Hi, everyone, and welcome to DevOps Global Summit 2022. Excited to welcome everyone here. Hi, Ksenia. Ksenia is our community manager, and she helped us to come together, brought all the speakers from various companies, and thank you everyone who decided to join us as speakers and as program committee, and who helped us with topics. And thank you everyone who decided to participate as an attendee, and thank you for purchasing the tickets. It means a lot for us because this actually helps us to operate and to organize these events. Thank you once again, everyone. And how are you doing, Ksenia?
I'm pretty fine, thank you very much. It's really cold outside here, and we're preparing for Christmas time, as I can see from your t-shirts.
It's so cold in my apartment, so I decided to
I have the same.
throw
Yes.
in a Christmas t-shirt. Yeah.
Yeah, guys, please tell us know where are you from, because it seems to me that it should be cold there too. And yes, actually, I wanted to express my huge thanks to my program committee too, because these 9 amazing professionals who dedicated their time, their energy, who directed us to create this event. And so in the result, we'll have around 27 talks and 30 speakers from 12 countries. So yeah, it's a real global event. So yeah, let us know where you're from too, because we need to check how global trend is now.
Yeah, right in the chat. And yeah, once again, we want to remind you that we have the 2-day format. So the first day is totally free, so you can share this link with everyone you know, with everyone who is aspiring DevOps or who's already practicing. So just throw it in your social media. And also we have a second day, the professional day, with very practical talks, and you can get today a special discount for this event and for the upcoming as well. And Ksenia is going to tell a little bit more about that, about the promo code. And yeah, so, and also we're going to have some promo codes for another events, for software architecture, if I'm not mistaken, and I believe maybe for the QA, I guess. Yeah.
Yeah, it will be a lot of discounts today, actually. So please stay with us.
Awesome. And yeah, so Ksenia, a couple words about the discounts and how everyone could participate in this and grab himself a discount or herself.
Yeah, actually, we prepare a great discount for the next DevOps event, which we'll have in April next year. And just hurry up to take your early bird ticket, because the discount will be relevant only for the next 48 hours. Cool. And also, we invite you for our Worldwide Software Architecture event that we'll have on November 15th, 16th. I'm sure it will be relevant for a lot of people from our community from DevOps. So I hope you like it too. And yes, it's just a couple of weeks left. So join us there too, please.
Yeah, and also for the QA, if you're interested in QA Summit, we also going to have a discount for the QA engineers, because I'm pretty sure on DevSecOps, QA Ops, we have some engineers who are on the intersection of those roles. So yeah, so expect this promo code to pop up somewhere in the chat during the course of this event. Yeah, and I guess we want to invite our introduce our first moderator. Who's going to be the moderator for?
It will be Chanel Choksi. Yeah, he will join you just in a minute. But now I would like to take my couple of seconds just to tell you that usually we outreach thousands of people actually to find out the good speakers with the relevant content. But if you're sure that you have something to share actually, and you want to join us as a speaker or program committee or moderator for the next DevOps events, architecture, or any of them we'll have in the future, just find out our call for papers forms on the website. Yeah, and we'll contact you. Because it really makes sense to create good content for this amazing community each year, even a couple of times a year. So yeah, please join us. And don't forget to like this video and subscribe. Let other people know about such events like Geekle does. Thank you.
Awesome. And I guess we're going to throw a CFP form link in the chat today also. So if you think you can contribute something to this sort of event, welcome. Please join us. Okay, I guess without any further ado, we'll invite Chanel to the stage, and and let's start.
Yeah, do not forget to leave some comments and questions to speakers. Good luck. Hope you like it. Bye.
Bye.
Hello, everyone. Good evening, good afternoon, good morning from wherever you are from the world. I hope you can listen me better. So I think it's a first day, first show. So we have got the DevOps conference starting just now. So we have got the speaker from Switzerland. I think it's everyone's lovable country. So the speaker we have got is Michelle Ruiz. This topic she's going to cover is she's a senior software developer at JFrog. The topic she's covering is DevOps for Java developers. Are we there yet? So I'm going to introduce Michelle on the stage. So just a second.
Yes. Hi. Thank you. Thank you for having me. Yes. I'm usually in Switzerland. Today I'm in Morocco for another conference.
Okay.
So it's warmer here.
Okay. So is that your presentation?
Yes.
Just that one, right?
Yes.
Okay.
Perfect.
So are you excited for the talk?
Very, very much. I mean, the DevOps is super important for all developers. For Java developers, it's also really, really important.
Okay, so I will give you the stage, and the stage is yours now, Michelle.
Perfect. Thank you. Thank you very much. So I'm super happy to be here at DevOps Global Summit 2022. My name is Ixchel Ruiz. And as Shahil was very kind to introduce me, yes, I am from Mexico. I live in Switzerland usually. Today I'm in Morocco, so a warmer weather. I work for JFrog. I'm a Java champion, and I have contributed in some books, for example, the ones below. And I'm part of several organizations, like, for example, the CDF Foundation, the OpenSSNCF. So I love open source. That is what I like to do. My latest book, the one that I contribute with fellow writers, is this one, DevOps Tools for Java Developers. So this is a topic that has been in my mind for the last months of years. So let's start. DevOps and Java. Let's start with the DevOps part. So this is the State of DevOps report prepared by Puppet that was for 2021. And in it, there it says really interesting things. So regardless of how we define DevOps, today, thousands of teams now are using that methodology. So we have the ability to deploy software more safely and more quickly than ever before. And we move from being able to deploy it only a couple of times a year to multiple times on demand. So this report has been out for several years. 2011 was the first one, but since 2013, there was a clear relationship between true DevOps practices, the combination of people, culture, with high performance outcomes. For example, organization practicing DevOps consistently reported more frequent deployments, shorter lead to time to change, lower change failure rates, and faster mean time to recover. These 4 metrics don't encompass all of DevOps, but they illustrate the measurable concrete benefits of pairing engineering expertise with a focus on minimizing friction across the entire software lifecycle. They also have a direct impact on business outcomes. Organizations that can deploy on demand and have shorter lead time to change create comparative advantages by delivering solutions to their customer faster. Shorter mean times to recover and lower change failure rates create more stable systems. So let's see a really good example about implementing DevOps in a large organization. This report was published in 2018, the EAAA software by Barry Sanders from Fannie Mae. This is one of the largest companies in the US, and here the author described the amazing journey that Fannie Mae undertook during its DevOps transformation. This transformation was motivated because Fannie Mae needed to adjust its IT capabilities to meet the requirements and the pace of rapid evolving mortgage market. This is right before the boom of real estate. Well, if in 2012, Fannie Mae had only 10 teams using Agile-like techniques. The releases took 9 to 18 modes. Provisioning of environments took 2 to 4 months, and quality was not consistently measured. Fannie Mae's IT department was a complex technical polyglot ecosystem composed of 461 applications, several hundred utilities, and almost 18,000 open source components. So that was quite a challenge indeed. So in 2016 and in 2017, when they actually undertook this transformation, they were able to create an internal software supply chain with automated handoff between functions to reduce delays. Teams performing frequent scans coupled with the full spectrum of Agile DevOps technologies average 30 to 48 improvement in their total quality index. With outliners, the really good teams, almost as high as 70%. An average of 28% productivity gains was achieved by teams that implemented repeatable Agile practices, automated structural quality analysis, test automation, and consistent use of the DevOps platform for continuous integration and delivery. In comparison to 2012, Fannie Mae achieved 21 times more than 19,000 more builds per month with half the previous staffing while improving quality. So these are the results that upper management and the entire organization are looking for. So that's why it's so important for them and for us to start with our DevOps transformation in the different organizations. But that's at management level. So let's see another compelling reason: jobs and salaries. So the average salary, this is the average salary for a DevOps engineer in Germany, it's 58,000 euros. The average software engineer salary, again in Germany, is 54,000. So they are better paid DevOps engineers than software developers. The other comparative that I usually use is the average development operation DevOps engineer salary in the US is 98,000, while the average salary in the US is 88,000. So again, the trend continues. DevOps engineers are better paid than software engineers. So there is something there. Now, the two topics, DevOps and Java. What about Java? How are we there? How close we are, how far away we are. So we build a lot of software in Java. Java is one of the most popular programming languages out there. And when we are building either a library, a module, an application, whatever like the scope of the software that we are developing, the entire process is an iterative process from development, operations, and runtime or execution. So what we are noticing is by increasing the number of feedback loops between these phases and bringing important concerns early in the development process. Like, for example, if you are already following the DevOps methodologies, every single time that we release a new version, you are adding more valuable features or improving the code. You know that this process can be totally automatic, with automatic hands-off, with automatic testing, with different kinds of dealing with the releases, promoting releases inside different development instances or environments. So here is when I always start talking about DevOps, DevSecOps, shift left. For those that we are not so clear about these concepts, I will go super fast here. So the DevOps movement started in 2007, 2008, and it was because the software development communities raised a concern that the level of dysfunction between operations, the operation teams, and us was super high. So we were creating bottlenecks where they shouldn't be. There is a book that I can recommend to you. It's the Phoenix Project. It's a dated book, but still introduces the story of DevOps in a kind of a novel. It's actually a novel. So it's an interesting reading. If you have the options to read it, please do so. It's interesting. So the DevOps culture, it's about increasing transparency, communication, collaboration, and across different teams, and share responsibilities. No longer I built it, you deploy it, but I can build it and I know how to deploy it. Even if I'm not going to reach production environment, I should know what does it take to be there. Because we don't have this kind of information about the runtime, the production or production-like environments, we can make decisions about our software, what to expose, how to expose it, what are the best techniques, what should we expose when we're talking about observability and and monitoring. And we are always thinking about how to make this process as automatic as possible so we can release without any worry on a Friday night. Well, what is then DevSecOps? Well, DevSecOps is only the idea of applying more security during our software development process. So what are they promoting in DevSecOps? We're promoting to start using different kinds of applications, to start looking for different kinds of issues. For example, static application security testing. This is like your code smells. We will look for known weaknesses in secure coding practices. Are you pushing your user and password for even your database testing database? Are you pushing some credentials, some secret that should be secrets? So things like that, like actually working against us when we're developing software. The software composition analysis. This is software that detects software components, open source or third library parties, and check and identify any associated vulnerabilities. These two, the SAST and the SCA, complement each other in terms of vulnerabilities. 80% of the code out there depends on open source libraries. So it is important that we have a good overview on the versions that we are used and the quality of the software that we are adding into our projects with dependencies and third libraries. The dynamic application security testing, this scans applications at runtime. This enables an outside-in approach to testing applications for exploitable conditions that were not detected in a static state. Again, many things can change when your application is running, from lazy neighbors to an infrastructure that maybe is not what you assume it was going to be. So it is important to monitor and to check and to test that we are behaving as expected, or if there is a problem, we are also behaving in the most correct way. The other one is the web application firewalls, which is monitoring traffic at the application level and detect potential attacks and attempts to exploit vulnerabilities. Container image scanning tools that continually change our container images with the CI/CD pipeline and in container registries. Most of our time, so we sometimes, for example, in JavaScript, we are creating our own container images to speed up our development process. So sometimes we're consuming published images, sometimes we're consuming not so public images, but we still need to check what is inside there. So we're going to show you some tools that will help you go really drill into your container images and check what is happening there. The cloud security posture management identifies misconfigurations in the cloud infrastructure. Now that most of our software is being deployed in different cloud providers to increase the resiliency of our software, well, then it is important that we have an uniform definition of our rights, permissions, and identities in the different cloud providers. And finally, shift left. Shift left, having said all that before, is bringing testing and security measures into code development as early as possible. No waiting until Q&A gives us a report of all the known issues or found issues. Or no, it is as soon as we can get them. So, testing and security. That's it. But, and this is a great but, nowadays we sit down at the overlap of something and architectural styles, which introduce the idea of multiple service. So, and probably you know what I'm talking about, microservices. In the last decade, a lot of companies had started or had totally embraced this style for building enterprise applications. Or at least, I'm sure, everybody has been tempted at this stage. So this is the definition by Martin Fowler, an approach to developing a single application as a suite of small services, each running its own process and communicating with lightweight mechanisms, built around business capabilities and independently deployable by fully automated deployment machinery. And this is the other interesting part. They may be written in different programming languages. So the challenge is improving the quality of the software that we're building and releasing more valuable features in the next release are multiplied, because now we have components that can have their different programming language and can have their different software development cycle. So that is quite interesting. And all these challenges occur from requirement specification, documentation, architecture, testing, security, automation, to actually sit down with different teams that are taking the lead on different components and try to discuss what is the compatibility matrix and the APIs for communicating between different services. So for one side, DevOps is going to improve our development cycle, is going to increase a little bit the quality, reduce our response times, so many things that it's going to allow us during our software development process. And on the other hand, it's just in time for microservices, because microservices are increasing all these challenges. So when people ask me, should we consider moving to microservices, even if before I sit down and discuss their business solution, their business situation, is like, what is your development methodology? If you are not embracing DevOps at this stage, don't even think about microservices, because microservices without an Agile and DevOps methodology, it's going to be incredible, difficult challenge, because you will have a different or increased amount of micro, mini, or small services. Let's not go deep into the definition of what is a microservice, what are the boundaries, how loosely coupled they are or not. But they are there. They may be there. And as I said before, they can be with different languages, evolving at different rate as a whole different product. And they can have different levels of dependency between them. And of course, they have, or they can change their API contracts. So we need tools, and we need really, really good tools. So this is why I like to talk about my favorite tools that will reduce the stress in our developer lives. So for example, the first one that I'm going to show you is Freiberg. If you have heard the Pandabot, well, think about Freiberg, the big brother, like the one that can solve you a little bit more things. So this works for GitHub, GitLab, and Bitbucket. And the good thing is it has two ways of working. The first way is like whenever there is a pull request, Freiberg will scan that particular pull request, will trigger a security scan. If nothing happens, it's nothing there is no problem there, then it will be green and will say, yay, it's perfect. If there is a security vulnerability, then it will show you the severity, the impacted package, the version. If there is a fixed version for this specific vulnerability of this application library, what is the component affected, and even sometimes it's going to come with reports, the security report for our JFrog security team. And one of the important things about this is that you can use your free tier instance. What does that mean? That if you go right now at JFrog and go start for free, you will get a free tier. That is something that you can keep for as long as you want. You configure Freiberg in your GitHub, GitLab, Bitbucket repository, and it will start checking every single time that you have created a pull request. It will show you this particular report. And the other, because I said it has two modes. For example, if regardless, for whatever reason, you decide to merge that pull request that is bringing a known vulnerability in your code, fret not, fear not. Freiberg will also create automatically a pull request to upgrade or modify the version to as a fixed version. So then it's going to be even easier to keep those versions. Why did I say that this was the big brother of the Pandabot? Because at this point, you should be thinking like, that sounds so much as a Pandabot, Ixchel. What is Freiberg giving me extra? Well, the extra, as I like to say it, is the watches. As a Java developer, I have encountered that too much information sometimes is less helpful than the important information. So I was discussing with people about like, what do we do when we check or when we see a security report and we have thousands, hundreds of vulnerabilities? First of all, we felt overwhelmed because that's a lot of vulnerabilities displayed. Second of all, I have my Jira ticket and I have to deliver that feature or I have to ship something really fast. So where do I get that budget? Like, which one should I start working first with? And these are questions like, as a software developer, of course you can pose them, but it's not you who decide how to invest time, how to invest the project resources. So somebody at the company level, at the organizational level, at the team level, has to come up with a policy. And that policy in the JFrog platforms are watches, because we define what triggers, what filters to apply. So when you are using Frogbot and you already have a watch defined by your organization or your own definition of watch, what to watch, then you can limit the scope of the information that are coming back and really target to the important things that matter to you, to your organization, to your project. And that is awesome. Because if everything has top priority, nothing is top priority. The second tool I want to talk about is the JFrog Docker extension. Since some versions now, the Docker desktop has now the ability to use extensions. In this particular one, we created our own extension and follows the same idea. It's going to scan your Docker image, but it's going to scan your Docker image really to the center of it. It will go into zip files. It will check zips. And the same thing I talked about with Frogbot, about the watches, happens for JFrog Docker extension. So again, instead of having 43, 1,000, you are going to have as reports what your organization, you or your project man or your project has decided that it's important. And finally, instead of waiting for a pull request, instead of waiting for you to build your Docker image, this is happening at your development environment. This is happening while you are writing the entries, the dependencies into your project. This is IntelliJ IDEA because that's the IDE that I use. This is a Maven project. It's very trivial. And here I'm showing you how while by adding a specific version, known version, we know, we survive this issue. Anyway, it's going to show me at that point what is happening, what are the vulnerabilities, etc., etc. So these three tools about security, use them. Honestly, use them. We need to have more secure software. We need to react as fast as possible. We need to have the information at our fingertips as soon as possible as developers. And I mean, I'm a consumer of software every single day of my life. I'm a user of technology every single day of my life. So my first and foremost worry is that we're building secure software, reliant software, software that actually improves my life and the life of other people. So one of my main concerns, security. So please, please, please use it. Okay, the second topic, remember we were talking about microservices. And in the Java world, we adopted it with gusto. Oh my God, so many options. Microprofile, Micronaut, Quarkus, Helidon, Spring. so many frameworks, Drop Wizard. And this is good because Java, it is one of the most mature ecosystems out there. The Java platform is an amazing piece of machinery. So I will show you and will really briefly talk about my favorite testing libraries. And this is our testing libraries, very well known, or I hope they are very well known. And I will go with the highlights of what I love them. So again, tools. The first one I want to introduce is WireMock. I love WireMock because it has a standalone version. And the two things that I love about, well, I love so many things about WireMock, but the two things that I mentioned at the beginning is that you can use them with Java, or you can use curl to introduce simulate faults, stateful behavior. So when you are creating and mocking your HTTP-based APIs, this is effective, flexible, quick, and very robust way of doing it. And what I keep when I go really, I have some sessions about the WireMock and how to leverage like amazing examples of WireMock. One of the things that I said is not only I use WireMock for testing, but I create a Docker image with a standalone WireMock with some of the services that I'm simulating, even with faults like random delays, and I ship it to my front-end development team. Because then as soon as we're discussing the API contract, I can generate the services even without me writing the code, the backend code. And even I can send them like random delays. So they start thinking about, what is your web component showing if the backend is slow? How are you reacting to faults? How are you reacting to errors? So these are things that I also push into my web development team. And they are happy because we are, first of all, they don't have to wait for me. And second of all, we enrich our experience with happy paths and terrible paths. So WireMock, have a look. And something important about version 2.32 and last December is that they introduced the ability to run WireMock without needing HTTP server. So they're thinking more about the serverless deployment model. So in the past, it was impossible to do this with WireMock app, but relied on internal APIs, which will break as soon as they start, or we all start with Java modules. My other library that I totally love, rest assured is for people that have used Groovy with a G programming languages. They have Node.js and Kotlin, but Groovy was first, but I won't go into that. They have noticed how trivial, delightful is to use or parse XML or JSON. So with this, you can see how easy it is to specify request data, path parameters, cookie headers, multi-value, and it supports authentication out 1 and out 2, and has a Spring support. In version 4.5.1, which was released in February 11, 2021, that's the most recent one. But something notable, in version 4.5.0, they upgraded from Groovy 3.08 to 3.09. Another of my awesome projects, test containers. So test containers is a Java library that supports JUnit tests, providing lightweight, throwable instances of common databases. For example, if you're using the Oracle database, there is a Docker image for that, and it will run fast. Well, I will go more into the details. Oh, I have questions. Yes, there will be a Q&A later on. But anyway, and the one thing is that anything that you run in a test container, in a Docker container, can be instantiated during your test. The test containers team has done an amazing work. For example, in the past, I will use Docker Compose that I have to define my ports. I had to define so many things. It was crazy. And then I couldn't run them in CI/CD because there were clashes. And if the test died, then I have some Docker containers. Test containers solve that. They create the test environment and they take it down, no lingering zombie containers over there. They also have help signals, so I don't have to do the, oh, are you there? Are you there yet? Are you there yet? Can we populate your database? No, they take that on their own. So that is awesome. The other thing that I want to talk about is that in version 1.6.3, which was released on January this year, probably they have released more things since I last checked, but they introduced the K3S module. That is, now if you want to test your Kubernetes components, you can do it with test containers. So they bring the K3 module to spin up the K3S lightweight Kubernetes inside a container. So we are there for microservices and testing with test containers. But what is the problem about testing? Even if we have the healthiest number of unit integration contract, that is consumer or provider test, UI, end-to-end, REST API, acceptance, exploratory test, we are still in a controlled and well-defined world bound by our imagination and assumptions of what could possibly happen in production. So we are in that tiny, tiny space of our pond. We don't have a real clear, because we are bound by us. And out there, things may be completely different. So our view of production and testing can be totally different. So we're left with testing in production. I know, sounds so wrong. We shouldn't say that. Let's change it to, we shall observe closely our services in production and understand better the system state using a predefined set of metrics and log. So monitoring in production or in any part of our staging environments should let us detect failures. So what is monitoring? Monitoring is crucial for analyzing long-term trends, provide information on how the services are growing and how they're being utilized. And observability, on the other hand, they are complementary. They're not the same thing, which originated from control theory, measures how well you can understand a system internal state for external outputs. Observability uses instrumentation to provide insights to add monitoring. An observable system allows us to understand and measure the internals finding easily and figure out the cause from the effects. So observability, it has three pillars. Traces. Traces is track the progression of a single request. That is a trace, and it's handled by services to make up an application. A request may be initiated by a user or an application. Distributed testing is a form of tracing that traverses process, network, and security boundaries. Remember, now if you are already embracing micro, mini, whatever level of service, and several servers out there, so now it's more difficult because so many things can happen at the same time, so many versions. So it is difficult to know what is happening out there. So that's why we need observability and monitoring. And the traces will help us check what is happening in a specific set of boundaries. So, and this is a trace is a set of, or a tree of spans. And a span is each unit of work in a trace. Spans are objects that represent the work being done by individual services or components as it flows through the system. Metrics, we are more used to metrics. It's a measurement about that service, captured at runtime. It's a snapshot. Logically, the moment of capture in one of these measurements is known as a metric event, which consists not only of the measurement itself, but the time that it was captured and associated metadata. Logs. Logs is the third pillar, and we have been working with logs for our entire life. Because logs in monolith systems, it was the entry in a specific file which had a timestamp text record, either a structure or unstructured. I recommended this structure with metadata. And so now we use these three ways of acquiring data to know what is happening with our application. And again, I'm going to tell you about tools for observability and monitoring. So as I said, I love open source. I love standards. Why? Because the standards will help us to avoid vendor locking. And as a developers, if we learn the standards, then we have a better chance of understanding the different implementations or the different flavors from different vendors of said standard. So if you are already in your path to cloud native, go to the Cloud Native Computing Foundation. So they seeks the adoption of technologies and techniques, both at the same time. So they have a very sustaining ecosystem, open source and vendor neutral. So the technologies, they want to run scalable applications in modern dynamic environments, private, public, hybrid clouds, containers, service meshes, microservices, immutable infrastructure, and declarative APIs. The techniques that they are trying to promote is to have a loosely coupled system that are resilient, management, and observable with robust automation. And they want engineers to make high impact changes frequently and predictable with the minimum toil. So you probably are already using some of their tools. Kubernetes was the first one project and graduated from the CNCF. If you go there, you can see all the different projects that the CNCF has inside their landscape. You will see their information like the bio. And for example, if you're looking for tools into observability, probably you know Prometheus. I urge you to, yes, of course, use Prometheus, but also have a look about open metrics. For example, for tracing, if you're in the Java world, maybe you have used Zipkin, or Jagger is more common nowadays, but it was also from the Go world. And I totally urge you to have a look at OpenTelemetry. For logging, FluentD, Grafana, etc. But if you are used to Prometheus, I urge you to look at Grafana Loki, is because it's so similar to Prometheus for monitoring. Loki is for logging. So Prometheus was the second project to graduate from this. This was built in 2012, and then was the second project accepted into the CNCF, and the second one to graduate. And it provides a rich multidimensional data model, a concise and powerful query language called PromQL. And it has more than 150 different integrations with systems. Open Metrics is an open standard for transmitting cloud native metrics at scale. It was created inside the CNCF in 2017. And now it's used by a lot of companies. So it's a wire format independent of any particular transfer for that format. And the format is consumed on a regular basis, and everything is a numerical value: counts, current values, enumeration, and Boolean states. And OpenTelemetry, this is the one that I urge you, because this is more than just a new way to visualize data across application. It's a collection of tools and features designed to measure software performance, and it's an amalgamation of two open source projects, OpenTracing and OpenCensus. So even if it's very, very young, as it's the consolidation of two previous ones, one was OpenCensus by Google, and if you were using already some of the Google technologies, probably you have noticed that they have changed from OpenCensus to OpenTelemetry. And this is the landscape of the CNCF. But if you feel overwhelmed by all the choices, don't worry, they have the trail map. In this trail map, they will help you marshal your thoughts. Think about your containerization solution, your CI/CD, your orchestration, your observability, your service mesh. Think about your networking, your distributed database, your messaging, and containers runtime and software distribution. And this is it for me. We made it to the end. Thank you very much. I'm always open to questions, feedbacks, and if you actually use that QR code, you will be making me a favor. I cannot hear you, Shahil.
Oh, sorry.
I can't hear you.
So hi, sorry for that. I was muted. Thank you very much, Michelle, for wonderful, insightful talk. I hope everyone enjoy it. So I think we have got two questions for you.
Okay.
So just a second, I'll show it one by one. If anyone has any questions for Michelle, I think type it down so we can ask her straight away. So the question is, just a second.
For DevSecOps. Okay.
Right.
Yes.
So which tool do you use for DevSecOps? That's one of the question.
Yes, I went back into the in the slides. I showed that there are several, like 6 different categories of different tools, like static code analysis, third parties, when you check your container registry, when you check like networking traffic, etc., etc. So it depends on which part of the security process of the entire application runtime you're. But as developers, I usually use static code analysis that also check my code smells, good code practices. For this, there are several ones. For example, for code coverage, use Jacoco, SonarQube. For security, on the security part, use X-Ray from Artifactory, obviously, or you can use as the ones that I mentioned. Freiberg if you're using GitHub, GitLab, or our own instance too. You can do Java audit, npm audit. Several different programming languages have the security audit solution.
I hope everyone got the answer. The second one is, and I'm just showing you the second question. What about scanning the containers at deployment time, not only at pull request? I find that's the most important time to do it.
Well, I certainly will do it as often as possible. But let me tell you, when you are creating already something and publishing, And if you notice at that point that you are introducing some vulnerability or you are consuming some vulnerability dependency, in my opinion, it's too late. It's after the fact. So you have to go back to your board, you have to go back and do a new iteration and change either your dependency or improve your coding practices to eliminate that known vulnerability or eliminate that. So for me is really at development time, and for sure before publishing your release version of the whatever you are creating, and for sure also test at pull request. But this is to prevent any man-in-the-middle attack. What if you are consuming something that you think you're consuming, but that's not true? But so development, release, publishing, and when consuming.
Okay, I hope got the answer. The another one is, the question is big one. I'm just showing you. So just a second. Yep. So this one is, yeah. So what I see for Frogboard supports only pip and Python environment package managers. Are you aware if there are any plans to support which is slowing to the to be a standard?
Can you send me a tweet so I can answer you back? Because I will ask our development team. I know that the roadmap is improving a lot, like in terms of environments and package manager support. But I wouldn't like to tell you something that it's not true. So I can follow that up with you and the team.
Okay.
Yes, this is the size team in practice in DevSecOps. Excellent question. So even for meetings, for development teams or services, it all depends. I was a consultant for most of my life, but I can tell you a number. And it's the definition is a team of 6 to 7 person can handle, and this is area statistics, can handle very nicely 5 to 7 services. That is like microservices. So I would say that for meetings, for different roles into the different development teams, it is 6 to 7 people usually in a development team that is sufficient enough for effective communication and separation of roles and responsibilities.
Okay, I think that was the last question. Unless anything coming up in a comment, we'll wait for 1 minute. I think that's it for now. I think there is no more questions from the audience. So thank you very much, Michelle, for your time and wonderful talk. So I think it was the best effort you have done ever. I hope everyone enjoyed it. So thank you very much, Michelle, and I will offload you from the screen. So we are going through the next sessions. So just a second, I'll take your screen up. Just a second. Hello everyone. So that was the Michelle's presentations, and now we have got the next one is Jordan Assouline. He's from France. There is a customer engineer applications, and the topic he's going to cover is DevSecOps, security tools integration into your pipelines. So I'm going to introduce Jordan on the stage. So just a second. Hello,
Hi,
Jordan.
everyone.
How are you doing?
I'm fine. What about you?
I'm very well, thank you. Are you excited for the talk?
Always.
Yeah.
I hope you are also exciting about these talks.
Yes. So let me share your presentation on the screen. Okay. Are you ready now, Jordan?
I'm ready.
Okay, so I'll.
Okay, so
now.
Oh, it's okay for you? Yes. So hi everyone. I'm very happy to share this time with all of you to talk about DevSecOps. Today, we will talk about DevOps and DevSecOps in a quick introduction. I will share with you the tools and the main steps we will see later to analyze your Python code, your Docker images and Kubernetes objects. We will have a specific focus on how we can fix vulnerabilities and bad practices on a Docker image. And I will talk about few other tools to scan your Git repo to find secrets, for example, or to do DAST on your Kubernetes clusters. And finally, I will share a way to secure your Docker and Kubernetes hosts. All the tools I'm going to talk about are available for free. You can therefore easily implement them within your own pipelines. So I'm Jordan and I'm French, as you can hear with my perfect accent. I've been working for about 10 years in innovative technical topics involving DevOps and DevSecOps. My main activity during my years as a consultant was showing that helping security works much better than blocking security. And today I'm custom engineer at Google. As a custom engineer, the CE provides technical support to customers about their cloud migrations, their applications architecture, and the achievement of their business and technical goals. I'm also teaching on Udemy about Linux, DevOps, and cybersecurity in French courses. But enough about me. Let's start with a little introduction to what DevOps and DevSecOps are. Sorry for that. Okay. So then we can all speak the same language for the rest of the talk. DevSecOps logically has its origins in DevOps and its 5 fundamental pillars: the culture, the automation, the lean, measure, and sharing. And one of the most interesting thing about DevSecOps is when it's integrated within the workflow and the CI/CD pipelines. This is the case when it's necessary to check the security of the code used on production. We can talk about this with the famous security by design, or the security of images of the containers used within the Kubernetes infrastructure or even on cloud environments. I used to say that DevSecOps is simply DevOps done in a good way, with the security as part of the development and releases processes, and not as a downstream step after the development itself. So DevSecOps will focus on security aspects on each of the DevOps pillar: security culture, automation of security-related tasks, limitation of security-related bottlenecks, very, very important thing, measuring the effectiveness of security actions, of vulnerability of your assets, and finally share with all the good practices, the result of security audits, and support dev and ops to improve their security practices. In DevSecOps, the most important thing is security is everyone's business. So we talked about DevSecOps, but we will also talk a lot about continuous integration pipelines in this talk. Continuous integrations refer to the stage of the development cycle during which the code coming from different team members and the different functionalities are integrated together. This improves code merge, code build, basic functional test execution inside an ephemeral environment, like with containers, for example. When several developers are working on the same code at the same time, it is necessary to implement solutions and features to prevent incompatibilities and also malfunctions from occurring. Basically, the developer will start here by committing the code and pushing the changes to the code repo. It could be GitLab or GitHub, for example. The repo will notify the continuous integration server that new changes have occurred. The code is then built by the server, the continuous integration server. It could be Jenkins, it could be GitLab CI, for example. And once the build has run correctly and the code runs smoothly, various tests can be performed. For example, unit tests, API tests, integration or system tests, and security tests, of course, for example. We can see in this slide a very simple way to push our code to a repo, then activate a CI server to check tests and store artifacts, images, or Kubernetes manifest in a repo or in a kind of global repository, and to deploy it in specific environments with Docker and Kubernetes, for example. We can have some security actions on each steps. For example, on the code repo, we can do a secret scan or static security analysis on the code when the developer commit or push his code. Then a dependencies or software composition analysis check with the CI server. Also a SAST security, static security analysis, and a SCA software composition analysis check on the artifacts, on the images, on the cube objects, and finally, the dynamic security on dev, production environment, and so on. Of course, I have not enough time to show you how to do every steps, so I chose to focus on few of them. Let's start by seeing the different tools and the different stages we will cover in this talk. First, we will talk about the code. We will see how to check the code style, how to lint your code, and how to check code and dependency security. In a similar way, we will see that it is easy to implement lint, image builds, tests, and security scan on our Docker images and Kubernetes objects. Finally, we will see how to scan your repo to find secrets and how to secure your Docker and Kubernetes hosts with scans. Remember, every tool are free, not open source or not free like in the free world, but you can use it without pay anything. We will therefore focus this talk around Kubernetes, Docker, Python, and using the GitLab CI system to perform our continuous integration. Unfortunately, I'm not a developer. My coding skills are quite limited, but I had to work for many years in environments that used Python. It is therefore on the basis of this language that I will present the different stages and tools to you. Here are 4 interesting steps to implement in your pipelines. It is, of course, possible to add many other steps, but these basic steps are enough for our talk. We will see how to check the code style, how to lint your code, and how to check code and dependencies security. Here's a very simple Python code to check if your password is on a worst password list. It's not very important, just to show you what I will use for the next tools. So first, when you are talking about code and security, it is important to define the code standards. That the code standard that we want to use inside the organization. For example, for Python, there is PAPE 8 and there is Flake 8 that you can use. For each tool, I will give you the link to the presentation. Then you can go to the official documentation, and you also have here a link to an example that will take you to GitLab to see the result of the corresponding job. As you see, it is quite simple to check the syntax of the code, whether for PAPE 8 or Flake 8, in a few lines. Let's see what it looks like. Here, you can see an example of a PAPE 8 Python simple style code checks. As you can see, it's mostly about blank lines, indentation, comments, or lengths. Of course, you can enable or disable some checks according to the organization code style policy. We will then perform a security test on our code to check that it does not have any major vulnerabilities. To do this, we can use Bandit, which allows a static security analysis. I gave you the link to the Git repository associated with the project in the presentation. You can also see on the right an example of using the tool with GitLab CI, whose job means here a new group of jobs named security, and here a job named security code, using the Python Docker image to execute the following commands: execution of the pip install bandit to install the tool, command before launching the job properly. And here, execution of the command bandit-r passwordcheck.py, allowing to launch the security analysis on the code itself. And in the last line is about allowing job to fail and to continue the pipeline. So here we are in the screenshot, the job run correctly, not detecting any potential security vulnerabilities, but you can see there are 22 lines of codes, and also the vulnerabilities are shown in low, medium, and high category. Then you can say, okay, if there is a high vulnerability, it's better to focus on this one than a low one. So we tested the style and the vulnerability of the code itself, but other vulnerabilities can be inside the dependencies that we use. Safety is a tool that allows you to do a lot of things. But here I'm using it to check dependencies vulnerabilities. For this, safety looks at the requirements.txt to compare the libraries, Paramiko and Ansible, with its own database, the safety database, and check if the versions do not have any vulnerabilities. Here, of course, I have chosen specific packages with old versions, so that the tool shows us an interesting result. We therefore see 13 vulnerabilities with a link to the CVEs, allowing us to know a little more about how to correct your code. And what is very interesting about this thing is we had an example of a code, a Python code, without vulnerabilities, remember, but using vulnerable dependencies. So always check both. So we talk about the code, but today, especially in the microservices culture, we are using Docker images. Organizations are quite aware of code security, more or less. However, many people believe that as long as the code is integrated via a Docker image, security is not a main goal. Okay, that's why I will show you how to fix some vulnerabilities on a Docker file sample, thanks to the tools I will show you. But a recent analysis of around 4 million Docker Hub images by the cybersecurity firm Prevagio found that 51% of the images had exploitable vulnerabilities. A large number of these were about cryptocurrency miners, both open and hidden, and about 6,000 of the images had malware. From Sneak and his State of Open Source Security report, they observed the following statistics regarding who owns container security and who actually practices it. 68% of users feel that developers should own the security responsibility of their Docker container images. I agree with that. 54% of developers don't do any Docker image security testings. That's bad. And only 15% of the users claim to test their Docker images for vulnerabilities during development. So I did a security scan on 4 Docker images, 4 very popular Docker images. It was Node, Postgres, Nginx, and HTTPD with a tool named Trivy, a tool we will talk about a bit later. And I found about 1,137 vulnerabilities for Node, 110 for Postgres, 123 for Nginx, and 91 for HTTPD. I use the latest tag for every image. I let you think about this, and if you don't trust me, never trust anyone. Do it yourself with the tools I will show you just a bit later, and try to redo the exercise for yourself. So, in a similar way that what we saw for the code, we will see that it is easy to implement lint, image build, tests, and security scan on our Docker images with GitLab CI, but you can do this with Jenkins, Travis, and so on. Here is a simple Docker file to build an image called my-nginx that respects the following base from Debian latest: installations of the package curl, nginx, and git, a creation of a user named user, and running the command sleep infinity. It is this Docker file that we will analyze with the different tools. First of all, the lint of the Docker file can be done thanks to hadolint. This tool helps to write Docker files according to the best practices specified on the official Docker documentation. Hadolint will perform an analysis of the Docker file to transform it into an AST for abstract syntax tree on which the check rules will apply. I like hadolint because it's one of the few tools that can lint directly on the Docker file rather than the image. Very, very useful in a CI pipelines. You can say that, okay, lint is not very about security, but I can say that's not true. If every developer used his own way to create image and quit his job, for example, do you think it will be always easy to take back every images if they don't respect a specific style. I don't think so. And it's a story of my life. So we see on the job of Hadolint, we see there are 5 problems. Okay. The first one is do not use latest versions. Remember, the Docker file is based on Debian latest. So do not use the latest versions, but rather a specific versions of an image. Rather than just using a simple apt-get install, like I did for Git, Nginx, and curl, always specify the version of the package to install. Remove apt-get lists after installing something to gain space, and avoid installing additional packages thanks to the no install recommends options. Prefer consolidation rather than putting several successive runs. Thanks to Hadolint, you can refer to the documentation on the website to understand which actions you can perform to solve these issues. Here, on the left, it was my initial Docker file, and on the right, the correct one. It is necessary, as far as possible, to always be specific, to be as specific as possible in all the fields of a Docker file. If we choose the latest tag, for example, we have a risk of having a different behavior of our image with the updates which are regularly released on Debian, for example. Whereas if we freeze the version, we know that there is less risks of behavioral changes, because regardless the updates, we will always use the same version. Here, for example, I'm going to use Debian in version 11.2 to fix the first issue detected by Hadolint. In the same way, it is also better to specify the versions of the packages to be installed. This is why it is necessary to add the following versions of the package: curl, Nginx, and Git. You also need to remove the apt-get lists and add the no install recommends options. So here, no install recommends options, and here apt-get clean and remove the list of apt. The last fix is about the successive runs command. Here we have 3 runs command that have changed by the end and the backslash you can see on the right. So we fixed our Docker file thanks to Hadolint. We are now going to add jobs to build and test our image, because build and test are part of the continuous integration. First of all, to build our image, be aware that is not natively possible for GitLab runners to run Docker correctly. For this, we must add the service docker dnd at the beginning. Then, once the image has been built, with this command, we will save it using the docker save command in the image folder that we created in the previous line. With artifacts here, we ask GitLab CI to export the contents of the image folder, which contains the my Nginx image, for future jobs. In our Docker image, we installed several different packages. Remember, curl, Nginx, and Git. We have also created a user called user. So it is therefore necessary to implement tests just to check if the curl here, if Nginx and Git tools are working properly. And of course, to check that the user called user has been correctly created. So we did a lint we build and we test our image. Now we need to focus about security itself. Docker is a good tool allowing you to perform security-linked actions to build more secure Docker images that respect all good practices. In our GitLab job, on the right, we load the my-nginx image created by the previous build job. In order for Docker to access this image, loaded in the GitLab runner's local cache, we need to share the /var/run/docker.sock volume between the hosts, the host is a runner, and the Docker container, which performs the security scan. Finally, by default, Docker returns an exit code of 0, which means that regardless of the vulnerabilities found, the job will always be in success. To return an exit code of 1 and fail the job, when warn or fatal alerts are detected, we have to use this option, exit code 1. I'm sorry, it's not very big, but when performing vulnerability tests on our my-nginx image, we found 2 warn types alerts, which therefore return a code of 1, letting our job in failure. These 2 alerts are: the first one, create a user for the container, and the second one, avoid latest tag. So I will fix this. Concerning the first issue, we need to create a main user from which all commands will be executed. However, remember that in the various tests we perform, like start service nginx start, we need root rights, especially for starting the nginx service, but not only. Indeed, a standard user cannot start, stop, or restart a service without obtaining even temporarily root rights. In our Docker file, we created a user called user, remember, at this line, okay? We still have to add a command allowing this user to temporarily have root rights to root access, if you prefer, to start the nginx service. For this, it is possible to use the sudo commands. But since this is not natively installed in Debian 11 image, the base image of our my-nginx image, we must also add the installations of the package here, specifying the version. In our Docker file, we will therefore add the installation of the sudo in its version and the access for the user to invoke root access temporarily using the sudo command in order to start the nginx service. And lastly, we specify the user called user as the default user for our image. So another security tool I like very much is Trivy. Trivy is a tool maintained by the company Aqua Security, allowing to do specific vulnerability scans for containers and its artifacts. It is particularly suitable for use in the form of continuous integration and presents few very interesting options for performing specific scans. In its official documentation, Trivy offers us several methods to use a vulnerability scanner. We will use a similar way that we did with Docker. Finally, by default, Trivy returns a 0 exit code, which means that regardless of the vulnerabilities found, the job will always be in success, same as Docker. To return an exit code of 1, when a critical category alert is detected, we use the -- exit code 1 -- severity critical option. When we perform the vulnerabilities tests on our Docker image with Trivy, we find a total of 14 critical vulnerabilities identified. Trivy tells us the CVE numbers as well as the versions from which the corresponding vulnerability have been fixed. We are therefore going to add to our Docker file the packages whose update would fix the associated vulnerabilities. Here you can see dpkg, libc, libc6, and so on. Unfortunately, there are no patched version yet for the libd 5.3 and libexpat1 packages. So thanks to the previous updates, we only get 2 last critical vulnerabilities. I will show you in GitLab CI, okay, just right here, that you can have a pipelines looks like this with a code style I talked about at the beginning with Flake 8 and Pape 8 code, code security about dependencies code with safety and security code, for example, with Bandit, the Docker lint with Hadolint, Docker build, Docker tests, Docker security with Docker and Trivy, and the other tools I will talk about. So, for example, if I'm going to the Trivy test, I just have to click on it, and then I can see so one last critical issue on the job. For the Docker test, I fixed the issues, so I don't have any warning or critical issue on my test. So you can see it's very simple to use on GitLab CI, but you can also do this with, for example, with Jenkins or Travis. So let's go back to the slide and talk about Kubernetes objects. Here is the manifest that we will use in our pipeline. It is a simple pod with a container called web servers based on Nginx image. Okay, you can see it, Nginx image, and it's a simple pod. Just as we already did for Docker, we will see the tools we can use to perform lint tests on our Kubernetes manifests. This will allow us to know if we are not building a pod, a deployment, a replica set, or a service that would natively present security issues related to a bad configuration of the options and parameters available. For this, we can use the kubelinter tool, which was developed in Go language by StackRox. This tool was designed to analyze YAML file in order to identify configuration issues we need to fix for confidentiality, integrity, and availability of the Kubernetes objects that we will deploy on our cluster. One of the main things about kubelinter is that it is possible to configure the tool to include its own checks that will be specific to your company or your organization. For example, it becomes possible to check that the Docker images used in Kubernetes are indeed stored in a trusted repository, or that the names of the objects respect your company's naming conventions, for example. We can see 7 issues for your pod. I will show you directly on GitLab. Here, Oh, I already fixed this. Sorry. So we have 7 issues. The first issue is about a container web server is using an invalid container image, because here we are using the Nginx image, and we should specify the tag of the image. The second is the container web server does not have a read-only root file system and is not set to run as non-root. Also, container web server has CPU request of 0, CPU limit of 0, memory request 0, and memory limit of 0. But the main tool I used before deploy something with Kubernetes manifest is checkoff. Checkoff is a Python tool. It allows you to perform many vulnerability and misconfiguration scans in DevOps and cloud tools such as Kubernetes, Terraform, CloudFormation, and so on. It is an essential tool for those who want to perform vulnerability scans on all their code concerning infrastructure as code, but also Docker files and Kubernetes manifest. We can observe with checkoff that the tool carried out 77 checks, and that only 12 are indicated as failure. Failed checks appear at the end of the job with an identifier and a link to the documentation to learn more about this check, and especially how to correct or to fix our manifest to respond to these vulnerabilities. I won't show you how to fix all vulnerabilities because I don't have enough time, but these vulnerabilities are talking about service account tokens, about seccomp profile, about allow privilege escalation, liveness probe, readiness probe, capabilities, and many more. So we talked about Docker and Kubernetes, but I would like to show you more useful tools. Truffle.org is the first one, is a Python tool used to find secrets in Git repo, even in history and branches. In the screenshot here, you can see that it can find AWS secret token, for example. The developer added this token and deleted it a few minutes later. Okay, here you can see the miner and the miner. But we can still retrieve it in the history, as you can see just right here. You can't imagine the number of Git repo, even official Git repo, with secrets into the history. Dive is used to deeply analyze a Docker image as well as its different layers. Why we are doing this? Because it allows, for example, to check that the size of the image cannot be more optimized, or that the different layers do not contain sensitive elements. The last tool I will talk about is Falco. Falco is a tool allowing to set up events related to security on Kubernetes. If there is a violation of a configured security rule, a notification is sent to the user with the associated security level. For example, shell inside a container or pod, reading the /etc/shadow file, pod in privilege mode, and so on. So, even if our code, our Docker images, or our Kubernetes manifest are secure, if the host on which these different assets are executed is full of vulnerabilities, all the work done into our continuous integration pipelines will have been for nothing. So there are tools and notebooks summarizing all the security action that can be taken on a host in order to improve its security. Among these tools, you can rely on the CIS benchmarks. However, there are more than 250 dedicated pages, something like this, with the best practices, the best practice rules to implement for the CIS benchmark dedicated to the community version of Docker. Fortunately, some have already done a lot of work for you and for me, and have implemented all of these checks rule in turnkey scripts. For example, there is Docker Bench security tool. Its purpose is to check most of the good practice rules to follow when using Docker to deploy containers in production. So Docker Bench for security has been packaged inside a Docker container, which makes it extremely easy to use. All you have to do is go to the Docker host and launch the container with every important volumes mounted, like you can see here. It's in the documentation, of course. Be careful to adapt the shared volume according to the distribution you are using on the Docker host. Here you can see an example of the output of this tool. Very, very useful, Docker Bench security. You have the same thing for Kubernetes. KubeBench is a tool developed by Aqua Security. It allows you to check that all the check rules indicated in the CIS benchmark file are respected on your cluster. To run KubeBench on your cluster, you must first download a job file, just right here, then launch the job on the cluster, check that the job started and ended correctly, and to access to the results, type the command to view the logs of a pod. I would like to show another last tool, not specifically dedicated to Docker or Kubernetes, but Linux is a tool for performing a security audit on your Linux system, but it also works with other OS. To use this tool, you just have to run the following command: clone the repo, go into the folder, and launch this command, Linux audit system. Of course, you can launch the tool in sudo or as a simple user, but the result will not be exactly the same. You then have as a result the list of all checks performed by Linux, allowing you to set up actions to improve the security of your system. And to end this talk, I would like to show you the DevOps tools periodic table from digital.ai, where you can find a lot of DevOps tools available, including some security stuff, of course. The security stuff are in blue. Okay, you can see here. But you have also a lot of tools about package and artifact, about database management, about containers, and so on. So if you want to implement something, you can just take a look at this periodic table and see, okay, I don't know what is this tool, but maybe I can bench it on my own environment just to see if it's reaching my goals, maybe better than another one that I already know about the limitation. So I hope you enjoyed this talk, and you will try some tools I showed you. Do not hesitate to send me a LinkedIn invitation or a message if you would like to talk about DevSecOps or how you have implemented these tools into your own pipelines.
Hello, Jordan. Thank you very
Hey,
much for your insightful and detailed talk. I hope everyone enjoy it. So we have got a couple of questions, Jordans.
yes.
Okay, so just a second, I'll show you first one. So this one is, do you have tips for transforming organizations to adopt DevOps bottom up?
I have a lot of tips, but I know that there will be a couple of talk dedicated to this in the Global DevOps Global Summit 22. So I will let my colleague to develop and more detailed about how you can transforming organization to adopt DevOps.
Okay, I hope everyone got the answer. So the second one is, I think it's a link one, first and second one. So the first one of part one is this one. Suppose that you can use Git Actions and Jenkins. How would you split all the steps to optimize the continuous deployment process? That's a part one of the second question.
Okay, so Git Actions and Jenkins are working very, very well. You can use Git Actions to do, for example, all the steps about lints, about security checks, and so on. But for the continuous deployment process, you can use Jenkins. I know Jenkins is more a continuous integration tool, but you can also use it to do some continuous deployment process. Because I used it a lot in my previous job. So I would like to say one part about security, SAST, and dependencies, lints, so on, with Git Actions, GitHub Actions, and the part about more about continuous deployment process with Jenkins itself.
Okay, based on that question, there's a second one, the part two. Would you execute the same steps, all the branches, or only develop and masters?
It's interesting, very interesting question because it depends what is your Git workflow. If your Git workflow is about two branches, for example, a master one and a dev one, of course, you do not need to implement all these steps. Why? Because it takes time. And when you are developing something, you you are you don't want to wait so much time to see if it's okay and if you can go on with the next step. So all the thing I showed is more about the production environments, but you can just use few of them in the dev to win time for the development.
Okay, I think that was the last questions, Jordan. So thank you very much again for your effort and the wonderful talk and the presentations. I hope everyone enjoyed. Please feel free to connect with the speakers on the social media for any further questions or anything. So thank you very much, Jordan. Have a wonderful evening and have a wonderful sessions going ahead.
Thank you very
So I
much.
will
Goodbye.
thank you very much. Thank you. So we have got the next speaker is Ben Freiberg from Germany. He's a senior solution architect at AWS. So let me introduce him and put it on the board. Hello, Ben. How are you doing?
Hi, I'm good. Thanks. How are you?
I'm very well. Thank you. Are you excited for the talk?
Yeah, absolutely. Can't wait.
Yes. Okay. So let me share your screen on the board. Okay, so the time is yours now, and I will go off the stage, and all the stage is yours.
Thank you. Hi, everyone. My name is Ben Freiberg, and I'm a senior solutions architect at Amazon Web Services. Today, we're going to talk about how to build serverless workflows with AWS Step Functions. This is the agenda for today's talk. So first, I'm going to explain on why you even need orchestration, and then what is AWS Step Functions and why is it the perfect service for this use case. Then we're going to dive deeper into the different kind of states, integrations, and patterns that are available and that you can build upon with Step Functions. Then I'm going to talk about a bit of the available developer tooling and observability. And finally, some important limits and best practices. With that said, let's start by talking why you even need orchestration for your applications. And to do that, let's take a look at a typical modern, let's say, cloud-based application. So in the cloud, let's say in your application, there's only one Lambda function. And as you probably know, Lambdas are stateless, event-driven functions that exist in the cloud. But there aren't really that many apps with only one function, one entry point, one module, or one component. So there'll very likely be more than one. And in fact, it's really also common to have not only lots of functions, but lots of them talking to each other. And again, applications, serverless or not, they tend to have and tend to communicate with databases. And especially in the cloud, lots of applications also use queues of some kind or another. And it might be that even some of these functions, some of these components connect to servers outside of the cloud. So this is what an actual modern serverless application might really look like. And you might have noticed that these arrows are in different colors. And that's because there's lots of ways for functions and other serverless components to talk with each other and control each other and orchestrate each other. And before we dive into the how, let's talk about a bit what we want to do with functions when we have more than one. So what are the requirements for orchestration? So the simplest one is I want to run task A and then to run task B. But there might also be the use case to say, okay, I want to run task A, and then depending on some kind of input or some kind of data, some kind of conditions, I want to run task B or task C. There might also be the case that you have transient errors, that you need to retry your task. There might also be unrecoverable errors where you need to have some kind of try-catch mechanism. And there are many more requirements like running tasks in parallel or concurrently. Let's give an example of where workflows come into play in real life. So let's assume I want to book a vacation. Let's assume to the Grand Canyon. I've booked a flight, I rented a car, but for some reason, I'm unable to find a hotel. Now I need to cancel all my previous reservations. So several components need to be orchestrated depending on what has happened before. So that's when we are talking about and when we're needing a workflow. Okay, let's go into the implementation side of things now. How could you implement this? So one idea could be you just link all your functions together. That's not really a terrible idea, but it also doesn't give you these modular and independent components that each do one thing very well. In this case, it's all very tightly coupled, and that's not what we want. So another idea would be, okay, why not call one function from the other? So if you do it synchronously, that really doesn't scale because, okay, one Lambda function might call another and another and another and so on. So you could do it asynchronously, which is actually a better design, but now error handling gets really hard. Even finding out about errors requires some extra overhead, some extra assembly. So an alternative could be, okay, why not track your state and write it into a database? For example, Amazon DynamoDB or some other database. You could even use SQL, particularly if you need transactions. And some customers are doing this and they're getting okay results. But again, there's still a lot of work that you have to do, that you have to implement. And another approach would be just pass the state that you have around through some queues or streams. Again, this involves a lot of bookkeeping. So for example, if the function that reads from the queue gets a failure, you need to catch that, rewrite the state into the queue. And then if you want to do timeouts and retries, all that you have to implement yourself. So coming back to the initial question, so why do we need orchestration? we want to isolate tasks into logical components that, again, do one thing very well and don't need to worry about all the other parts. They should be decoupled from each other. But we want to centralize the orchestration workflow, because that gives us an easier end-to-end monitoring capability. It gives you the timeout, the error handling. So basically, it does all the undifferentiated heavy lifting that you don't get any business value from. And the perfect service for this, at least in my opinion, is AWS Step Functions. So what is it? Step Functions is a serverless workflow service that's managed by AWS. And by serverless, I mean that you don't have to worry about any kind of infrastructure management. So you don't need to maintain, operate, or patch some kind of infrastructure. And you also don't need to worry about capacity. You only need to worry about your workflows, and the rest is handled by AWS. So if you build a workflow with AWS Step Functions, you build it using what's called a state machine. That state machine is comprised out of multiple steps that are called states. And you can write these using what's called the Amazon States language. But there's also a visual interface, a drag and drop interface that I'm going to talk about in a minute. In the end, you can use Step Functions to orchestrate multiple AWS services. But not only that, you can basically any endpoints that can make an HTTP request, you can orchestrate with this. And we're going to see how in just a bit. First, let's give an example on how this could look like. So let's say you have a use case, a workflow where every time a user uploads an image, you want to take a thumbnail, you want to identify some key features out of the picture, and you want to store the metadata. So using Step Functions, your workflow could look like this. Every time a user uploads a photo now, you have a first state, a first step, that extracts the image metadata. Then we're having a choice. We're doing some logic. So depending on the type, the format of the image, it's either supported or not. So let's say it's supported. Great. Then we're going to store the metadata, for example, again, in some kind of database, DynamoDB, and then have two tasks in parallel. One is creating the thumbnail, and the other one is using another service to extract the identifying some features out of the image. And you can run these in parallel because they're independent of each other. So you don't need to wait for one or the other to complete before running the other one. Meaning that with Step Functions, you get the following benefits. It lets you build visual workflows that enable a fast translation from the business requirements into the technical requirements. So you can build applications in, let's say, a matter of minutes. And when your needs change, you can easily swap or reorganize components without customizing any code. And you're writing less code in general because Step Functions manages the logic of your application for you, meaning that it implements like basic primitives such as the branching logic, parallel execution, timeouts. So this removes the extra code that you otherwise would have repeated in your services and functions. And it also improves resiliency because it manages the state, checkpoints, and restarts for you to make sure that your applications execute in the order and as expected. So there's built-in try-catch mechanisms, there's retry and rollback capabilities that can deal with errors and exceptions automatically. So apart from the microservice orchestration that I already mentioned, there are a couple of other use cases for Step Functions. So one could be data processing. So every time you have, let's say, multiple data sources that you need to aggregate, transform, or filter, and do some kind of ETL process, you could use Step Functions to orchestrate these steps. There's also IT and security automation. Let's say, for example, you have a security incident response workflow. So every time, let's say, when an IAM policy is created, the workflow could compare it against a customizable list of restricted actions, so something that should not be allowed. And if so, the workflow would roll back the policy, notify an administrator, and wait for them to approve or deny. But machine learning is another topic. So let's imagine you have a very complex steps sequence of steps that you need to take in order to build, train, and deploy a machine learning model. And again, all this can be orchestrated using step functions. I've mentioned visual workflows a couple of times now. So that's where the define steps of your workflow. So how do you define your workflows? So one way is using the Amazon States language, this JSON-based structured language that I mentioned. But the other one is using a drag and drop interface called Workflow Studio. So there you can really easily and simply build your workflows from the UI in the console. You could always use the CDK or the Cloud Development Kit if you're familiar with this, or there's even a data science SDK for Python. So now you've defined your workflows. Then step functions will go ahead and visualize them for you. So you can see a clear picture, you can have a clear overview and a graph of how your workflow will look like and what's going to happen. And similarly, when you execute and monitor your workflows, you can see which steps were taken, where an error happened, how it was handled. So it's a very visual way of understanding and reasoning about your workflows, which helps it tremendously during debugging and finding errors. So let's talk about Workflow Studio. So what is it? It's what I mentioned, this low-code visual designer and inspector with a drag and drop interface. The idea here is, and the main benefit, that it really reduces the time to build a first workflow for new developers. But also experienced developers can use it to build and share prototypes with stakeholders faster. It includes an improved workflow visualization using the AWS service icons. It has these automatic workflow layouts, and it can take visual cues from your workflow definition. So it's much more appealing, at least. I don't want to go into too much detail here, but these screenshots, they highlight the different kind of states that are available in step functions. So there are flow states that talk about the logic, how information flows around in your workflow. There are what are called optimized integrations. These are available for a few services. For example, for a Lambda function, you only really need to pass it the function name, nothing else. Then there are the SDK integrations, which allow you to trigger any of the over 10,000 API actions that are implemented right now, where you then need to provide all the different kind of parameters. So let's talk about the different types of states that are available in step functions. And firstly, this is the exhaustive list. So these are all the states types that are available in the Amazon States language today. You've seen already a couple of examples today, and I will go into more detail about the rest. But before I do, let's quickly talk about the succeed and fail states at the very bottom, because these are just simple states that you can use to semantically signal either a successful or failed execution. And each of them will then stop the execution. So let's start by talking about the task state. A task state performs work. This could be calling a Lambda function, which is very common, but you could also use the task state to wait for a polling worker process that's running basically anywhere to pick up work from step functions, perform some computation, and return the result back to the workflow. And a task state could also be used to invoke any kind of APIs and other AWS services that step functions integrate with. So here at the example on the right, you have a first task state that gets an item for DynamoDB using the getItem integration. Then it calls a Lambda function to process it, and then publishes some kind of message to an SNS topic. Then there's the parallel state, which you can use to create parallel branches of execution in your state machine. So for each branch gets its own copy of the input data, and the output will be an array with one element containing the output from a branch. So it's basically the array of outputs. That's useful when you have independent tasks that you can run in parallel, for example. So here in this example, let's say we need to look up the user details, and we have one system where we can find the address and one system where we can look up the phone number. So we can trigger and run these two in parallel, and they don't need to wait for each other or have some kind of order. So the map state is another one. It sounds very similar to the parallel state, but it's quite different. So the map state you can use to run a sequence of steps for each element of the input array. So while in the parallel state, that executes different branches of steps using the same input, a map state will execute the same steps, but for multiple entries in the input array. There is a limit to the concurrency that you can have. And when you reach that limit, some iterations will not begin until the previous one have stopped. And the likelihood that this occurs is around 40 items. So either limit your input array to 40 items or split it up into batches of around 40 items. And then there are the choice, wait, and pass states. I mentioned the choice state before, so it's where you add branching logic to your state, depending on some kind of conditions on input data, which path, which task to do next. The wait state does what it says. It waits either until a specified amount of time has passed. So you can say, let's wait 1 hour before continuing, or until a specified point in time. So let's say wait until tomorrow morning at 9 a.m. And then there's the pass state. It's a very simple, and it allows you to just take its input and it will pass it as output again. So without performing any work. It's still very useful because when you're first sketching out a workflow definition, you can use these as placeholders and replace them later on by other state types when you're fleshing things out. The pass state is also useful in debugging because you can add some information to the output. So you can have some static data that gets added to the output, which can, again, help in debugging your workflows. So now let's look at the available integration patterns in step functions. And to do that, let's first start with how you can actually trigger an execution of your workflow. One option could be a Lambda function just calls step functions and triggers the workflow. There could be an external request made to an API gateway that then triggers your step function. Or there could be other events that via Event Bridge, Amazon Event Bridge, trigger your step function. Or you could use Event Bridge to run to trigger your workflow on a schedule. So every day at midnight, for example. And interestingly, you can use step functions to trigger other workflows. So you can have what's called nested workflows. There are a couple of other options as well. Okay, let's talk about now the task integration pattern. So there's the different states and the different tasks, because, for example, the easiest one is, okay, I want to trigger a Lambda function. So you trigger the Lambda function, wait for the response, and then continue the workflow. And that's what's called the request response integration model, let's say. But step functions will only wait for a result. It will not wait until the whole job has completed, for example, if it's a long-running job. For example, for some integrated services like AWS Batch or Amazon ECS, step function would only wait until the job has been submitted and not until it's completed. So you wouldn't know if it was a success or fail until later on. But for these kind of services, you have what's called run a job or synchronous integration. So you can have step functions call the service and really wait until it's completed. And it will wait until that time. And the last integration is what's called waiting for a callback. So that's always useful if you need to wait, for example, for human approval, you need to integrate with a third party or have some kind of legacy system. And for tasks like these, you can pause step functions indefinitely and wait for the external process or workflow to complete. And the way it works is using a unique task token. So for example, these are services that step functions is integrated with. I mean, there's a lot of other services, but these are very, very common examples. For example, so request response means Step Functions waits until the task responds, not until it's finished. For example, it's invoking a Lambda function, it's running a task on ECS, it's sending messages to either SQS or SNS, or even starting some machine learning model even maybe, and so on. Again, there was the runner job, what's called the synchronous invocation, and there's a limited set of integrated services, and these are of today the services that support this kind of integration pattern. Again, it's important that Step Functions itself is integrated, so you can trigger a step function from another one and wait until that nested one has completed. Not just that it's started, but it's really completed. And again, the wait for callback integration, it's very useful, but not a lot of people are aware of it. And how it works in detail is the step functions will make a call to that service integration and pass a unique token that could be embedded in an email, go to an on-premise legacy server, or some kind of long-running task in a container. And whenever that job finishes, it then needs to make a request, an HTTP request to the Step Functions API, and provide the result of that work or of that job, and the unique task token, so that Step Functions knows, okay, this workflow can now continue with the given input. There's also what's called activities, and that's a Step Functions feature that allows you to have a task in your state machine where work is performed by a worker that can be hosted on Amazon EC2 instances, or again on ECS, on mobile devices, on some kind of on-premise server, basically anywhere. The important part here is that when Step Functions reaches such an activity state, the workflow will wait for the activity worker to poll for a task. So it won't call the other service integration, but it will just wait, and the worker is responsible to get tasks from Step Functions, again, complete the work, and then provide a report of its success or failure. Okay, let's go even into a bit more detail and let's look at the flow of data from one state to another in a workflow. Don't worry, this looks very complicated, but it's actually very intuitive. So the idea behind all these features is to control and filter which pieces of information are passed as input to a state and which ones make up its output. Let's go quickly one by one. So you have the original input, and now you can use what's called a path, which is just a string beginning with a $sign. So it identifies a node within a JSON object. So you can use what's called the input path to specify which node of the original input should be the input to that state. So for example, here on the left, we have a JSON object with two attributes, or two objects, the title and the numbers array. And if you specify the input path at just $.numbers, that object will be passed to the state as input. The items path is really only needed when you use a map state where you had an array, and for every item, a sequence of steps is going to be performed. It works very similar. You select one part of your original input as input to the map state. More interestingly is parameters. So let's assume you have filtered or controlled what kind of input you want to send to your state. You can now use the parameters array, or sorry, the parameters field to add either static key values, or dynamically. So in this example, again, same input on the left. The parameters say, okay, we have a static value that's a string with just a string, and a second number. And you can see the $$ at the end, which indicates that it's dynamic, and it takes the second entry of the numbers array. Why is this useful? It's useful to transform your data structure. So let's say the task or the service that you're calling expects the input in a certain format, but your original input is in a different format. So you don't need to have like some kind of Lambda function that transforms it, some kind of additional service that transforms your input. You can just use the features in Step Functions to prepare the input format as your service expects it. So again, as a recap, so we've now made sure that the input to our state looks exactly like we want to and like it's expecting. Now the state performs some work and produces some kind of output. And now we want to maybe manipulate and filter this output. Let's look at the options that we have here. The first one is the result selector. It works very similar to saying, okay, like the parameters, now we can transform back the output. So saying, okay, we have again the option to do some static key value pairs or something dynamic. The use case here is again transforming the original output to what the next state is expecting. And again, the result path allows us to filter or control what parts of the output what part of the input should be added to the output, because normally if you don't specify anything, just the output of your state will be passed on to the next state. But maybe you want to have at least parts of the input or your full input to be merged into the output and then passed on. So you don't need to drag all the values, all the data with you in every state. So now the result path, you can either overwrite the input or just the output or merge the two, which is the most common use case. So you're specifying where in the original input array or in the original input object, your output should be slotted in basically. And then you can filter with the output path, you can filter what subset of objects should be passed on. Again, the use case here is to eliminate the need to have any additional services or transforming logic. And that's also where the intrinsic functions come in. So these are constructs that look like functions in a programming language that can just help you to process the data going to and from your task resources. So the idea is here, all these, let's say, simpler transformations, you don't need any additional service for. You can just do it in Step Functions to have your task focus on generating business value and then the core task. I've talked a lot about workflows so far, but I've actually not mentioned, at least, that there are two kinds of workflows with some significant differences. So now it's time to look at these two, because there are standard workflows and there are express workflows. And here is what's kind of the difference, the comparison between the two. So standard workflows is what you would usually use. They have, for example, a maximum duration of up to 1 year. So that's where you can have like long-running workflows. That's, for example, some kind of order processing where now somebody orders an item. You need to wait until it's fulfilled. You need to see if there's some like return, and after 6 weeks, you're going. And if they don't return it, you credit them with some loyalty points. And if they return it before, they don't get the loyalty points. So you can wait up to weeks or months even. But you have, let's say, a lower limit, a lower quota of how many workflows per second you can start. I'm going to talk about quota, so which ones can be increased later on, but there's a difference, a strong difference of how many per second you can trigger. Similarly with state transitions. So state transitions is every time your workflow transitions or switches from one state to another. And that's like one of the core dimensions of the standard workflows. The express workflows, they are useful for very short-lived, as the name implies, for very short-lived jobs. So they have a maximum duration of only 5 minutes, but the benefit is you can have a lot of them started per second. So really high volume, high throughput use cases, and they're not limited. They're basically not limited on the state transition rate. One thing to call out is that this nice visualization of the execution history, so what steps were taken, what was the input, what was the output, that's all very nicely visually prepared for you in the Step Functions console, and that's only available for standard workflows. Both workflows, you can send the logs to CloudWatch Logs, but you only get the logs then. There are a couple more differences. that I want to call out here, and that's the execution semantics. So for standard workflows, there's an exactly once workflow execution. So the service will make sure that your workflow is really executed only once. For express workflows, that's not the case. So there's an at least once workflow execution model. That means you need to make sure that your logic is resilient against invoking it twice with the same input. So basically your service or your logic should be idempotent. So it doesn't matter if you trigger it a couple of times. For service integrations, again, for both types, all service integrations are supported. The difference here is that express workflows don't support waiting for something. So they don't support the synchronous model where you wait until the job somewhere has completed, or the callback pattern where you say, okay, I need a human that needs to click on a button and it can wait for a couple of minutes, hours, days maybe. So the express workflows only support the request response model. The interesting part, the last interesting is maybe billing. So how does pricing work? And interestingly, standard workflows are built on state transitions. So explicitly, you're not paying for waiting. So if you have a workflow that says, okay, I need to do a job and then wait 6 weeks, you're not paying for this. You're only paying when your state machine transitions. The express workflows, on the other hand, they have like a request base, so how many of them you start, and very similar to the billing of Lambda works, like a duration and memory consumption model. So for how long, how many gigabytes of memory were you using? And that's also based on the usage of, let's say, parallel states, on the size of the input data you're using, and so on. Really important is that for standard workflows, you're not paying for waiting or requests, you're paying for state transitions. So the obvious question is now, which one is the right use case? Which one is right for my use case? It depends is the answer. Here's like some high level indications. So every time you have like really high volume data processing, or you don't want to be limited by the amount of workflows you generate. So in an event-driven system, you don't want to be limited if you experience a significant growth. So that's where express workflows come in. Whereas every time you need to wait for something, or you have kind of long-running workflows like payment, billing processing, or even media processing, you should use standard workflows. But you can embed them, and that's what I want to talk about next. So what kind of workflow patterns are there? And I've mentioned it before. There's what calls the child workflow, the nested workflow. And that's very, very useful and very effective, because you can break down like large state machines into smaller ones and have similar to like reusable libraries of code. So you can have a step function that does a somewhat contained, limited scope job, and then use that in other step functions. And for example, you can trigger an express workflow from a standard workflow. So you could have standard workflows that orchestrate the overarching workflow, and then express workflows for short-lived tasks. Then there's also what's called the saga pattern, or distributed transaction. That comes back to the initial example I made, where let's say I booked a flight, an hotel, and now at the third, fourth whatsoever step, something goes wrong, and we need to unwind or reverse all the changes that I made before. So that's also where you have basically a compensating step for every step that you took before. That's also very useful or very interesting to know. So let's talk a minute about developer tooling. So now it's great, you want to build using step functions. Okay, how do you build, how do you test, and how do you debug step functions? One option to build it is obviously Workflow Studio, as I mentioned before, especially if you're getting started. But you can also use the AWS toolkit for VS Code or Visual Studio Code, meaning it gives you a local development platform. You can build your state machines locally. It has also the same visualization that you get in the console. It has also state machine linting if you activate that. And it gives you the IntelliSense, so makes somewhat useful suggestions how to complete your code or what's missing, basically. Specifically on testing and running locally, there is Step Functions local, which is really like a downloadable versions of Step Functions that makes it so much easier to develop and test your applications locally. It comes as a jar package or as a Docker file. And the cool thing is it can invoke Lambda functions from your local environment. They can be in AWS, but you can also run Lambda functions locally. There's tools for this, and these integrate with each other. But it makes the testing and development so much more easy. Okay, now you've built, you tested locally. Now you want to deploy. You have two options basically there. You can use a declarative approach, meaning the serverless application model, which is really like a template-based, either in JSON or YAML, which supports Step Functions, or the Cloud Development Kit, for example, which is more imperative-based, where you use your familiar programming language to define and author your state machines. In the end, they both use CloudFormation to deploy your actual infrastructure, but you have, again, the choice which one you prefer. One quick call out is there's a data flow simulator available in the Step Functions console where you can really deep dive and understand in detail how specific configurations of all these input path, output path, result selector, and so on work by testing every step and getting an explanation. Okay, why is this happening? What's happening here? How do I get the result that I want to achieve? Also very useful. And the last topic, observability. Again, with every proper serverless service, you need three key topics: metrics, logs, and tracing. Step Functions emits metrics, for example, for executions, activities, the service integrations, and so on. They are available in CloudWatch. It also, you can for standard workflows, and you can only do it, only express workflows. Sorry, so you can send your logs to CloudWatch logs for standard workflows. Express workflows will send them to CloudWatch logs by default. And for tracing, you can have the option to create and pass traces. So if your Step Function is integrated in a larger application that already has tracing enabled via Ixchel, for example, that's the service, Step Functions will happily pass your trace IDs and so on around, but you can also use it to activate or implement tracing in your Step Function or in your workflows. And lastly, it's also integrated with EventBridge. I mentioned initially that you can use EventBridge to trigger Step Functions, but also Step Functions will emit events to EventBridge, for example, when there is transitions from, let's say, the workflow has started or it was timed out or succeeded and so on. So you can act upon these in your whole application landscape. I mentioned limits and quotas before. Let's look at them. I think most important ones. There are some more. You can find the link here in on the slide. But the important ones again are standard workflows have a duration of up to 1 year, whereas Express has up to 5 minutes. There is a limit of concurrent executions for the standard workflows of you can have at most 1 million concurrent executions. And one important highlight or one important limit is what's called the execution history size. And that's limited for standard workflows. What I mean is that a workflow has a hard quota, so that's a hard limit of 25,000 entries. So after 25,000 entries in your history, so the workflow has been like switching states a lot of times and you're reaching that limit, your workflow will be stopped. So avoid this quota for long-running workflows. And one idea could be starting a new one from an existing state. So keep that in mind. Then there's quotas on how many executions you can start. That depends a bit on the region you are in. Also, how many state transitions you can have. Again, these can be raised. And there's the hard limit of how large your payload size can be. And that directly brings me to the best practices. Obviously, choose the right workflow type. Again, if you need long-running, durable, auditable workflows, then go with standard workflows. Or if you need high-volume event processing workloads, use express workflows. They will behave a bit differently depending on which type you select, so be aware of this. Then avoid timeouts. So if you don't set a timeout for your workflow, Step Functions relies on the response from an activity worker or from a task to know that it's completed. So if something goes wrong and there isn't a response, the execution is basically stuck for a long time. So ideally, always specify some kind of useful timeout. I mentioned the hard quota of 256 kilobytes as the input, the size of the maximum size of the input. So again, if you have larger payloads that you need to work on, use S3 and just pass around the referrer to S3, so the object in S3, to get around this. Again, for very long-running tasks, be aware of the history quota. If necessary, start another workflow from the existing one that has then, again, a fresh execution history. And be aware of handling Lambda service exceptions, because there can obviously be errors within Lambda, for example. There are some transient errors, so be aware of the retries and failure handling if you use Lambda. And that's all from my side. So thank you again for attending the session. If you have any questions, please also feel free to reach out on LinkedIn. And thank you.
Hello, Ben. Thank you very much for the marvelous talk. I think it was the best one with lots of comparisons and lots of detailed explanations. So thank you very much. So we have got two questions, very quick one. So
Sure.
Can you let me share this the question? Can we use AWS Step Functions to replace MSK Kafka?
The answer is it depends. So I would like to know more about the use case, but I would see Kafka in a different use case than Step Functions. So when I hear Kafka, I would usually, or when I hear Step Functions, an alternative could be Airflow, for example, and there's managed Airflow also on AWS. Where I see Kafka is more in the communication of topics, of subscribers, of producers of events. So I wouldn't see it normally as a replacement, but that can depend on your use case. So again, feel free to reach out to me on LinkedIn, and I'm happy to provide more details if you know more.
Okay. The next one is, what does Step Functions have more than MWAA Airflow?
That's a good question. I think there's a lot of differences, and that depends on what you're looking for, right? So for example, Step Functions is a native AWS services, meaning that it's much more deeply integrated into the AWS ecosystem. Whereas with MWA, so Airflow, you have an open source product that's managed by AWS. I think that's only one of the differences here. Again, there's so much to talk about, and I would be more than happy to go into detail. So again, feel free to reach out.
Okay, thank you very much, Ben. I hope and I think that was the end of the question answers. So thank you very much for your time, and have a wonderful sessions ahead. If anyone has any questions, please feel free to connect to the speakers, including Ben, on the social media. So thank you very much, Ben, for your time. I think I will offload you to the screen, and we have for the next speakers waiting on the queue. So thank you very much, Ben. So everyone, I hope everyone is enjoying so far. So we have got the next speaker is Igor Ivaniuk from Germany. He's again a senior solution architect at AWS. So let me add him to the screen. Hello, Igor. How are you doing?
Hello, great to be here.
Are you excited for the talk?
Yeah, very excited.
Okay, so let me add your presentation on the screen. So the Igor, the time is and the stage is both are yours.
Nice. Welcome, and let's talk about Kubernetes once again. You may probably think of, all right, come on, not that again. I know everything about Kubernetes, but wait, maybe I will be able to entertain you somehow. Of course, you know already that in AWS, we have the managed Kubernetes service. And one of the benefits that is built into the service is that it is a vanilla open source upstream Kubernetes version. It is basically delivered with a slight delay after the official releases of official open source Kubernetes, because we need some time to modify and test our cloud integrations and tools. But the idea is that, of course, Kubernetes itself became very popular as a runtime platform for various workloads for our customers, and of course, EKS as a managed service is also one of the most frequently used service between our customers globally. But okay, let's maybe take a step back and say why Kubernetes. And there was a very interesting survey by Cloud Native Foundation, by CNCF. What features of Kubernetes are the most appealing to the community? And basically, if you can see for yourself that the most important one was, of course, like faster deployment time and improved scalability. And indeed, Kubernetes can scale almost indefinitely. It can operate complex applications and complex structures, complex architectures at scale, and of course, do it reliably. However, as soon as you start building something bigger or scale up your applications, immediately, especially if you are talking about the situations which are relevant for smaller enterprises or startups, we start talking about efficiency. And this is the main topic I want to focus on today. It is efficiency. And when people are talking about efficiency, so when IT people are talking about efficiency, we usually can talk about, efficient usage of CPU and RAM, like optimal storage distribution, and so on. But if we look into the decisions and how they are done by the business stakeholders, usually when they are talking about efficiency, they mean efficient usage of money, especially. That's why I believe many of you already encountered the requests from the business teams to find the ways how to optimize the costs used by your clusters. And as one of the example of our customers shows, so on the right, there is a chart of the costs, like daily costs for their cluster. And you can see that basically the biggest difference between the daily costs, like from here to here, is achieved by auto-scaling and right-sizing. Yeah, of course, later we can also modify purchase options, use some savings plans or spot instances maybe, or even migrate to EC2 Fargate instead of EC2. But this is usually done afterwards. But the first thing that we recommend to look into if you would like to adjust the costs for your cluster is make sure that it is used effectively. And this time I mean that we don't need to have any over-provisioned capacity, because any capacity that is not utilized by your production workload is basically money wasted. And yeah, you can do it manually somehow, or you can of course automate it, because I mean we all know that we like to automate things, and we trust in our automation and we believe it can do the best things for us. And in general, when we are talking about the scaling and right-sizing the whole compute resources that are used to run our applications in Kubernetes, we talk about, let's say, 2 dimensions. One dimension is scaling of the pods themselves, horizontally or vertically, which means changing either the number of pods or the number of resources dedicated per pod, depending on some criteria, usually depending on some metrics that indicate the customer load. And also another thing is to modify the size of the cluster. Of course, if you run out of resources in the cluster, we need to make it bigger, to add some more. But also, we would like to be able to shrink the cluster if it is over-provisioned, if it's not used. So let's take a more detailed look onto those two problems. So when we are talking about modifying the pods, either pod sizes or pod number, we are usually talking about horizontal and vertical pod autoscalers, HPA and VPA. The logic behind them is pretty simple. The horizontal pod autoscaler monitors a specific metric and tries to keep it within the limits that you have defined. So it's basically a target tracking type of scaling. Of course, to use it, you have to have matrix server, and then just when the specific metric goes above the threshold, whether it is the average load, CPU load per pod, or maybe if you publish the number of requests, so it could be the number of requests per second per pod, and so on. And so if it goes above the threshold, then pod autoscaler starts to add more copies of the same pod. Of course, assuming that the application that you're running there is stateless and it is safe to actually scale it up. So basically, the idea is very simple. There is no much to talk about here. Just that's another step, the sequence of data flow that goes through the pod autoscaler. So pod autoscaler does not look onto your pods directly. It uses the metrics published in the metric server to check if it should scale the pods or not. And the vertical pod autoscaler is the way to increase the size of the pod. For example, if you cannot scale the pods horizontally, so you cannot just plainly launch more of them, but instead you would like to make every pod work faster by assigning more resources to it, like more CPU and more RAM. That's the concept for the vertical pod autoscaler. And then you can do it actually two ways. One way is like in-place upgrades or in-place update, when you already have the running pod, and you can so you just modify the resource allocations for that, and then pod starts using more resources without being restarted. That could work well for some applications which are which take a lot of time to restart, like for example database engines. And of course we can also just kill the pod and launch one more with bigger resource allocation. That's another way to do it, but that's not what vertical pod autoscaler does. But anyway, both those pod autoscalers are limited by the amount of the resources available for the cluster. For example, so the horizontal pod autoscaler has basically bigger limits because it is limited by the total amount of computational resources of the cluster, whereas vertical pod autoscaler is limited by the amount of free resources on a specific node, because it cannot scale the pods outside of the node. All right, but what if you ran out of those resources? I think you all have seen the cluster autoscaler. So the Kubernetes cluster autoscaler it's another plugin that is installed in the Kubernetes, and what it does not work with the pods directly. It doesn't check the metrics. Instead, it checks which pods are in the pending state, and that cannot be scheduled because of the lack of resources. And then if it detects such pods, cluster autoscaler works with the managed node group, and in fact it increases the size of the node group. And under the hood, it is backed up by the AWS autoscaling group, which has 3 parameters: minimum number of instances, maximum number of instances, and desired number of instances, or desired capacity. So what it does, it just increases the desired capacity. This increase causes autoscaling group to start new instances, add them to the cluster, and of course, finally, the pods are being scheduled. So that's how it could look like. When you have auto-scaling group, normally you have the uniformal auto-scaling group. So it means that you have the instances of the same family and of the same size in this auto-scaling group, and that's actually the good recommendation or best practice to do so, because the cluster autoscaler does not know if there are different instance sizes. So, for example, it can only calculate in the fractions of nodes. So it counts that, okay, if we have 5 nodes already, and if we have few more pods to schedule that sum up to like 20% of the available capacity, it can calculate that it should add 1 instance. And if those instances would be of different sizes, it would mean that cluster autoscaler would be not effective. That's why if we have, for example, more nodes waiting to be scheduled, it starts the required amount of nodes, required amount of instances, and those pods essentially go there. Sounds good, right? But there is another way, and we decided to look at the problem of scaling from a slightly different perspective to see if there is something that could be optimized. And now I want to introduce to you the Karpenter cluster autoscaler. One big difference is that if you look into the way how it provisions nodes, okay, you have the horizontal pod autoscaler or just normal scheduling. You have padding pods, and normally, if with cluster autoscaler, you have the cluster autoscaler triggered, it modifies the autoscaling group, and finally, the autoscaling group like uses EC2 API to launch a new instance. So that's a multi-step process. Karpenter is doing something simpler, like that. When you are using Karpenter, you don't operate with the autoscaling group anymore. And the idea is that the Karpenter calculates the exact amount of resources needed to launch the pod and launches the perfect amount of instances of different sizes that could fit the given amount of pods. So when Karpenter also listens to the scheduler and checks if there are unschedulable pods. It tries to understand what is the current capacity as well, including the current unused capacity. And then when the new pods are scheduled, it aggregates the whole amount of resources and tries to understand how to distribute the pods correctly. Of course, it will first try to put the pods onto underloaded nodes and then launch some more if needed. So the logic is similar, just the size of the instance could be various. For example, instead of launching the same instance types, which would be underutilized, Karpenter could decide to launch a bigger instance type, 1 instance instead of 2, to accumulate all the resources, all the pods that are needed to be scheduled. And it does it pretty effectively because it always tries to solve the so-called knapsack problem. It's basically a multi-dimensional optimization problem. How to find the correct number and the correct type of instances to accommodate all resources requests of all the pods that are waiting to be scheduled with the minimum overhead. It includes multiple dimensions. For example, of course, it checks the CPU and RAM availability, but also there could be some other requirements, like, for example, architecture requirements, whether it should use x86 or ARM architecture, or, for example, the availability of GPU for example, for machine learning approaches, and so on. But as a result, the result of the bin packing algorithm is the command to the EC2 fleet to launch the specific amount of specific instances. As simple as that. Of course, Karpenter can do scale down as well. So it has few parameters. For example, by the default configuration, there is a parameter TTL seconds after empty. And that's the parameter that will tell you how much time the scheduler, the Karpenter controller will wait when the node is empty to basically shut it down. Of course, you want to make sure that this TTL is not too big, because it will so it will scale down efficiently, but also not too small. If for example, if you have the development environment where you have a lot of changes and constant redeployment of pods here and there, then maybe this TTL may be a little bit bigger, so we don't have to be stopping and starting instances all the time. Another very interesting feature of Karpenter, which was added recently, I think it was added in the version 0.16, it's so-called consolidation. Or you can call it defragmenting of the compute resources. So what consolidation effectively does is when there are, so when some pods get killed or get deleted, Karpenter analyzes, of course, if not just, it doesn't only check if some node is free, but also it checks, for example, if you have a lot of like unused capacity on multiple nodes, then Karpenter can verify if, for example, the remaining nodes could all, the remaining pods could all fit to one node. Then it will reschedule those pods, put them all on one node, and then free the other 4. And that's very interesting behavior, because this behavior essentially will not work very effectively if you try to replicate it with cluster autoscaler. So if you have the workloads that distributed their pods over the cluster, then shutting them down just means that you will have a lot of nodes with some part or unused capacity, but not a single empty node. That's why without consolidation, you may not be able to basically scale down the cluster and reduce the compute resources and reduce the cost for the cluster. And today we will see how consolidation works in action. The core configuration that you have to provide when you are setting up the Karpenter for your cluster is provisioner. So when you install Karpenter, it creates a custom resource definition called provisioner. This is the definition that controls the parameters that you would use to provision your pods with Karpenter. It has a lot of mandatory and optional attributes. We will go through them in details on the next steps. The idea is you have to have at least one provisioner. You can name so the default one that will catch all those pods that are not scheduled yet. But also you can create multiple provisioners for provisioning different needs. For example, some of them can observe some taints, or others can work only with spot instances, or another provisioners could only schedule the ARM-based architecture. So what kind of settings you can put there? One of them is purchase option. You can define if you would like to have the on-demand or spot instances. And if you can configure both, it will prioritize spot instances. And then another requirement you can put, as you see, the architecture, the architecture for that. So it can be either x86, which will be AMD 64, or ARM. It will define which instances to use. I think by default it's x86, so AMD 64 only. by default, again, Karpenter will try to use all kind of instance types, excluding the ones, the metal ones or GPU-based ones. The idea is that it tries to do so just to save, basically to save money and to use them more effectively. And then you can decide to exclude some of those instances and to reduce the amount of instances. You can do it, but only if only if it's needed for you for some reason. And it tries to diversify the instances over both instance sizes, families, generations, and CPU types. Even if you have different architecture, even if you have fixed architecture, so AMD 64, it can use like Intel-based instances or AMD-based instances, and this also can affect price a little bit. Also, by default, it will launch the instances in all availability zones. And again, you should restrict them if it's needed according to your business requirements. For example, if you would like to launch some instances in specific availability zones, then yeah, just do it. Karpenter provisioners support taints. They can be permanent, like this, for example. And then with them, you can do basically you can prevent the pods from scheduling on specific instance. Or they can do, or there can be also startup taints. Startup taints are meant to be present during the time of the node startup. For example, if you are using the CNI plugins to assign networking, to assign IP addresses to your pods, then the startup taint will make sure that the pods are not scheduled onto the node until the CNI plugin is not deployed in there, and they will be removed automatically. One interesting and important feature that Karpenter allows you to do is to modify the kubelet configuration, and it allows you to put these like system reserved constraints. Why is it important? It's because if you would like to use vertical pod autoscaling, Karpenter doesn't know during the scheduling time that, for example, that your pod can essentially grow in size. And by default, it will not reserve some compute and RAM capacity, like to have a room for the pods to scale upwards. But by increasing the kubelet configuration this way, you can assign some reserved memory and some reserved CPU just for the sake of increasing the pod sizes, to increasing the limits of the already launched pods. I mean, of course, there is a way to overcome this problem without reserved resources. As I said, we can plainly kill the older pod and start the new one, the bigger one. And it will be completely fine if your application or if your pod supports that, if it can be actually safely killed or safely shut down. Right. Enough talking. You're always free to ask questions in the chat, and let's have a look at some actions. So, demo time. I think I've shared the links to the demo scenario that I have prepared for you in the slides. Let me just try to put it in the chat. It's this one. And the idea is that I have prepared a cluster for that scenario. So we have one cluster, and I will use Cloud9 environment to operate it. Let's see what we have now. Sorry. So now we have one node, and it's a small one. It's 2x large node, and here on the right-hand side, I have the KubeOps dashboard. It displays the states, the state of the node. For example, you can see that there are a few pods running already. So that's the Karpenter pod itself, and the KubeOps view dashboard and the KubeOps view Redis. And of course, we have some daemon sets. We have core DNS, we have metric server, and so on. Let's do some load testing, shall we? Let's start with first trying to launch some specific pod. So I will launch, for example, I will launch this one. Just very simple application, but it will require 10 CPUs and 10 gigs of RAM. Of course, this will not fit into the existing.
Sorry, Igor, I think you are muted. Yeah, we can hear you now.
I did not change anything. All right. So I hope the ops view will remain. We will get back. But meanwhile, we can check in the EC2 dashboard what is happening on. And so you can see, for example, that here we have one pretty big instance. We have R5, R6, R32X large. Let's see. Let's check. Let's filter by the name. So contains Karpenter. Right. So you can see that we have one instance launch. We have one instance starting. So it means that Karpenter decided that in order to put 10 pods, each of them with such requirements, it can just launch one instance instead of like running many of them, and it have scheduled those instances. Those pods onto this instance. All right. Let's try to scale it a little bit, and instead of deploying it again, let's scale and see how it reports the scaling. For example. So, I'm sure if you noticed, it managed to schedule some of them onto the already existing instance, but there are still some.
I think, Igor, we can't hear you. I think you are muted again. I think while you're presenting, I think some of the setting is disabling the mute.
Don't have it.
We can hear you now, but when you, I think, presenting, I think you, I think by mistake something is happening which mutes the session, I think.
That's strange. You mean the slides or the what? Or here in Karpenter?
I think when you're running the demo, I think it's happening some issue. because we can hear you now. We can see your demo as well. But I think when you're running something, there is lots of noise happening and voice goes off.
That's weird, because the demo is not on my laptop anyway. So let's see. But I see my mic moving, and I see.
I think that's I think when your mic is moving, is causing moving noise.
No, I mean I see the level gauge is moving, so I see that my mic is working. It's not off. That's the thing.
Okay.
Let me try to switch to a different mic, maybe. Not sure if I can do it on the fly, but let's try. Me? Hey? I guess not. Okay.
Yeah, I think you can continue now. I think it's stable.
All right. Okay, great. Well, so back to the demo. One very simple thing that you have seen already, that of instances, and that it has deployed different instances for different workloads. And let's delete it, and let's see how it will basically remove all of them. But okay, I told you that. I also told you before that you can do consolidation. So in my case, the time for the TTL will be 15 seconds. So you can see that in 15 seconds that already the instances were shut down almost immediately. Sorry, not 15, but 5 seconds. But okay, I wanted to also demonstrate how the consolidation works. I also prepared the example of provision definitions. So this was the one we were using now. We were doing everything in spot instances, but now let's do consolidation. Consolidation is enabled just by providing, well, consolidation enabled equals true. Let's deploy that provisioner, and then maybe let's generate a little bit different. Let's generate a different load. For example, I have a script that would launch like a lot of pods with a little bit random loads. It's also there in the GitHub, and I can see I have already created the namespace called load, and now let me launch, for example. Okay, maybe not 500, but let's start with the smaller numbers. Let's say we have whatever. So 99 pods with the batches of 33 pods. So we should produce three batches of 33 pods each. You see that already it started to provision some of them on the C5 to X large node that we had been running before. And now it's gone again. But luckily, we can fall back to the EC2 console and see that it again starts to provision more instances. Now it's only one. But what if we launch something else? Let's say three more batches, but now more pods. You see already like two more instances, one again 24x large, one 48x large. And if you see, so when the KubeOps dashboard will come back to life, you will see that you see already that this one forward is packed like almost 100%, because you see on the left there is this capacity scale, and you see the CPU capacity is 64, and the reserve and the requested is 63.1. So it's basically almost like 100% of the whole CPU load is used by that by our workloads. And of course, it's so that the scheduling is not yet finished. We still have plenty of nodes. That's why let's wait a little until all of them are operatable. Meanwhile, by the way, I can have a look. I can have a look on the questions if there are any. Is Karpenter able to recycle nodes as in automatically replace nodes one by one to bring in new node or instance configuration with as little disruption as possible? Yes and no, because so what Karpenter does, it launches the instances. It launches the instances on demand. I don't think that now that right now it supports this refreshment operation as such. Of course, if we are using the spot instances, this refreshment will happen automatically, because the spot instances will die essentially, or actually they will be taken back, and then and they will be it will be refreshed. But there is no support of the refreshment as of now. However, the Karpenter is being actively developed at the moment. That's why maybe in some time in the future we will see such functionality. Because as I said, even the defragmenting that I saw shown you already was not there in a previous version. That's why it's been actively developed, and you can contribute to it as well. Right. So we can see already that the instances are provisioned. I think we are done. Scheduling now, and we can see that also in the cluster detail, we can see that now we have we still have like one node group, but we have a lot of running pods, and you can see like a lot of them. And yeah, so now let's try to see if we will be able to scale it down effectively. For example, you remember that we have now like 1, 2, 3, 4, 5 different instances launched by Karpenter, and also by the way, all those 5 instances are of different families and different sizes. So we have C6A, like two sizes, C5N, one size, and R5DN of 2 different sizes. That's of course the benefit we have while we are also using spot instances, that you can do it freely. But now let's see if we are okay. Thank you, KubeOps. It finally went back. So now let's see. Let's see the batches that we have been deployed, and let's just sorry, and let's I forgot the namespace, I believe. Yeah, and let's see if we will be able to if the Karpenter will be able to compact or to consolidate the pods if I will just delete some of the batches. Yeah, and let's see. Let's just delete the half of them. Oops, sorry. And let's do it. And maybe 4 of them. Right? So the batches are gone. Let's see how many we have left. So we should have been left with 66 pods. And now let's see what will happen to our instances. Right, so as you can see, instead of all those different instances, what we are left with is just with one instance that is able to accommodate all the pods. So it not you saw that it not just remove the pods, but also reschedule them to pack them together on the existing nodes. And if it would be possible to scale the node down, it would do it as well. And maybe if we still have some time, one last thing I would like to demonstrate is how the taints work. What if you don't want to put like all the eggs in one basket? That you don't want to you want to limit the amount of pods being launched on a specific on one instance, because if you have like small disruption budget, it means that if, for example, you have this one huge instance, but if it's being taken away from you because of the way that spot instances work, then you may lose basically like 2/3 of your cluster. In order to fix this, we can do first of all, we can restrict the number of nodes, or number of pods per node, even in the provisioner configuration. For example, let's do it now. And then let's launch the same workload that we had with 99 pods altogether, but with batches of 33 pods. Of course, the KubeOps doesn't display anything now, but we will see what is getting scheduled. As you see, now it schedules not like one huge instance, but actually smaller instances. Instead of like one big, 3 smaller. And this is because we have put this restriction, but also you can have this restriction not only on the scheduler level, it will be globally, but also on the pod, on the deployment definition level. For example, I think I prepared one of those. It's this one, and you can define the topology constraints in the deployment definition. And again, the Karpenter will respect these constraints and deploy your pods accordingly. All right. Yeah, we still have some smaller instances starting up, just like to handle very small amount of leftovers, because T3 medium is quite small. Yeah, so here you have it. All right, that was the demo part. I have prepared this. I have prepared some slides to go through if my demo would go wrong, but actually it went okay. The only thing I wanted to show you as well, I'm not sure if I showed you, is that the comparison of the pod scheduling with Karpenter with the ones through Cluster Autoscaler. So as I mentioned, one of the scenario would be to launch some bigger pods where the nodes are not really that big. So as you can see, we have much more diversity in terms of launching different instance types and bigger instance types, and that makes Karpenter work very well for the deployments which are good to work on the spot instances. Because with spot instances, the more different instance families and instance sizes you define for your autoscaling group, the better. The bigger are chances that you will get the spot instances. That's why Karpenter works very well for such scenarios. And in any way, if you would like to read more about Karpenter, you can always visit the its official documentation, karpenter.sh, and you can always reach out to me on Twitter to ask about Karpenter or basically anything else about AWS.
Thank you very much, Igor, for the wonderful and marvelous talk with the decent demo. So I hope everyone enjoyed it. If anyone has any questions or anything, please feel free to connect with Igor on the social media as well. So thank you very much, Igor, for your time and the effort what you have done for explaining the demo and presentation. So have a wonderful evening and have a wonderful sessions ahead. Thank you very much.
Thank you. See you.
So the next one we have got is the next block of speakers. We have got Daniel Jasnik from Czech Republic. So the topic he is going to cover is modern DevOps organizations design. So let me introduce you, Daniel, on the stage. Okay, can you unmute your speaker, please?
Sure.
So
do you hear me?
how are, yes, we can. How are you doing, Daniel?
I'm good, thank you. How are you?
I am very well, thank you. And are you excited for the talk?
Sure, I'm very excited. I look forward to speak about modern cloud organization design.
Yes, we have got very good background in your back, Microsoft and so many big companies logos. So
Sure.
anyway, I will add the presentation on the screen, and the time and stage both are yours now. Thank you.
Thank you very much. And hello, everyone. Good morning, good afternoon, or good evening, whenever you are listening to this. My name is Daniel Jasnik. I'm the cloud culture and cloud transformation architect in Microsoft. I work with customers on their cloud transformations, primarily from the standpoint of if you divide IT to people, process, and technology. I work with them primarily on the people and process part. So basically helping organizations to transform themselves from the process perspective, from the people perspective, from the organization perspective, governance perspective, management of change perspective, operations perspective, all the processes such as ITIL, IT4IT, DevOps, Scrum, and Agile, and anything what is needed in today's world, in the cloud world. And today I'm here to share with you the basically approach what has been noted by several organizations in the world, including Microsoft, and adopted by a lot of organizations in the world, including Spotify, Facebook, Microsoft, and many others, what are using the cloud to their most benefit. So if the previous session was very technical, this will be like more organizational, people and process focused. So I hope you will enjoy it. So let me take you through the session content, what we will cover. So we will look at the traditional and modern ways of the cloud usage. We will also go through how traditional IT delivers actually value to the business, how in compare with that modern IT delivers value to the business, how modern cloud organization design looks like, and of course there are many ways how to achieve that, but I will show you one of them, which is publicly available. How the platform team looks like, how the workload team looks like, and then what would be the modern IT outcome. So if you would transform your organization in such a way I'm describing, what's supposed to be the outcomes you can achieve with that. So are you ready? Let's go. So if you look at the traditional versus modern use of cloud, usually you have some on-premise data center in the beginning. And we can say you have it in Azure, and the Azure would be the way to go, the Microsoft Cloud. There are two options you can go to. With many organizations and customers, I see as a consultant and architect that they actually use existing IT processes. They use existing governance and existing policies. They use existing security and risk controls. They use same culture. They have not changed any people management skills, like people change. They don't use management of change to change their people mindset. And they have same approach to user and employee experience. They use same tools, IT for IT tools, meaning tools for patching, tools for monitoring, tools for management, tools for software distribution, etc. And of course, with all of that, basically you have new tool, cloud, and you use it the same way as the previous on-premise environment. Unfortunately, with that, it usually leads to current state of affairs with a lot of issues and inefficiencies, same speed, less control, similar results, and business value is limited, and there is some additional effort the teams needs to make to really work well with cloud. On the other hand, if you invest into the transformation, and if you say you want to play the new game and work in native cloud, you need to make or create or manage a couple of things. You need to establish your IT new processes. We call it in Microsoft modern service management, which would stand for like modern ITIL, modern processes, modern governance, modern policies, modern security and risk controls. And you need to establish DevOps. That's why we are here all today. So DevOps and modern service management, both together, not only MSM or only DevOps. That doesn't work usually. Then you need to work with cloud native IT tooling, what means that you try to deploy everything with the cloud native applications, cloud native services, and not use any on-premise or not native technologies. Also, you want to change the culture. You want to change people, because the people mindset in DevOps, it's the critical thing to achieve, and we will discuss this later. And also, you want to change the end user and employee experience focus. So you want to change your people, your IT people and your business people, that their primary focus is not anymore to deliver service with some performance on some SLAs, service level agreements, which was what was happening before. But what you want to do is to really ensure that we focus on the end user experience. So you focus on the employee experience focus. So on my employees as an organization and on my end users and consumers of my services. If with this approach, you really get to a new state of affairs, and you will have a lot of benefits of that, and you will see what benefits you have in the end of the presentation. If we have a look on a little bit funny presentation or funny comparison with what I was talking about just right now, if you imagine the horse and the car, and the horse is pulling the car, that would be our current environment. So basically, something what we have done in 18th century, let's say, and it was working well. Everyone was riding a horse. Everyone was being pulled by horse. Probably not this such kind of car. That's why it's funny. But it was maybe a little bit different type of car. But what happens in many organizations is that what they do is actually they modernize the car. They take cloud environment, they take all the new beautiful tools, and they say, this is my amazing cloud organization. But the horse is still pulling the car. There is no Ferrari engine. There is no Lamborghini engine. There is still the horse. And the horse represents the everything what is about modernization, what needs to be modernized, the things I've discussed previously, DevOps, modern service management, culture transformation, and everything. So if you really take all these through, you become a truly professional cloud organization, which can be represented by Re-Auto. If you have not seen that, you can visit re.auto, where you see this really automated car, which works fully automatically based on all these sensors. We can refer to Tesla or some other types of cars which already has it partially. So you see this difference, yeah? So I'm using still the horse, or I'm using really the modern technology, 4 motors, fully automated, fully organized in different way. So how traditional IT actually delivers value to the business? So if you look, when we would have a look at how traditional IT delivers value to the business, we can see that people, process, and technology actually supplies the platform with their work and resources. On the platform, we usually build the IT service. And this is all what happens in IT. So in IT, I built an IT service with my people and with my products. And I hand over this to the business. And in the business, they take it, they kind of rephrase it to line of business application. They take they use it by their business process, and they deliver some product or service to their end users or to the consumers, to their customers. Why business does it? Of course, to compete with their competition, to build some new markets, and to innovate. But when you have a look how the IT actually receives feedback and how long it takes, you see that the demand from the business needs to go from the product to the business process, to a line of business application, then to the IT service owner. And when the IT service owner gets the demand from the business, he might or might not actually work with that and transform it to some feedback to the platform team. And platform team might or might not to send it to other teams. So as you can see, there could be a lot of issues in this model. And there is this classic friction between business and IT department, which we know about, and that's why a lot of services became unusable. After some time, customers became unhappy, and that's why also DevOps as an approach and Agile went to be used very much. There will be one friction between IT and the business, the most known friction. But of course, there is a friction or misalignment also between all the other groups, because between the first group, between people, process, and technology, there is a friction between them and the platform. And there is a friction between IT service owner and what platform teams delivers. Because it's different people, different teams, they don't communicate to each other often. So they deliver something, they send it by a ticket, or they send it as some delivered product. And if there are any issues, it takes some time, and so on and so forth. If we have a look on what happens inside of each of these boxes, inside a people, process, technology box, there is a development, right? There is a dev team. And dev team wants to deploy as many features as possible with finishing the code as soon as possible. And they just want to have it deployed. On the other hand, test wants to have an easy writing of their test cases, easy to test code, but dev doesn't care, right? They don't care about their test cases. On the other hand, test doesn't care that much about how many times they return failed test with bugs to dev. And when it comes to operations or security, those often seems like a bottleneck, right? Because security wants security. On the other hand, development wants velocity. And if we look at that way on that, the operations is the same. Operations want stability. On the other hand, development wants velocity. And these are conflicting objectives, right? And we have different teams what wants different things. That's why we are here to talk about DevOps, because DevOps majorly solve that if it's done right. If you look on the platform team, that's the same. There is application team, there is database team, there is operating system team, there is infrastructure team. And all of those teams has their own goals, own objectives, and they don't collaborate with each other. And there is a friction between all of them. So much friction. So much misalignment. What that means for the business value? What it means for business value? It means that basically it will take ages, the business value to be delivered, and there will be so much waste that it will really create a lot of inefficiencies. Yeah. If we zoom in a little bit, I can show you what types of waste are there. Wastes such as waiting, misunderstanding, extra bugs, which are not, which like extra incidents, in other words, extra features what no one is going to use, hard to test code. Maybe we are over testing, we are testing too much. Maybe we have insufficient tests. We have handoffs because we are handing off to each other, and that takes some time and to understand and to really understand what the other team wants and what the other team meant. There is a knowledge gap between each of the teams. Some teams want over control; they want too much control. Our security team usually wants over process. There is bureaucracy. And again, extra processes, extra features, what is not needed sometimes, and underutilized talent, because we have people who really know some things well, but they are not using their knowledge, and so on and so forth. Yeah? But this would be the main types of waste we see during the traditional IT, how the traditional IT delivers value. That's why the industry had looked to something what is quite old, which is the Conway's law. Melvin Conway was an American computer scientist and programmer and hacker who actually coined what is known as now the Conway's law. Basically, what does he said in 80s? He said that an organization that designs a system defined broadly will produce a design whose structure is copy of organization's communication structure. What that means? That means that basically, if you have an organization, that the organization is the same efficient as your communication structure is. What it means for us, how we should design our organization. If we take a look on Conway's law and we think of that, we understand that if we do a reverse Conway's maneuver, like reverse the Conway's law, and we say, all right, let's design our organization based on the best communication structure we are able to achieve. And once we achieve the best communication structure, let's design the organization structure based on this. So all our teams, all our roles and responsibilities, or the division structure, team structure, let's design it based on our communication structure, which works. And this is exactly what Melvin and Conway meant. So based on that, we saw a book. There was a book which I will refer in next slide. But let me first show you how modern IT delivers value to the business. Modern IT delivers value to the business a little bit differently. We still see the business department here, but it's not anymore the business only, but it's biz DevOps or biz DevSecOps. And we see the public cloud and IT enablement teams in the IT part, right? Before there was IT and business. Right now we have biz DevOps teams and public cloud and IT. So basically in the modern organizations, which I referred to before, we usually see usage of cloud because cloud is an enabler. Cloud is an enabler to modern IT. Cloud provider provides some service, and this cloud service is later then used with some friction, yes, but still it's used by line of business DevOps teams, or we can call them workload teams or product teams. And these product teams, they later then delivers value to the business process and to product, and they build upon that on product on service, again, with the same goals to be competitive, to achieve new markets, to do innovation. Demand, as you can see, go from product service to business process and directly to the line of business team. So there are like four less interactions than it was on the previous slide, because previously it was so many interactions. So here is the team, what is actually delivering value. This is the team what is delivering value. Not before, the team which was delivering value was here in the end, right? In the end part, basically over here. Here was the team which was delivering value. But right now, the team which is delivering value is here. Is here in the start. This is the team what delivers value, okay? So that's different. But you see that we have here some platform enablement teams, because these line of business DevOps teams couldn't make everything working. And how this works, how this could work, I will tell you on different slide. What I'm gonna tell you on this slide is only that these in the platform enablement teams enables the line of business DevOps teams to be productive, efficient, and effective. And line of business DevOps team demand some changes or updates to the platform or enablement by their demand channel. So let me go and show you how this looks. But before that, let me also show you how short is the time. Yeah, you see the time here. It's just this long, yeah, this short, I might say, yeah, as you see the red arrow. If I go back on my previous slide, do you see how long was time to deliver value? This was so long. You see my red arrow, yeah. It took months, weeks, or ages even to deliver value. So let's have a look now how the modern IT actually could look like. That's one of the options. The book which I referred to is the Team Topologies book from Matthew Skelton and Manuel Pace. which really beautifully spoke about topologies which could be used to achieve the success. What I spoke about is that it's smart to create a platform team which would provide an underlying platform on which stream-aligned teams, workload teams, or DevOps teams, or however we call them, can build and support software products and services with really minimal friction. That there also exist these workload teams or biz DevOps teams, DevOps teams, product teams, whatever you want to call them. Here we call them stream-aligned teams, which tries to achieve high rate of flow and value delivery. But of course, these teams doesn't know everything, right? These teams really are oriented to the application, oriented to the product, what they are producing or maintaining. So they can't know how to do infrastructure as a code from the start. They might not know how they should do security in Azure or in other cloud, how they should do, let's say, network operations, how they should do security operation, how they should do governance, how they should do identity, how they should do different things such as RBAC, role-based access control, architecture, monitoring, etc. They might not know it. And that's why there exists something we call enabling team. And this enabling team is actually identifying all impediments or blockers or cross-team challenges and helping these teams by facilitation, meaning by coaching, to achieve their goals. Yeah. So this team it's helping to achieve their goals to stream-aligned team. And there is, of course, not one stream-aligned team. There is more of them, right? So there is another for each product, for each application, there is another stream-aligned team. So there is really a lot of stream-aligned teams, and enabling team is facilitating that. In the start, the enabling team could be the same team as the platform team, because the platform team can be the one who is helping stream-aligned teams when we starting this model. But later then, once everything is developed, platform team supposed to be primarily the team what is delivering platform products. Delivering platform products, well-prepared platform products from in Azure or in Microsoft terminology would be using the ARM templates, Bicep, Azure blueprints, or things what can build infrastructure as a code together with Azure policies, security policies, governance policies, and all types of policies we need to make sure the products are already governed, secure, compliant. So we can, as a governed, secure, and compliant products in form of ARM templates, Azure blueprints, etc., give it to the stream-aligned team to use it. So basically, my platform team is building those kind of products, and stream-aligned team is only consuming those products. So stream-aligned team is not allowed to actually work with different types of environments, except the products what platform team does. So stream-aligned team needs to work only with the Azure technologies or services, products what platform team developed, which are already governed, already secure, already compliant, already operated, monitored well, etc. Because everything is prepared in the ARM template, so it's just a kind of plug and play. I take my ARM template, I change the parameters, and I deploy it, and I'm good to go. And I know it's governed, secure, compliant, etc. Of course, this it's not enough, right? Because stream-aligned team sometimes needs expert help from people who knows things like HoloLens, IoT, machine learning, blockchain, or different other expert areas. And that's why we have the complicated subsystem team or SME team, which actually by collaboration works the stream-aligned team. So the enabling team works with them through coaching. So they coach them, they sit with them for a couple hours maybe, or they just reply on their message and help them. On the other hand, the subsystem team or SME team, they are in collaboration. So if I have, for example, one blockchain expert, and one of my stream-aligned teams needs a blockchain expertise, then the blockchain expert joins the stream align team for 1 or 2 or 3 or 4 or 5 sprints, let's say, he or she helps them to develop what is required during those sprints, and then he or she leaves the team and joins the other team who needs such expertise. So I basically have those experts available in some teams, and I am able to allow them to join other teams just to help the team to build that capability or that functionality what they need to, right? So what would be the platform team responsibilities? The platform team responsibilities would be, of course, governance. They need to set up the right governance, subscription model, management group policies, and everything about governance. They would need to do cost management, everything what comes to cost management, managing of hybrid use benefits, managing of Azure Reserve instances, and so on and so forth. They would need to do network operations. They would need to do security operations. They would need to do identity operations. They would need to do system operations, which would mean to build up those products, those platform products, which I was referring to, right? So this would be the capabilities or functions of the platform. So if you have a look from Azure perspective, from Microsoft perspective, what this platform team does, we can look at Cloud Adoption Framework, which is the Microsoft way to achieve governance. And there are 5 disciplines: the cost management, security baseline, identity baseline, resource consistency, and deployment acceleration. And these are the primary disciplines what this platform team works on. And they works on this continuously to achieve the best governance. But of course, this is the MVP. This is the minimum viable product. They try to work on it continuously. So they identify the top priority things, and they make sure that these things fit into 2-week or 3-week sprint, and they go and deliver it in 2-week or 3-week sprint. But later then they identify another priority things which fit into sprint number 2 and sprint number 3 and sprint number 4. And of course, this goes continuously, and continuously we deliver value by that, and we increase our maturity, and we increase our governance efficiency and effectivity. So that's what platform team does from the governance standpoint. From the operational standpoint, the governance team does things related to inventory and visibility, so monitoring of everything, operational compliance, patching, policy enforcement, workload migrations, resource configuration, etc. Everything what is operational. Platform team also does protect and recover, so backup, data protection, business continuity, disaster recovery. And last but not least, the workload operations, like automation, performance monitoring, etc. And also they care of operational processes, which should be enforced and which should be followed by all DevOps teams. So these would be 2 main capabilities of platform teams, like governance and operations, in many aspects, as I told you previous slide. Of course, the governance team needs to have different skills, right? So if you have a look on this slide, here is like different paths. If you look at the bottom, these are different Azure personas. This is like Azure Architect Persona 1, Azure Architect Persona 2. Here we have DevOps Architect Persona 1 and Data and AI Persona. And we might have different numbers of personas in every platform team. But what is important here, why I'm showing this to you? For example, Microsoft solves this with different types of certifications. So we have different types of certifications to help you to really get on the sufficient level of different persona capabilities. And this is something what is very important, so that in the platform team there are people not all the same knowledge, but there are kind of T-shaped professionals. So I know the basics of all the platform, and then I'm expert in DevOps, then I'm expert in CI/CD, then I'm expert in security, then I'm expert in identity, and then I'm expert in AI, or then I'm expert in data, or then I'm expert in solution engineering. Okay, so I have different people. Let's say if I have 5 people or 6 people I tried that all of these 6 people are having the different path, different learning path, different know-how. Of course, ideally, it's to have 2 members per each path, because if I go to vacation, my colleague can take it over, or vice versa. But not always this happens, so because not always the platform teams are that big. So at least one, but the primary goal here is really to have different personas, so at different learning paths. And this is one way how you can show. You can see the DevOps persona needs to learn Azure fundamentals, data fundamentals, AI fundamentals, security and compliance fundamentals as a fundamentals accreditation. Then they should learn Azure administrator, which will be secondary. And later then, this is the same for everyone. And later then, this persona would learn Azure developer, AZ 204, Azure DevOps engineer, AZ 400, and then DevOps Dojo, which is kind of Microsoft DevOps professional certification or learning we have available. So this would be platform team. So let's have a look on the workload team. If you have a look on the workload team, the workload team structure should be following. We should have the workload team is the application team who's delivering value, the product team or the base DevOps team, the DevOps team, not the platform team, because DevOps team is using the platform team product. So this team actually should have different capabilities. Primarily, they should have some Azure and platform knowledge, because this is the key. They to have really good Azure and platform knowledge. They should also have the general application knowledge, because these are 2 knowledge which is they need to have in general. But they are also T-shaped professionals. So I will have 1 person which will know security very well. I will have 2nd person who knows application very well. I will have 3rd person who knows security very well. Maybe I have 2. I have other person who knows infrastructure very well. I have CI/CD person who knows the CI/CD very well. I have automation person who knows automation very well. I have operation person who knows operations and the ops part, the site reliability engineering part very well. And I have database guy, let's say. These are just an examples. Of course, this expertises could look differently in every organization, different team. But the main goal here is that I have, let's say, 8 people, or the recommendation is 8 to 12 people in my DevOps team, and that each of them has different specialization. And again, it's good practice if I have 2 which does the same, so they can switch during the vacation, etc. But I should try to have really different specializations and different, again, the learning paths for each of them. Because I want to achieve that this team is sustainable. This team has ability to deploy their infrastructure themselves. They can. So we have, as you can see, we have infrastructure SME, right? So this infrastructure SME can deploy the infrastructure themselves. They don't need anyone. They take the platform product and they deploy themselves. They can update themselves. I have security guy who knows how to update their things regarding security and how to make sure everything is secure. We have CI/CD guy who knows how to deploy it well using Azure DevOps, GitHub, or whatever. We have automation guy who knows how to automate things if required. We have operations guys who knows how to do things regarding operations. So
Daniel,
these are, yes, sir.
Just we are running out of time, so could you please wrap up in very shortly? Thank you.
Sure, I will. Thank you very much. So this would be the things regarding the workload team structure, right? So if we go on, the workload team needs to have some key pillars and capabilities. DevOps is a really holistic way. You need to consider people, process, and technology. In Microsoft, we have DevOps Dojo, and which consists of culture, lean product architecture, technology, and different types of 8 practices we have, which were defined based on the Microsoft DevOps team's Microsoft DevOps team learnings during our Microsoft transformation. And this is something also what we offer to our customers and to the public, so you can read about it, and you will see it on my final slides, which comes right after this one. So the different capabilities what DevOps needs to have. You need to have in mind that DevOps, based on the different researches, is the people challenge in DevOps. It's primarily 50%. It's usually 50%. So 50% of challenges in DevOps are based on people. So people are the most challenging thing when you want to transform to DevOps. The process is the other challenging thing, which is very challenging to really change all the processes inside the organization, from project management to product management, from ITIL to DevOps, etc. And all that, it's another 40% challenges. And the technology in DevOps is only 10% challenge usually, because for technology, you have usually manuals on internet or on, and this is not easy, but it takes a lot of effort, but you are in the end able to achieve it. But with people and with processes, it's much harder, because organizations, are very complex, a lot of processes, a lot of people challenges, and these are very hard to address. So if you look at DevOps from mutually exclusive and collective exhaustive perspective, the METSEP principle, you really go and you see that people are 50%, process are 40%, technology is 10%. Last but not least, how you organize in the DevOps organization. So when you want to organize the DevOps organization, you have usually, this is Spotify model. So these are different sectors. So you see different sectors, different teams. Vertically, you have different teams or squads. And horizontally, you have different communities, which these people in different teams can talk together. Yeah. So these virtual communities can help. And then you have some sector leads, product owners, design leads, etc. What it's supposed to achieve? In general, it should help you with all the red to decrease all the red. The modern IT outcomes should be to decrease all the red on the left side. Ideally, you should increase all the green on the right side. So everything what is green here, you should increase. By this approach, everything what is on the left side, you should decrease. Of course, it also depends how you transform, how you do it well. What it means for your business? It means decrease cost and increase revenue in simple words. But of course, again, it means how you transform, because if you 10 times fail to do transformation, then it's probably not going to increase revenue, and it will increase the cost a lot. If you get help for some organization to do it, then it might be much easier. So consulting would definitely recommend. So key session takeaways for this session. So modern IT is more than DevOps. Modern IT is modern service management. It's culture transformation. It's adoption and change management, or people change management. This is really using the cloud native tools and everything what I refer to. Focusing on user experience and end user experience and custom experience, because DevOps is only an enabler to the modern IT. The new tools. Use new tools only with new ways of working. Don't use new tools with all ways of working, with all processes, with all governance, with all compliance, with all security boundaries. That's not gonna work. Always think about Conway's law. When you are designing your team, your organization, always think of Conway's law. If you look at platform team, you have platform team, couple enablement teams, subject matter expert teams, and many workload teams. That's the way how to use this model. One of the models which are available publicly, which I'm referring to. Everyone works agile. Don't forget, everyone works agile. This is not waterfall delivery. Everyone works agile in sprints. So even platform team delivers their platform products in sprints, 2-week or 3-week sprint. And all of them are T-shaped professionals, at least 2 per 1 specialization. DevOps challenges. So that would be, and the last one, DevOps challenges are 90% of people in process. With that being said, I would like to also share with you that if you would be interested for sessions tomorrow, which are the paid track, I have from me the 2 tickets available for tomorrow. You can actually reach out to me on LinkedIn. I'm selling them $100 each, so you can reach out to me on LinkedIn. I'm happy if you reach out. I'm happy to sell it to you since I have no use for them. So 2 tickets available. Thank you if you reach out to me. And the final slide, I would like to share with you how you can learn more about this session. So you can learn more if you contact the local Microsoft team, Unified Support or Microsoft Consulting. You should ask for Culture and Cloud Experience Team, CCX or MSN. You can also visit Microsoft portal, aka.ms/CAF, Cloud Adoption Framework, where you learn more. And you can also check the devblogs.microsoft.com/devops, where you can find more about DevOps Dojo. Or anytime, if you want to learn more, or if you want to buy the ticket for $100 for tomorrow, which usually costs $325, please contact me directly. Add me on LinkedIn. I'm very happy to add you. My name is Daniel Jasnik. This was my session about modern cloud organization design. Thank you very much, and I hope you enjoyed it.
Thank you very much, Daniel, for the marvelous, insightful, and the detailed talk. So I hope everyone enjoy it. So thank you very much for your time in explaining and putting the efforts on the conference as well. Thank you very much, Daniel. I will speak with you soon, and you enjoy the rest of the evening and the rest of the sessions and the conference. Thank you, Daniel. So the next speaker we have got is Javier Re. He's a CEO of Crodar. He's from Argentina, and the topic he's going to cover is how to assure the quality of microservices with automated. So let me introduce you, Javier, on the screen. So hello, Javier, how are you doing?
Hi, hello everyone. Can you hear me okay?
Yes, we can hear you.
Okay.
So are you excited for the talk?
Yes, a little bit nervous. That's English is my second language, so I expect to do it.
That's okay. That's fine. That's manageable and that's understandable. Don't worry about that. Okay. I will add the presentation on your screen. So the Javier, time and stage both are yours. Thank you.
Thank you, Shahil. Okay, hi everyone. Well, this is I'll try to make a quick presentation talking about a specific implementation of some of the practice that we need to take into account in the DevOps process. As Daniel mentioned, many of the things related to DevOps are mainly a cultural change. So we are talking about this a little bit, but then we will review a sample scenario where you can put some quality process in place in a pipeline to accomplish the quality assurance of the microservices, and then some small outcomes of that experience and some best practice to share that eventually we can share lately in a more deeply conversation. So let me introduce myself. Well, I'm Javier Re. Yeah, that Re is my surname. It's very short. I have some stories about that from my childhood when I was young, so not matter right now. Husband and father of 2 kids, very proud. I'm a software engineer and master of business administration, a bass player. I say always that it's a continuous learning because I'm still learning. It's difficult for me, but I don't give up to that. I have more than 20 years on technology experience and very fan of the quality assurance, agile and DevOps methodologies, and CEO of Crodar, where we implement some of these practices that we will share. So basically, what is about DevOps? There's many conversation about this, and I try to be concise on this. Basically, DevOps is a cultural change, a cultural shift to move to a more collaborated environment where we try to eliminate the silos between different teams, which is usually a big problem. So the most important thing, since my perspective, and probably many of the speakers in this event, is that the cultural change to eliminate silos between the different specialities and the different skills in the teams is the most important thing. But at the same time, DevOps is impossible without automation and without integration of specific tools and software that makes it possible to deliver software small and quickly. So is the purpose of all of this. So basically, as DevOps start as a cultural change and a purpose of eliminate silos between the different areas. At the same time, as I mentioned, we need to automate the integration between these pieces, that the flow of deployments and new code being released many times during the day. Sometimes it has to be a mandate. So in this presentation, we will see how to implement some of the practices with the specific cases in this area, basically starting in the code, in the build, test, release, and deploy section of this diagram. So basically, how we do ensure quality of microservices. If we talk about microservices architecture, the applications are split in small pieces that are isolated, that are independent, and can run and be deployed as a single piece of software. So it's very important to have that split and have the architecture in place to do that, but also adding the possibility to do deployments automatically with a CI/CD pipeline needs some process in place to make sure the quality of those pieces of software are delivered correctly. So as we deploy software very quickly and with a faster changes, we need to make sure that we don't break anything. So basically, the purpose of this is to not just automate the deployment and the build of this piece of software, which is a microservices, but also to run tests on that portion of software in the same process. Otherwise, we will deliver software very quickly, but with lower quality. So it's a critical portion of the pipeline to do functional testing, to do automation testing, and also eventually to do non-functional testing like performance and security check-ins. So in this case, we will just talk about functional automated testing, but it's not less important to have in mind all the other kind of testing. So the execution of those tests must be done each time that the microservices is deployed. So that generates the need of automate a small set of scenarios, just checking that microservices in a specific behavior, and then later on integrating them most in the rest of the deployment. We will see a sample of pipelines later where we can see how to do that. So the other point that is important to define when we try to automate or to keep the quality of microservices is a simple step-by-step approach, is to identify the endpoints that we want to automate the test. So that's the behavior of the microservice that we want to automate and deploy, and also have some feedback, right? So we need to understand that the test automation is a tool to help the developers to have quicker and fast feedback if something is broken. So we need to understand how this change or how the code that the developer just committed affected in a good way, implementing the functionality that is purpose of that change. But not just that, we need to also make sure that the developer doesn't make or don't inject a bug into the code and break something else. So the purpose of this test automation is, as I said, is to provide fast feedback. And the way to do it is, as we will see, to integrate into a pipeline. So basically, here is a very popular picture that I like to show in these presentations, because shows very easily how the automation testing approach has to be implemented to be efficient and to add value to the process of development. So basically, in the traditional approach, or mainly in the cascade approach that we used in the past, there's a few unit tests to check some pieces of the code in a method level or a very low level. Then we have some automation, but in more a kind of regression kind of automation at the end, and then a lot of effort doing UI manual testing to prevent bugs, and which is a specific approach that is initially stated by Martin Fowler in their blog. So we'll have at the end the links to this paper. The idea is to increase the number of tests in the base of the pyramid and decrease the number of tests in the automation piece to the top of the pyramid. Why? Because at the bottom of the pyramid is more efficient and more cheaper to build and to write those tests, and more cheaper to execute that. As soon as we move up to the pyramid, so from the backend or from the code passing through the backend to the UI, the automation is going more and more difficult in two terms, basically into the effort to write those tests and to maintain those tests, but also the time that we spend to execute those tests. So basically the big base of the pyramid has to be unit test. Then we can make component tests to test the microservices isolated, or in a way that we can test their interface, their behavior, but very, very basic behavior. So let's say we try an endpoint, and we can check if that endpoint responds with a 200 response code or a 400 response code, and with that would be the test. Then we add more functionality to those tests, and we can test the contract. The contract is the interface that exposes the microservices. So we can write tests to check if the JSON provided by the microservices, either in the input or the output, is correctly formed. If that contract is not working, it doesn't make sense to continue testing the microservices in a functional way, because the contract is broken. So the very basic kind of test that we can write at the very beginning, after the unit test, is to write component test and to write contract test. So on top of that, we can write behavior test in an automation way. So we can test the backend of any application, testing the microservices, but in a functional way, not just testing the response code or the contract, but writing a specific business scenario that has to be executed by the backend. And so in that case, we can write cheaper in effort test using just the backend, and also run those tests very quickly and very often. So with that approach, we can detect or prevent bugs, as this approach state, more easily and with less effort. Think that a UI test automation usually takes 4 times in time of execution than an API test. So it's a matter of trade-off that and taking advantage of those kind of testing. And obviously, exploratory testing is on top of the pyramid and is not optional. So we cannot replace completely the exploratory testing with automation. We need to combine and complement that. So moving forward, what is the approach that we propose, and after many implementations in projects, we think that is the best approach, and it's part of a paper that one of the members of our team write, that will be at the end of the presentation, a link to share that. Is basically a split to start in a sprint. right at the beginning of the sprint, when we need to write a user story, as BAs or product owners write that user story, immediately after that, we need to start writing acceptance test criteria. Basically, that is a job that the testers and the BA has to do using the user stories as an input. With that approach, we start from the very beginning of the sprint to write criteria and scenarios that then we will test as soon as we develop the code. So this approach set just at the beginning of the development sprint, as soon as we have all the user priorities written and the backlog prioritized, the developers start picking user stories and using the acceptance criteria to test that user stories before integrate the code. So that is very important, because at this stage, the developers and the testers work together to make sure that the quality of the pieces of software, in this case microservices, are built, fit and match the quality expected, which is the acceptance criteria. Then we can add more tests, but at least in the first approach, which is the sprint, where the code is written, we need to write the test and execute those tests. We cannot wait at the end of the sprint. That is a bad practice. So as soon as the developer starts writing code, the tester starts to write tests and to automate those tests. So look at this, that at the very beginning of the development process, we start doing automation. So this is a big recommendation, because otherwise all the test automation will be at the end and at the sprints, or probably later on the following sprints, and that generates technical debt and generates a problem of the tests don't represent the real code that is underdeveloped. So that approach, so writing the test automation after the sprint that the code is built, is a bad approach, because sometimes generates disassembly between the code and the test. We will see some of the problems that has that approach in the later in the presentation. So as soon as the development is complete during the sprint and the tests are complete, we integrate the code into a feature. So in that integration, devs and testers work together to make sure that that integration of microservices accomplish the purpose of the expected behavior in the user stories. So let's move quickly to make sure that we can share more. So it's not, I mentioned that the only purpose of having automation in place is not just to having a green dashboard with all the tests passed and don't give any value to the process. The only purpose of the automated test in many areas, as I see in the testing pyramid, is to add value and to accelerate the feedback to the developers. So basically, this is a general pipeline where as soon as we commit and merge the code, we build test, very basic test, unit tests, static code analysis. So this is the first stage of quality control into the pipeline. Then we deploy the component, and then we run two specific automated tests. One is a smoke and a small regression. So this is a traditional pipeline, and at the end we do a UAT. So in the automated test, we do installation and deployment test, integration test, functional test from UI and API, and non-functional test, as I mentioned. And then at the end, we run a UAT. So this is a manual exploratory testing or demos that we mentioned in the pyramid as well. So going deeply a little bit, if we look at the commit pipeline, which is a small pipeline that is run every time that a developer commit a piece of software, we do the same basically. But in this case, we just see the portion of the pipeline that is repeatedly executed each time that the developer made a commit. It's not a release pipeline, it's more a commit pipeline. So as soon as we, as a developers, commit code, all these small regression and smoke tests are executed. So we don't need to wait until we have a release candidate to execute automated tests. We run automated tests every time that we commit code. With this approach, we shorten the period of executing automated tests. The tests are executed more frequently, so we can feedback the development team much faster than on each release. So we accelerate the feedback to the developers, and they can fix expecting code. Sorry for that. What happened when we have a release candidate? So we have a feature branch that will be shipping with a set of changes or new features. We execute the same piece of process that we mentioned in the candidate in the commit pipeline. We run always the unit test, the static code analysis, the low-level integration test. We do the deployment, and we do the automated test, including the installation, integration, functional test, and non-functional test. But then we do the acceptance test, including the manual and exploratory testing, and a full regression in parallel. That regression of test will be an automated test set as well, but is a full regression. So we don't run the full regression in each commit. We run in each release pipeline, release candidate pipeline. So why we do that? Because we've been executing small regressions all the time in each commit, and if we do a regression test all the time in each commit, probably takes longer and doesn't make sense to accelerate the feedback. So finally, we do the UAT with the exploratory testing and demos. So, no, sorry, this slide is a little bit messy. I don't know why. Probably it's a matter of StreamYard. But basically, what I like to show you is a small sample of a real microservices that is built on Node.js, and a sample test automation code that tests that microservices, and also a pipeline that includes that test automation to show you how to integrate that into a real pipeline. So for this demo, I will use GitLab.com as a CI/CD and a code repository tool, and also I will use Lipia, which is an open source framework built on Java that lets you write tests in any platform and in any application without depending on writing the same language that the code is developed. So if we look at this picture, just to show quickly how this architecture is built, Lipia has basically a core framework, which is an open source framework. You can see later on GitHub eventually. That has many connections. One of the connections is basically integrate with any test management solution. Then they have different supported reports like console reports or extent kind of HTML report, or you can connect to a report provider like report server in Lipia, which is not the case. We will not show that, but it's possible to do that. But also Lipia is able to integrate with web apps, mobile apps, backend, and Windows apps, and also in the backends with databases or APIs. In this case, what I will show is how to write some test using Cucumber language with Lipia, and using testing REST API, not a database, but is something that is possible as well. And I will integrate or show how to integrate or how to run this test written from a GitLab pipeline. As you can see, Lipia also is able to integrate with many other pipelines solutions, but in this case, we will show you with GitLab, which is a popular solution nowadays. So let me share my screen. Okay, so basically I will show a little bit of code. I think that is okay. Looking some code. So basically what we have here is too many projects, right? It's two different projects. One is the backend of the application that I tried. So the microservices that I try to automate. So basically this is the code of the microservices, which is basically an attachment microservices that let an application to attach files to a specific item in a test management solution. So this microservices has the responsibility of just managing attachment. So no matter what is the item that I'm managing, I want to attach a file to that, and that's all the behavior that I expect. So basically, this is the code. I will not review the code of this Node.js microservices, but I want to share with you the pipeline that we will see. But first, let me show you the test that we written to test that microservices. So for that microservices, what we have here is a test automation project. So if you look at this, we have two different source code projects. One is the microservice itself, which is the Node.js code, and then we have a project, a specific project in the repo based on Lipia, where we rewrite the code to test that microservices. So in this case, we have many features. Obviously, these are all the tests that the application that is under test is performing, but we will just choose the test attachment manager, which is the microservices that I mentioned, which is responsible to attach files to a specific item. So in this case, we have a very simple feature, which is a crude kind of test, which is create attachment, get attachment, and delete attachment. So basically, in these scenarios, what I try to do with this test scenarios is to perform operations using the API, but not using the front end. So we can write with Lipia, which support Cucumber, which is an implementation of our support for Gherkin language, which is a high-level language that we use to describe behavior and to test with behavior, is to write the specific code, which is very easy to understand by a product owner or a regular tester without knowledge of programming skills. So in these scenarios, we have these three tests, and if you can see, this is a very basic test, which is as soon as I want to create an attachment, I perform the operation with the attachment, the file name that I want to attach, and the parameters. And I expect, so this is the validation of the test, that the status code is a result specifically, in this case, a 201 status code. So in this other test case, we expect a status code of 200. So with this information as an input, we can model the scenario and eventually use different sample tests or sample data to run this test with the same behavior. So that is a very powerful tool that lets you write a single scenario and include many sample test data to execute that. And in this case, I made a little bit more complex scenario compared with the previous one, where when I try to delete an attachment, first I need to obtain the ID of the attachment and then perform the operation of deletion. So that is basically the test that we will show. These scenarios are written in Gherkin, but then those Gherkins are written in code, basically. So what we do is to manage to map these steps, each of the steps like this, with a piece of code in Java that lets the test automated to interact with the application. So let's move a little bit quickly. I have a sample run it first here, but let me clean my console. So I will run this test, but as this project has many features, as we can see here, we have many features, but I don't want to run all these tests. I just want to run the related to attachment. So I will run with this command, which is a Maven command, just filtering the tags related to attachment. So in this case, I will run from console. So this is the job that test automation engineer will do during the sprint, as I mentioned in the pipeline. So I will run this test, make sure that it works, and as soon as this works, I can provide feedback to the developers. But if you can see, this is run very quickly, and it lasts 18 seconds to these 3 different tests. And given this result, I obtained the result of the execution. You can see in green that all the results are okay. So basically, the run throw a result with 3 tests okay and 0 failures and 0 skipped tests. So as soon as we run this, we are okay. But what happened here? I'm running this test in my computer, so it's not providing value to the developers. So to do that, we need to integrate into a pipeline. So let's see a pipeline, a real pipeline in GitLab. So basically, what I have here is the code of the attachment manager. So the microservices in this repository is the proper code of the microservices, as we see before, and then here we can add into the pipeline of building this microservice a specific stage. So what we have here, if we can see, is a pipeline that build the solution with different stages. So let's see in Visual Studio Code to make it more easy. So here I'm showing the same pipeline, the YAML file that execute all these steps needed to basically build the code, package the code, deploy, and test. So basically, what we have here is some variables, some specific variables that I add to this pipeline, so that are needed to execute the test that I just showed you in the other project. So here I reference the code, the repository location of the test, and these variables I will be using in the steps. So as soon as the stage are executed, sorry, these packages or these stages of the pipeline are the standard, and it's not detailed here to avoid noise in the presentation. But the testing stage, which is here, is mainly responsible to execute the test that I just written into the the other projects. So what I do here is to instance an image of Lipia runner, which is a Docker file that I use to run the test. And I write, before running the script, I run this specific clone.
Javier,
Yeah, sorry.
We are running out of time, so please wrap up quickly.
Yeah,
please.
I'll try to do it quickly. I started a little bit later, so I try to move it quickly. So basically, the first step is to clone the code, then run the command that I showed you in my computer, and depending on the branch that I'm merging, I execute a specific tag or a flow regression test. So to avoid running this right now, which takes some time, I will just show you the result of this execution using the logs of the GitLab pipelines. So basically, all these are runs of the pipeline that I executed and was executed during each commit of the development team. And if I see the details of this, I can see that the pipeline has many stages, as I can see here, right? Build, backcache, deploy, and testing. So each of them has their own results in the log. And if I see the test results, I can see all the results that are through the console. And at the end of the pipeline, in this case, I run all the full regression tests with 66 scenarios instead of just 3 that I showed you in my computer. And these pipelines are executed successfully. So the build is successfully, and as you can see, the pipeline execution was passed. So in this case, for example, some of the tests failed, so the pipeline was stopped and the deploy was not executed. So this is an important topic to make sure that as soon as we deploy code, we test accordingly with the automation. So going back to my presentation, let me share it. One last 2 slides is to explain a little bit that not all is nice in this kind of a scenario. One of the things that usually happen is that we can have flaky tests. Flaky tests are basically when test fails or pass in the same version of code, so it's not predictable. So basically, we need to prevent those flaky tests to avoid having a false negative feedback to the development team. So common causes of flaky tests are asynchronous wait. So when we execute a microservices that depend on another, probably that microservice is not ready yet, or even in between the UI and the backend sometimes happens. Concurrency, when we have different microservices acting at the same time or running tests in parallel, that has some problems because of that, or missing data or inconsistent data. Also, internal server errors or resource leaks, when we have a service that is needed to perform a test and that service is not available, and that will be a common causes. These are best practice. I don't want to stop here too much, but basically there are some recommendations to avoid that, which includes basically manage the test data programmatically to make sure that the data is available, collaborate between devs and QA to make sure that the code are aligned, that the services are available, and also add negative scenarios to automated tests to test the specific behavior that are not the common ones. So basically, this is all the learnings and that we obtained from this presentation, and I hope that you obtain from this presentation, that basically automated test helps to ensure the quality of microservices. we make sure that the quality in each release and in each commit by running frequent test automation and having those pipeline in a CI/CD pipeline. Those tests in a CI/CD pipeline is very important. It's not enough to run in a local computer of the developer. We need to integrate into a pipeline to make sure that the results are good. And obviously, this helps to reduce the testing effort, which is sometimes difficult and takes a long time to do a full regression. So this is the reference that I used to prepare this presentation. So anyone that needs or wants to go deep on this can use these resources or contact us eventually. This is my contact information and our website at Crowder, where we provide specifically these kind of services. So I think that this is all that I have. Sahil?
Thank you very, very much, Javier, for the demo and for the nice, insightful, and marvelous talks. So we have got 2 questions, very quick ones. First one, both are together. So first part one is, what is your recommendation for integration test for a service that has an external API as a dependency?
Okay. Well, in that case, it depends. But if you have an external dependency that you are not sure that it's available all the time that you run your test, probably a good approach is to build a mock. Basically, a mock is a double of or a stub of the service that you need to test integrated, and act as a fake service. So if you are not sure that that service is available, building a mock with the same contract of that microservice could help to run those tests and avoid the dependency of having that microservices up and running all the time. So you focus on your test or your specific behavior, but the dependency of that service is not tested in that process. Probably you need to write a specific test to test that service. But if it's not available all the time, and I imagine the question is related to that, you can write a mock. There are many things to do that.
Second question based on the first one. So far, I know about the mock server to provide the HTTP response to simulate the expected API behavior. Would you suggest another approach?
No, that I think, well, it's what I mentioned is a good approach to use that. There are many solutions to do that, to do mocks, basically. Insomnia is one of them, for example, that is pretty new and very popular now. But there are many. What I suggest that is to write mocks to do that, but also make sure that you write tests to test out the specific service. Don't forget to test out the specific service integrated sometime, because otherwise you trust in a mock, and eventually, if that contract change of the external microservice and you don't test it accordingly, you have an issue in production for sure. So don't forget to test isolated and then integrate as soon as is possible.
Okay, I think that was the end of the question answers. So thank you very much for your time and effort for explaining the nice topics and the demonstrations. So I hope you enjoy the day and the rest of the conference. So thank you very much for your time. Thank you, Javier.
Thank you, Sahil. Thank you for inviting me.
Same to you. Bye. So the next speaker we have got is Alejandro Portela from Switzerland. He is a DevOps consultant at AWS, and the topic he is going to cover at DevOps and security at scale. So let me introduce Alejandro on the screen. So hello, Alejandro, how are you doing? I think you are on mute. I can't hear you.
How about now?
Yes, I can hear you.
Okay, great. I'm good, thank you. How are you doing?
I am very well, thank you. I'm very well excited to listen you. So,
Likewise.
are you ready for the screen?
Yes, absolutely. Let me get started. The screen sharing. So, okay. All right, you should be able to see it at the time at the moment.
Yes, I can. If anyone has any questions for Aljero, please type it in the chat box. We will be having after his sessions. So all the stage and time both are yours, Aljero. Thank you very much.
Wonderful, Sahil. Wonderful. Hi, everyone. It's very exciting to be here today, especially talking about a topic that is very dear of mine. My name is Alejandro Portela. I'm Spanish. I'm based in Switzerland. And today I'm here to talk about how the best practices of how to build a certain, let's say, DevSecOps practice. Oops, I think there was something wrong with the presentation. Just give me a sec. All right, I hope you can see it now. Yeah, I think so. All right, so as I was saying, I've been in AWS for around 1 year. My focus is in automation and security. Little before that, I was working in a slightly larger companies here in Switzerland. And before that, I was a fan of the startup community and the startup companies in Barcelona. What we're going to talk about today, I have been following a little bit of the talks so far that happened during today's, and I have enjoyed greatly the deal of technical detail that they have gone into it. I've prepared a deck that it's slightly more abstract and generic, so we can cover also some wider audiences, not just the DevOps, not just like the technical point of view, which for sure we will cover, but also some alternative options, alternative points of view. So before we dig into the presentation, now we're gonna speak briefly about what for DevOps, why we're actually using it, how good a DevSecOps end-to-end cycle could look like, and then of course how to highlight that security is at job zero, not just at AWS, but should be job zero at the industry in itself. We will speak about briefly the responsibility model of the cloud, and as well as the security and native services. So to get started, let's take a step back, because we have been talking about a lot of tooling, about a lot of techniques, and what does it even matter? Why DevOps matters so much? And in fact, the issue is that DevOps increases dramatically organizational agility and decreases failure rates, increasing the security posture. This is what DevSecOps should be about and what it actually looks like. Anytime we have a deployment, or anytime we have a development team, operations and security working on a piece of software, embracing this specific mentality, this specific framework, we are making our organization much more functional and agile. Usually, these successful organizations that decide to adopt this framework are reducing deployment frequency from weeks and months to hours and days, getting new features on the market from 1 month and reducing that release cycles to 1 or 7 days. And very important to gain the trust of customers is as well to be a very resilient and reliable service, meaning that anytime we make a change, we need to make sure that the customers can trust that digital offering, that digital product. So DevOps comes also in hand to actually allows reducing the change of failure rate from 50% to even sometimes less than 1%, in some cases very close from 0%. Those metrics that you're seeing here, I'm taking it away from a DORA State of DevOps report, which is a publicly available document. For those that you don't know about it, I recommend it. Gives very much of good insights about the different topics that are important for those organizations. And in fact, what I know is that just a few days ago, there has been a release of about the 2022. So go and have a look if you're curious about it. What we're talking here is about designing fully automated processes that guarantee resilience when it comes to change management. However, all of this process, all of this construct would be a risk if it wasn't for the security aspects that are or is able to remediate every security vulnerability. However, the approach is during the life cycle of releasing software. So on one hand, we can emphasize this very much, but it couldn't be complete if we couldn't also not mention that usually these organizations or the successful organizations that implement DevOps in a very successful way, they usually have a high degree of testing and deployment automation, a very high degree of automated risk mitigation, less rigid and much more less manual processes, and an effective and enforced DevSecOps culture and communication. So of course there couldn't be solutions if it couldn't be for challenges. But as engineers, we love to bring solutions when we observe several challenges. And among a lot of different aspects of challenges that we have been observing, or I've been observing in my career, is that usually pain points are about developers waiting long times for getting infrastructure provisions. So they usually run things on Docker to kind of test the functionalities. Software is usually manually deployed on ad hoc basis. Let's say that we need to patch a specific production server, or we're going to try a specific set of changes in a specific region. So it's usually manual, or sometimes it could be manual for some large enterprises or for some small medium businesses that haven't yet adopted this framework. We're talking about developers having a lack of visibility into application running in production. We're talking about product owners or business side not having exact visibility of what is actually running in production, or even sometimes the business wondering why the product teams are releasing software that may not align with the business plan. So in fact, this is I believe one of the top three of the problems that we often encounter. And another one which brings as well a lot of problems for technical teams is the lack of standards. Tooling is usually inconsistent across teams and business units. They all have their own rules and processes, and that just makes things much more complicated. But if there is one risk or challenge that has the capacity to actually bring all those other issues to the ground and really be and put the customer data or the customer operations or the company operations at risk, is definitely the security aspect of it. And one main challenge that we are encountering, or I have encountered in my previous experiences as well, is that security is configured ad hoc for each application. There is no standardization as what security practices any application or lifecycle should have. And this is usually a reason for a lot of different problems that we find when it comes to securing workloads and running workloads that are very robust. In terms of solutions, we are defining to have developers self-service their on-demand deployments. So for infrastructure, test, Q&A, performance, security, they can have the button to click and deploy whatever they want at any time. Also for software deliveries to be automated via continuous delivery pipelines and continuous integration pipelines. Applications are fully instrumented for metric and log collection, which means that once I release a feature, that the work has actually just passed the 50% threshold. This is about monitoring that application, getting observability about how it performs, about how it behaves, how stable it is, things like that. And then as well, another point is to solve defining world or organizational wide standardization for tool, best practices, and communication and contracts among teams. And extremely important, last but not least, is to enhance and improve and get the security best practices that usually internet giants are often using, and bake those practices into the standard delivery of software. Another important factor that has very few to deal with technical issues is how to communicate between teams. Agility means ownership and communication is agile and effective, meaning that all of the different teams involved in the software development are extremely tied to each other and not blocked by any of them, which means that communication needs to be very frugal, communication needs to be very effective, very honest, as well as intertwined between all of the different teams. So weekly calls, monthly calls, enlightenment committees, things like that are effective and have clear outcomes and address the room with clear problem statements are very effective to deliver software faster and better. So sometimes what we're also seeing is that some of these messages sometimes are actually getting distorted. And why this actually happens, we often speak with several companies, or we often speak with a lot of different customers that think that bringing DevOps is about eliminating operations, where actually what we're doing is trying to bring development, operations, and security together as one team with one outcome, which is to delight and to improve the customer trust on the platform that we are running. Also, we hear a lot in communities that, it's about the developers not doing the job of operators. And definitely this is a very good point, because when you have a very highly scalable system, or a very large system, large distributed system, operating that large distributed system becomes very complex. And we need to find a specialist knowledge about that. So the fact is not to become, or not to make developers owners of the operations, but involve them in the operation lifecycle, giving them continuous feedback about how operations perform, and granting them the right to ownership of some of that, even in production, but not limited to all of the, let's say, infrastructure databases, right? The ownership, it's very important. So in that sense, what we vouch for is to help teams go much faster with fewer errors. Sometimes we also hear from some other colleagues that it is not about changing the organizational structure. Sometimes we may observe that a change may be positive, but the idea is to have those organizations, or have this structure, communicate more effectively, and mostly tear down the silos, tear down the blockers that allow for a company to move much faster and allow innovation. So as a result, what we should get out of an effective and successful DevSecOps framework implementation is an explosion in innovation that delights not just internal teams, but also is extremely good when it comes to applying and releasing products to the customers. An end-to-end solution, which I believe it has been spoken today very often, but maybe we can have a bit of a wrap-up just to summarize. But of course, we will go from the author of the code, so any team that will be developing the new solutions, we will source an artifact that we will build it and test on many environments until we're sure that things are correct. We will deploy that into production, and then after that, we will keep a close monitoring and a close observability of what is actually happening and why. And to orchestrate all of that automation, we will also be looking at automating the creation of pipelines, so that every team that desires and wishes to have their own pipeline can actually do it. So for that, one of the main tooling that we could use is CloudFormation, which is an infrastructure as code language based and native to AWS services, as well as the cloud development kits and the SDKs, which we can automatically connect with the API of AWS, given and provided some credentials, so that actually allows to have virtually unlimited amount of resources at our hands, and as well as leveraging some of the application serverless models, which are very let's say agile, and can allow developers that may not want to deal with some infrastructure provisioning for testing or Q&A to ship and lift workloads in minutes. But this is about DevOps, how it comes then the security embedded on this process. So on one hand, from authoring, sourcing, building and testing, deployment and monitor, we must have security principles and tenets at the forefront of every single technical decision. We're talking about designing with restricted access and least privilege principle on top of it. We will not allow any action to any identity that it's not necessary by design. We're talking about storing safely in the cloud, which means that we will be looking at encrypting at rest, encryption in transit, continuous scanning for vulnerabilities, not for the source packages, but for those that are currently that are currently deployed and their child libraries and irrespective components. We will be talking about running as much workloads as possible in private VPC, controlling very narrow and having exerting very high control over what connectivity goes and flows through the internet. And majority, or let's say one of the main important important cultural points is to maintain an active posture. Be proactive, not reactive. Stay on top of the issues that matters in terms of security for your business, for your application, and for your customers. To that extent, just to mention, AWS has very extensive set of security and compliance controls. You can have a scale, huge amounts of scaling with very high visibility and control, observing exactly what happens within your applications and systems. You can have the highest standards for privacy and data security with a lot of different certifications and international recognitions that the cloud is having that you have as a resource to implement as well to your own workloads. Then also the ability to automate with comprehensive and integrated security services such as CrowdStrike or Lacework or any third-party tool that could make your life and the life of your security, your security in DevOps team much easier. And of course, you have at your disposal one of the largest networks of security partners and solutions. But to give a bit of an idea about how do we first understand the security model, it's to get into the shared responsibility model between AWS and the operators of that. So on one hand, the green part that you see at the bottom is the security of the cloud, where AWS takes responsibility. So we're talking about securing the AWS global infrastructure, regions, edge locations, availability zones, as well as the software that runs on top. So for compute, we will mention EC2, ECS, storage, S3, database, every Aurora or MariaDB or Dynamo, and as well as the networking. This is the responsibility that AWS takes care of. But the model is not complete unless the user and the operator of the cloud actually gets its inputs into the topic. So customer responsibility, we often talk about patching the operating system, that it's not serverless. So for the serverless, AWS could do the patching, but for any EC2 with a standard AMI, then the customer is in charge of patching that up. We're talking as well about restricting network and firewall configuration and traffic, platform applications, identity and access management, and enforcing the least privilege access model, as well as securing client-side data, server-side data, and network traffic. Usually, security and compliance is a shared responsibility model, not just between the cloud provider, but between teams. We're talking about the responsibility model that an application could have by securing certain paths or securing certain vectors of attack. We're as well talking about how to automate the test of those vectors through a DevOps practice, as well as understanding from a network or from an infrastructure perspective how things should be run smoothly. Establishing shared models of responsibility among teams actually help greatly increasing and improving the security posture of the companies. To dive deep slightly on the topic of security, there are probably two columns or two categories that we are clearly identifying as the backbone of understanding the security model of how to run a large business or how to run a very secure workload on the cloud. On one hand, we could start from the identity. It is extremely important that administrators, developers, operators, consumers of your applications require an identity to access any AWS environment and application. These could be members of your organizations, external users with whom you collaborate, who you interact via a browser, via a client app from a mobile app, or any other kind of command line interface. And it's very, very important that those identities are controlled, are tracked, are audited, and are identified early should something be not the way that it should be by design. So in this sense, most of the workload applications, operational tools, component require this identity. And it's very important that these identities includes maybe probably EC2 or S3 or Lambda functions, but those identities can be managed, can be identified, can be auditioned, and can be completely audited. So part of this is to protect as well. So I guess that's could be maybe the principle to understand what design principles we should apply. Then to enforce those principles, we're also talking about data protection. We're as well talking about application security and threat intelligence. We're talking about enforcing, working with policies, enforcing delegating permissions to admin those IAM users. We're talking about IAM user analyzer, remove unnecessary credentials, rotate credentials that are older than 30, 60, or 90 days. Usually working with assuming roles through the CLI, including MFA for those operations that may be more riskier. Working defining permission boundaries, as well as role-based access control for applications and for operators as well. Now, another topic, once we have, let's say, defined a very secure system and found the right measures to enforce that design, then we're going into the next phase, which is about detecting. There is a zero security model which states that any company or any workload should assume breach and have a strong defense. How do we design systems assuming that our information system will be breached then? Enforcing encryption at every single level. And this is the utmost important. Sometimes some of the public news about threats or let's say about events where there has been some sort of data leak, they mostly point to databases that were not encrypted, meaning that once a malling operator got hold of this data, could actually decrypt this data, or not even decrypt this data because it wasn't encrypted, but could use some very basic hashing functions to understand what real content was there. So encrypting at every single layer, many times using your own keys, is extremely, extremely important. This is not the only way that we will try to detect, or let's say assume a breach. Usually detection consists of two parts, which is detection of unexpected and unwanted configuration changes and the detection of unexpected behavior. Those two main pillars, or those two main work streams, they require different approach as well as different resources when it comes to monitoring. When you deploy a workload into non-production and production environments, you can check configuration using native AWS open source or AWS partner tools. We're talking about understanding that the configuration of the servers or the configuration of the system is exactly how it needs to be on each environment. Also, as well, when it comes to running an application, you can check whether the configuration has been changed in an unexpected fashion, including outside of a known deployment or automated scaling event. For the part of detection that deals with unexpected behavior, you can use tools by alerting or increasing a particular type of API calls using Guard Duty, for example, which is a service that allows you to understand several patterns of unauthorized access or suspicious access, so that you can be alerted when a potentially unauthorized or malicious activity occurs in your AWS account. And you could also explicitly monitor for mutating API calls with CloudWatch alarms that measure on the baseline for the traditional or the standard measurement of calls through a period of time. We're talking about using or leveraging the usage of AWS Security Hub. Definitely the use of an event bridge so that we can capture events and target actions based on certain events. Configuring Athena to analyze CloudTrail logs so that we can have a continuous stream of audit logs of what is exactly happening over the AWS accounts that we're running workloads into. And then, of course, centralize and consolidate standardization of the logging solution. Have all the logs being written into one place that can be analyzed by one tool, and have standards as to how then everything should be. The last one, which is respond and recover. Sometimes those three pillars, identify, protect, and detect, are not enough. And we are seeing ourselves into a situation where we need to respond and recover. This is a very critical phase, as sometimes some of the responses are regulated, as for example, in the event of a GDPR leak, then you are obligated to report to the pertinent authorities within a time frame. So as for that, you definitely need, or you definitely want to have a good auditable or a good trailing system so that you're able to find any information that what has happened, when, on what system, with ease of time. For that, and a little bit into the more proactive service, of course, it's very important to have a very strong team that is highly trained and understanding of the different scenarios when it comes to incident response that is highly connected to the IT service management. But in a more proactive way, we're talking about threat detection before the actual hack can happen, and a continuous iteration of reviews, continuous iteration of tests, and continuous iteration of a stress test to understand if our workload is secure or what might be cooking up in some other organizations that might be a threat to the business that the company is running. So as I was mentioned, for the 4 pillars here, well, detect and respond are slightly divided, but for the 4 pillars, identify, we can use Systems Manager or AWS config that allows us to run automated rules so that once the threshold or once the configuration of one specific item is changed, we get alerted to understand if this change has been made manually by or has been made by an actual authorized person, or it has been an authorized access that should not be. In terms of protecting, we are, of course, looking into running things into a private VPC, as mentioned before, having a very strong mechanism for identity and for authentication and authorization, which could be, for example, single sign-on connected to any other identity provider. We are looking as well as AWS Shield and Firewall Manager in terms of network protection and surface attack protection. We're looking about key management service to handle the keys from which we will actually encrypt all of our data. We're talking about Amazon Macia and Inspector that proactively helps us understand if data found in certain locations are containing personal identifying information or not. Then moving on into detect, we're using and leveraging WAF for actually blocking and understanding traffic patterns that reach our platform. We're leveraging Word Duty for automated alerts for patterns that may be malicious but not yet detected. Definitely, we have a huge amount of tools for automation detection and response. So leveraging CloudWatch, leveraging CloudTrail, CloudWatch events as well, and then building response runbooks before the actual problem occurs. And then, of course, when it comes to recover, not just dealing with the ongoing incident, but how we can have a very short recovery time objective and recovery point objective. How fast can we be online, and how up to date is the data that we can the soonest put online. So we're talking about business continuity and disaster recovery, that we can leverage snapshots, we can leverage S3, and we can leverage as well our CDNs and CloudFront solutions. This is a very general approach, so feel free to put some questions about this. But I would like to have a conclusion with a few topics that sometimes we also observe. We have, or at least in a personal opinion, I've been observing for quite some time. We have, it seems that there are 2 forces, the agility and the governance. And those 2 forces are playing with a zero-sum game, meaning that one wins, the other loses. And I think it's extremely important to break that cycle. We need to bring agility and control together, not just choose between one or the other one. We need to be able to experiment. We need to be able to be productive. We need to be able to empower a distributed team with different tools and with different opportunities for testing, for exploring, for creating new things that may not be final, right? But we want our customers to see that the company is trying to innovate, the startup is trying to create a new service. And at the same time, we need to balance that with governance. We need to enable the teams to be secure. We need to provision and standardize security. And very important, we need to operate in a secure manner and make the business owners of our company trust that what we're doing is secure and that they will not have to be dealing with any unexpected and unwanted event anytime soon. So my take about this whole talk about this conclusion and the inspiration that I would like to give to the community is bring those two together. Never mention that agility could come at the cost of not having governance, and the opposite. DevSecOps enables both, and it's for us to find solutions on how to make this happen on a better and more secure way. And with that, thank you very much for staying online. I think it's a really cool event that the team has pushed, and I would open the floor for some questions.
Thank you very much, Alejandro, for the insightful and wonderful talk. Thank you very much for explaining in detail. So if anyone has any questions, please type it in the Q&A so we can deal with right now, or else connect with the Alejandro on the social media, on LinkedIn or Twitter. I think, thank you very much for your time and the wonderful talk, Alejandro.
Cool. Thank you. Thank you, everyone. Have a good day.
Yeah, same to you. Bye. So I hope everyone is enjoying so far so good. If anyone has any questions or anything, please feel free to type it in the Q&A. We are having, after each sessions of the speakers, we are dealing with the questions and answers. So the next speaker we have got is Ronald Maravanyika from Zimbabwe. He is a DevOps engineer at Zimbabwe. So let me introduce him on the stage. The topic he's going to cover is low code, no code platform now in Azure DevOps. So let me introduce on the stage. Hello, Ronaldo. How are you doing?
I'm good. How are you?
I am very well, thank you. Could you please share your screen?
Sure. Let me know if you can see.
Not yet. Yeah. Yes. Okay. So are you excited for the talk?
Yeah, very excited to be here.
Okay. So the stage and time both are yours now. Thank you very much.
Okay. Thank you so much for attending my talk. I'm going to be talking about low code, no code platform, which are of late now in Azure DevOps. So this talk, it's the first part of the talk will mainly cover the basics and introduction to what low code, no code is. And then the second part is sort of a little tutorial that I'll be just walking you through, but just the steps. So my name is Ron, but full name Ronald Maravanyika. I'm a co-founder of a startup called Zimbabwe. And more about me, I've got 8 years experience with Python and Django, 4 years experience with Power Apps, and again, 4 years experience practicing DevOps. So what you can expect in my talk is the introduction that we have already done, a brief description of what low code, no code mean, what is Power Apps, and the fundamentals of DevOps and Power Apps put together. I've also added little gotchas that I experienced. And if we have time, we'll take questions at the end. So basically, low code, it's just a methodology of designing applications, right? The main focus there is to sort of use graphical tools rather than writing code. The second focus there will be to reduce the requirements of doing something, right? If you want to publish a website, for example, we want to reduce the requirements that you need for you to be able to do that. Then lastly, it's all about simplicity. The world is changing so fast that things can't afford to be complex. Then no code literally just means we are not writing any code. This is an ideal situation, but in most cases, this doesn't happen at all in some instances. So let's just take a look at why it is important for us to look at this talk. In 2021, Gartner published an article which was very interesting to me. That article was around low-code, no-code platforms, right? They said currently nearly 60% of all custom apps that are built outside the
Okay, so we had some issues with the speaker, so let's wait for just a couple more minutes for the speaker to reconnect. Sorry for that.
Hello again! I hope you find this event interesting. Please let us know what you think about everything's happening today in the comments, leave any feedback. And yeah, I'm happy to invite you to our next day pro track that will happen tomorrow. Our speakers definitely prepared more content, more live coding use cases to learn from. So you can check our agenda and just grab your tickets with 25% discount. And of course, I'm happy to announce our next DevOps event that we'll have in April next year. Actually, I'm really excited about it, and I hope you join us too. And early bird tickets are available on the website now. Please invite your colleagues, your friends, learn more, get more. For those who'd like to join us as speakers or moderators, program committee partners, or actually in any role, please apply with the form on the website and I'll get back to you. So enjoy the rest of the conference. See you.
hey Ron, is everything is good now? Hey.
Hello.
Yeah, hey, we can hear you. You are back live, so we can continue.
Sorry, Ron, you're back live. It was just a quick announcement in between your talk, so sorry about that. So I'll share your screen again, and you can continue peacefully. Thank you.
Okay. Apologies about that. In Africa, we have what we call load shedding, where we ration power. So it was just a little glitch in power, but I should be back now. So I was talking about the report that was published by Gartner, right? And they said currently nearly 60% of all custom apps are built outside of the IT organization. What does it mean when they say outside of the IT organization? These are your normal people, daily running people, your accountants, your financial experts, people that are within the organization that normally consume IT softwares. But now they're at a point where themselves they can solve their own problems using low code and no code. And they are predicting that by 2025, 70% of new applications developed by enterprise organizations will be using no-code, low-code tools. Again, this is all centered around how easy it is to interact with the users, right? So after 2021, in February 2022, they now said 65% of applications are already at this point being built by low-code and no-code platforms. There's an interesting case study that happened at Heathrow Airport, where a normal worker created an app that ended up being used by the whole airport. And this person who was a general worker ended up being recruited in the IT department because of low-code, no-code platforms. That said, for today, we are going to be focusing on Power Apps, Azure DevOps, and Power Apps build tools. Power Apps is let's take a look at what it is. Power Apps, it is a Microsoft low-code, no-code platforms that create enterprise applications. So if someone has got an M365 license that comes with a Power Apps license, someone can also buy that license separately. So this is my main focus of today, but there are a whole lot of other low-code, no-code platforms that go outside the scope of this talk. Then Azure DevOps is a platform. Traditionally, people used to know Azure. There is also Azure DevOps. Basically, Azure DevOps is a platform that integrates all the DevOps elements, right? So when you're looking at your source control, there is Azure repos. When you are looking at your CI/CD, there's Azure pipelines. When you're looking at your planning, there's Azure boards. There's also testing tools there where you can test your items and link them to your test boards. So basically, that's what Azure DevOps is. It's a platform of all this range of products. Credit to Bikash, who provided me with this detailed picture here. Right. So at this point, we have sort of passed the first section, which was sort of an introductory setup. Now we are going to get into the second section. The second section mainly is going to focus on how we are putting in Power Apps into a proper pipeline so that it would seem as if we are developing with Pro Code whilst we are using a no-code platform. The main reasons of why we want to do this is because low-code, no-code platforms, they are, like I said before, they are graphic-centered. And Azure DevOps, they tried to sort of mimic that that situation where items are being rendered not as code but as graphic items. You can only enter your variables, you can only enter the name of your files, things like that. That's the main focus of what they try to do. So I will take a couple of assumptions here. So I'm going to take a sip of water. The assumption that I would take is someone has got sort of a basic knowledge of what Git is and a few Git commands. Then a knowledge of Azure DevOps, you know, how to set up your account in Azure DevOps. There is a whole bunch of documentation if someone is interested on how you can set up a free account and get this going. And I'm also going to assume that someone knows what a pipeline is. Those are the only assumptions that I'm going to take at this point. So firstly, what someone would want to do after they've developed their application in Power Apps and they put their app as a solution that they want to distribute to their users. The release, the development is being done in your development environment, and then it will go into staging, and then it will go into production. But what happens with low-code, no-code platforms is you're actually downloading a file, then uploading that same file in a separate environment, and then on each and every element that reference to items that are in devs. For example, if your data source is pointing in dev, you actually have to go back and put your values of your staging environment. Then you repeat the same process for production. This is now cutting what low-code, no-code is intending to do, which is to release products as much as possible. So of late, it's now possible to actually actually create your release pipeline that can put your application through all those development environments that you have, whether it might be staging or whether it might be your development environment or even your production environment. So what these guys did, they created a Power Apps build tool. What a Power Apps build tool is, it's a script that was packaged together so that it can perform specific tasks that a person was doing manually. Like, for example, now I mentioned that you were actually downloading a file. A script was packaged together where it was just given a name of unpackage your solution, package your solution, and those little chunks do different tasks within your release chain. Then the other thing you would need to do, because now you're building enterprise application where your financial data is existing, where your HR data is existing, you actually need a proper way of preserving your code. You actually now need a repository. A repository also comes through as a package of Azure DevOps. It's called Azure Repo. So generally, this is what Azure DevOps looks like to those that don't know it. On your left there, you have the various products and services that are offered by these two. For us today, we are mainly going to focus on two, which is the repo, where we are going to store our unpackaged application, and then the pipeline. So for the pipeline, there will be a release pipeline, and then there will be a development pipeline. So to create your pipeline for Power Apps, you need to stay in the context of using graphical items. So when you click on your pipeline to say you want to create a new pipeline, there is a section at the bottom there where it says use a classic editor. What a classic editor does is it will display your data as graphics. So you don't have to write any code within that classic editor. This is how the platform will look like after you have created your pipeline. What is on my right here is where you are naming your solution. This name doesn't have to be the same name as the name of your application. It can be a name that you use within your organization to standardize how people who are developing softwares within their smaller entities can join their work together, right? So if someone in finance has developed an application of tracking how many times he receives emails, then in another section of the organization, maybe in IT, would want to use that same solution. But for us to be able to do that, there should be a standardization. That's where the name is very important. So you select your pipeline that you want to use. This is the agent specification. It normally comes through as a default, and I wouldn't recommend playing around with those settings. Once that is done, you now have what they call a job agent. A job agent is where you are going to write your steps of the pipeline, right? So you are taking your application from development, you are putting it into staging for testing, and then you are putting it into production. So those are the few steps that will be detailed in your job. So this is how within the job, how the steps would look like. This is the Power Apps 2 installer that I mentioned before. Once that is installed in your Azure DevOps platform, just a mention here, only an administrator will be able to install the Power Apps Tools installer. So if you are someone in the finance department, I wouldn't think you will be an administrator. So you just need to take note that it's something that has to be installed by your IT organization. Like I said before, this tool was developed by Microsoft themselves, so it will be well up to date. Once you have added your installer, you have the steps available to you as graphics. What do I mean? Here, I'm just asking the Power Apps installer, who am I? So that I confirm it's logging to the correct environment, so that I confirm it's logging into it's logging use the correct user account. Here you are now detailing your steps, but they are coming as graphics. So the steps where it say Power Apps export solution, you are just telling, you are now just putting your variables of where your environments are, of what your application is named. And then the tool itself, the Power Apps tool, will go in the background and do the whole process that you are doing. For example, the export is where it's locating your application. It's packaging it for export and then downloading it. And then you see the next step. Once the file is downloaded, we can pass that step into the next step. That is passing the output of the previous step into the next step. Again, all that comes as graphics. This is where you specify your variable names. It is highly encouraged to put in variables rather than hard coding your values, because if your file name changes, you are going to change it at only one position. The build artifact staging directory is a dedicated directory that sits within Azure DevOps. So this directory temporarily stores the output of exports or imports. So in this case, we're doing an export. So you will temporarily store your files in the artifacts directory. Once you have exported, the second stage is actually putting your application into source control. I'm just going to look at the time. Okay. Is actually to put your application into source control. Once your application is unpackaged, the next thing is to push it into source control. Source control, all you need to do is to paste this little bit of code into the already packaged GitHub tool that comes with the Power Apps tools installer. So you see, if you are familiar with Git, you see the commands there are familiar, like what we normally do, but you're just putting this once and for all, and all is set. Your Power App solution will now be pushed into GitHub if you're using GitHub. In this case, we were using Azure repos. But once your app is in your source control, the next thing that you now need to do is to pull your application that's now in source control through the production pipeline, which is your release pipeline. You'll be doing the same steps like you did for the initial creation of the pipeline. The steps are the same. You just type what you want, and then the tool installer will find the task that needs to happen. the main gotcha that I found for this pipeline, which is difficult, is the error 128. So this is a common error when you are running the pipeline for the first time. The main reason why that is because once you have created your packaged solution, it will create a new service account with all the details pinned to that service account. So you have to allow it to have access to your repo. You have to allow it to have access to your Power Apps solution, so that you'll be able to run all the commands on behalf of yourself. So where things are running smoothly, you get a blue tick, and as you can see there, where they are not running smoothly, you get a red tick, and usually it will give you details, except for this 120 error, where the details are not clear, you don't know where to change, things like that. So all you need to sort out is the permission of your service account. That brings me to the end of my talk. Thank you so much for attending. I think it's wonderful for me to be here. Thank you so much to the organizers for having me.
Thank you very much, Ron, for the detailed and wonderful, insightful talk. So I hope everyone enjoyed it. If anyone has any questions, please type it into the Q&A box. So we are dealing it with right now. So the one question we have got for you is, what level of technical knowledge a non-tech person should have to evolve a Power Apps application once it's already created?
So the question, is it on the release or on the creation? That wasn't clear.
Do you think any other approach or anything?
I'll just generalize the question. So once you are in low code, and now I'm saying it's now in DevOps, everything that you are using, it's graphical, right? So you are not writing any code. It will just ask you for a name of your application, and then you put in your name of your application. So in terms of technical knowledge, a simple how to guide should be able to be sufficient for you to be able to run the application.
Okay, so I think that was the end of the Q&A. That was the only one question for the audience. So thank you very much, Ron, for the wonderful talk, and thanks you very much for your time and effort for explaining and presenting the new ideas and the concept. Thank you very much. Thank you. So guys, thank you very much for listening so far. Everything, I hope you are enjoying. So we have got the next speaker. So we have got a short break at the moment before we jumping into the next speaker. So let's meet up again in around 4 to 5 minutes. So we have got the next speaker ready, getting ready. So enjoy your break. Thank you. Welcome back, guys, from the break. I hope you are enjoying so far so good and enjoy your break. It was a very quick one. So the next speaker we have got is Stanislav Tiurikov from Germany. He's a startup solutions architect at AWS. So the topic he's going to cover is coding on the edge as Amazon CloudFront functions. Amazon CloudFront functions. So let me introduce Stanislav on the stage. Hello, Stanislav. How are you doing?
Hello. Hello, everyone. Thank you. I'm doing fine and hope you're doing well too.
Are you excited for the talk?
Yes, of course. So ready to share a lot of useful information.
Okay, let me add your slides on the screen. So the stage and time both are yours now. Thank you.
All right. Thank you very much. And again, hello, everyone, and welcome to this session. My name is Stanislav Tiurikov. I'm a solutions architect and I work for Amazon Web Services. Today, we are going to talk about how Amazon CloudFront Content Delivery Network works and how you can use CloudFront functions in Lambda H to improve logic of your web applications. I have prepared a few slides for you and a couple of demos to show you CloudFront functions in Lambda H in practice. That was a quick intro. Now let's get started. Let's start with introduction to H services, what problems they solve and how they work. In order to understand the role of H services and how they can help web applications, let's look at the following example. Let's say there is a public web server and there is a viewer who wants to get a web page from the server. To do this, the viewer needs to send a DNS query to obtain an IP address of the server. When viewer establishes a TCP connection and a TLS session using the IP address. After that, using the established connection, viewer sends an HTTP request to the server and then receives the desired web page in response. As you can see, client-server interaction from the previous example produces multiple network packets which are sent in both directions through the internet. In a nutshell, the internet consists of many networks interconnected with network devices. Passing a single packet from one network to another usually adds a small amount of delay. This is not maybe a big issue for if the number of hops is small. However, in a real-life scenario, when a packet flows through many hops, overall delay may get a significant value. In general, if the longer the distance between client and the server is, the higher chances for a single packet to meet more hops along the way. And in addition, network packets may go through different paths and hops, so delivery time may vary. To improve the situation, AWS offers CloudFront Content Delivery Network service, which is built on top of a global edge infrastructure. This infrastructure consists of more than 410 points of presence and located in more than 90 cities and 48 countries around the world. The points of presence are interconnected with a high-speed private network, which is called AWS Backbone. This allows traffic from clients to be routed into AWS Backbone as soon as possible and when to be routed to the target server in the optimal way, bypassing less predictable public internet. With CloudFront, requests and responses hit AWS global network earlier, resulting in more consistent and predictable delivery times. That works the best if the server is also hosted on AWS. In addition, network connections and TLS sessions are terminated on edge locations, which helps to increase the speed of data exchange. Let's take a look at CloudFront architecture, which consists of multiple edge locations, regional edge caches, and origin shield. CloudFront stands between a viewer and an origin service. Its main task is to speed up delivery of requests and responses, both by using private network infrastructure and by response caching on a set of intermediate servers. The viewer interacts only with CloudFront services on edge locations. It's not possible to connect directly to our components. As I mentioned before, network connections are terminated on edge locations, which can also cache frequently requested content. Regional edge cache is the next caching level, and it has way more capacity than a single point of presence. The last component here is Origin Shield. It's primarily designed to protect target service from excessive load. When a viewer makes a request to a service behind CloudFront, this request first hits the closest by latency edge location. When CloudFront checks whether the response is already in the cache, in case of no response found, CloudFront sends the request to the origin server. A response received from the server is placed into the cache and returned to the viewer. The next time the same request is sent, the result is immediately returned to the client from the cache. There is no need to interact with origin anymore. This greatly helps to increase response speed and reduces the load on the server. Better network performance, response caching, and protection of the target service are not only the benefits offered by CloudFront. What we can also do is to customize request and response logic right on the edge. There are two instruments we can use. First one is CloudFront functions, and another one is Lambda Edge. Next, we will start talking about each of them, and we will start with Lambda Edge. Lambda Edge is a serverless technology built on top of AWS Lambda. Serverless means you don't need to provision and maintain servers or virtual machines to run Lambda functions. Scaling of the functions occurs automatically as the load increases. You pay only for utilized resources. That means that no charges occur when function is idle. Lambda runtime is designed for high availability and reliability. If any of underlying components fails, Lambda function will be automatically moved to a healthy environment. Lambda works in the following way. You write a function using a supported programming language. The function contains all the necessary logic. It can also use additional libraries, make calls to other services in data stores. You also set a function trigger. For example, change in a data storage or change in a resource state, or it can also be a direct call to the function. Lambda Edge is an integration of Lambda and CloudFront services. It allows to trigger a Lambda function to process CloudFront specific events. What kind of events can this be? There are 4 triggers we can use. On a viewer request, when we want to run some code before CloudFront checks if there is a cached response. On an origin request, it will be triggered if there is no response in the cache, but before request is sent to origin. On an origin response, when a response is received from the origin, but before possible caching decision. And the last one, on a viewer response, when we want to run some code before response is sent back to the client. In this way, Lambda function can modify requests and responses at different stages, which opens very great opportunity for customization. With Lambda, it's even possible to generate a response completely without touching cache or origin. There are different use cases how Lambda Edge can be used. To improve performance, we can manipulate cache control headers, implement client redirections, or normalize URLs and query parameters. We can generate content on the edge. For example, we can resize images, render pages, or implement A/B testing scenarios. We can also choose how or which origin should be chosen to process a request by prettifying or rewriting URLs or by selecting origins dynamically. Also, we can improve application security by adding specific security headers, authenticate tokens, or by signing requests to origin. At the moment, you can implement Lambda H functions either using Python or Node.js. Examples in this presentation are written with Node.js. Let's have a look at the structure of a simple Lambda H function. We register a handler function that takes 3 parameters: event, context, and callback. Event object contains information about current event, for example, request or response data. In context object, we can find data about an execution environment like function name, function version, or memory limits. Callback function is the last argument what can be used to return either an error or a processing result. The request event is a structure with some information about current request. It can be a client IP, headers, URI, query strings, or other useful fields. In the response event, we may find information about both request and response data for the current call. For more detailed information about event structures, including fields description and usage examples, I encourage you to check the documentation. Now, let's have a look at Lambda at Edge deployment process, which consists of the following steps. First, using AWS console or your favorite infrastructure as code tool, we create a function and add a trigger for a specific event. When CloudFront replicates the function across all regional edge caches where event processing will take place. If we want to check logs, we need to go to CloudWatch log service in a specific region where function was executed. Let's take a closer look at the dynamic origin selection use case. In this example, there is a distributed system which is deployed in 3 different locations: US, Europe, and Asia. We want to make sure that authenticated users work only with a service from their home location. To do so, we can assign a home region ID to every user using cookies during authentication. Then, all requests from authenticated users can be distributed to corresponding services by Lambda H function based on the cookie value. Now, we will go to AWS console to see how in practice you can implement a dynamic origin selection. Give me a second, I will switch to another window. And I hope you can see my screen now, because I'm sharing my AWS console at the moment. So here in AWS console, I would like to show you how we can implement a simple Lambda H function in order to choose dynamically origin. To do so, I need to have a couple of origin created. So what I did with Lightsail service, here I can jump into Amazon Lightsail. So here you can see I have a couple of virtual machines with public IP addresses. And if I open my terminal, copy an IP address, let me quickly do it, like this one, I can run curl command to show you that the service is up and running and returns me a message that this backend is up and running in European region. I can also do the same for another backend. Let me quickly copy this IP address. I will paste it here. And you can see that another backend is running in US region. That is great. Now I can return back to AWS console and open CloudFront. Here you can see what I have a single distribution. And this distribution is set to proxy all the requests to my European backend. If I open this URL, you can see that the request was passed to the backend, and I just can view the returned message. So what I'm trying to achieve here, I would like to create a Lambda function which will switch between different origins by setting a specific cookie value. So let me go back to console. Let me go back to Lambda console. And here I will click create function. I will start from scratch. I need to give this a function a name. I will give it this name. For runtime, I will choose Node.js 16. I also need to select an existing row, which is in my case Lambda H row. This row allows Lambda H service to take my Lambda function and distribute across different regional H caches. So I will click create function. And now I am in the source code editor. I'm going to delete existing default implementation, and I have already prepared some code for you. You can find it on GitHub. I click here and copy this function to my editor. So we have a function here right now. What I'm going to do, I will deploy it first, and when I will return back to explain how it works, because the deployment process takes some time. I want it to run at background, so let me do it by clicking deploy. So the function is deployed now, and the next step, I need to add a trigger. I will click add trigger. From the list of sources, you can see there are many different sources. I need to choose CloudFront. When I need to give my confirmation that I would like to deploy it as a Lambda H function. Here, a few more settings are required. So first of all, I need to choose a distribution. I have only one distribution, which I created. And I need to choose a behavior. I also have only one behavior. Behavior provides a set of settings for event processing and request processing for specific paths. Also, I need to choose CloudFront event. As I mentioned before, there are 4 different events we can use, but if I want to dynamically manipulate origins, I need to choose origin request. So here we go. I don't need a body, so I will not touch it, and I need to click here to confirm deploy to Lambda H. When I click deploy button, just a second. Let me do it again. All right, something went wrong. Let me do it again. I will go the same way. So we are working in real time. Origin request, confirm, and click deploy. So something went wrong. All right, let me do it this way, because I can go another direction. I can first publish a version, which is usually a necessary step, because what we can do is to create triggers right away. So here I can click add a trigger. I can go the same way, So choose CloudFront, choose distribution, origin request, custom, confirm deploy to Lambda H and click add. All right, now it works. So here you can see that we have created a simple trigger, and what we are going to do right now, I'm going to demo how it works. So we have a DNS name for my CloudFront distribution. So here, by default, I'm moved to European region, but if I would like to change the region, I go to work this way. So I will type login. I pre-created these endpoints, and I will pass the parameters, which region I would like to use. I will type this way, region US. I will click enter. And as you can see, your current region is US. Moreover, if I open debugging console, I can take a look at available cookies. And in available cookies, I have one region US set. So that's what was expected. Now, if I go back to the root object, the message has changed because the request was redirected to another origin, and another origin returns me a response. If I go back here and delete this cookie, right here, delete all, I will refresh this page. And as you can see, I'm back to European region. Now let's take a look at the source code, how it was implemented. Let me increase font a little bit. So here I declare a simple function. I gave it a name handler. This function accepts three objects: event, context, and callback. From event object, I get request object, and from request object, I get headers. If headers are available and there is any cookie in these headers, I can start going through them and check if we have a cookie header with value and name US region. Once I found such cookie, I can replace domain name for my custom origin with another URL. And when I will let this request to be processed by CloudFront, and CloudFront, based on information about domain name from custom origin, will choose where to send my request. As simple as that. All right, that was it for the demo. And now I can switch back to the presentation. Let me share my screen again. And we can continue to another slide. So another important point to note is the quotas and restrictions that are present for Lambda H functions. Depending on trigger type, origin of user, Lambda is limited by size of the consumed memory, execution time, function size, and the size of a response that can be generated. This information needs to be taken into account when you design Lambda H function. As you may have noticed, Lambda H allows you to implement a wide variety of scenarios. However, this is not only the tool we can use. Next, we will look at CloudFront functions, how it works, and how it differs from Lambda H. AWS continuously collects feedback on Lambda H user experience. According to our data, 55% of all Lambda H functions are triggered by viewer-facing requests. Such functions are usually very fast and contain simple logic. Often, such functions have to deal with spikes of requests, so the speed of scaling is critical. Based on this and other requirements, AWS has developed an additional tool to customize request response logic on edge locations that has better performance, easier scaling, lower cost, and better development experience. CloudFront Functions is a lightweight runtime for executing JavaScript code. Comparing to Lambda H, there is no need to send events to regional edge cache. CloudFront functions are executed right on the edge locations, closer to end users. CloudFront functions features high performance and security, almost instant scaling, lower comparing to Lambda 8H price, and as we will see in demo later, simplified development and deployment process. But that's not all. Let's have a closer look at some important differences. CloudFront Functions is a native CloudFront feature. It's more of an integration between CloudFront and Lambda services. CloudFront Functions deployment is possible from any region, right from the CloudFront console or with an infrastructure as code tool. Logs are centralized, can be found in the single place. No need to check different regions as we have with Lambda H. As with Lambda H, CloudFront functions can get access to information about user location and device type we use. There is an integrated testing tool you can use to verify if the function will work well in production. Now let's check CloudFront functions use cases. CloudFront functions are great for tasks such as normalization of caching keys, headers manipulation, URL redirection and rewrite, request authorization and token validation. At the same time, it's better to use Lambda H instead of CloudFront functions for long-running tasks that take seconds to complete, tasks that require significant resources, such as memory or CPU, tasks that use external libraries, for example, AWS SDK, and in cases when external service calls are required. Currently, CloudFront functions can only be implemented in JavaScript. The entry point is always called handler, and it takes only one parameter, an event. The event contains all necessary information about both request and response. Unlike Lambda H, to complete function is not enough to return request or response. If function returns a request, that indicates further processing is required. If function returns a response, CloudFront returns it directly to the client, no cache and no origin interaction happens. An event object can contain information about request. It can be method, URI, parameters, headers, cookies, and other values. The following information about response can be also found. It's status code, status description, headers, cookies, and please note that CloudFront functions don't have access to response request bodies, wherefore cannot modify them. If you want to modify body over response, you can use Lambda 8H. Now we will go to AWS console to see how we can implement request redirects with a CloudFront function. I'm going to share my screen again. So I hope you can see my screen again right now. I'm back to AWS console, and instead of going to Lambda console, I'm going directly to CloudFront console to show you how we can create a simple CloudFront function. I'm going to use the same distribution as I used before in the previous example. And here I need to navigate to functions. I will click on the link and I click create function button. Now I need to give it a name. Let it be this name. I can also add a description, but that's optional. I would like to omit it. Now I'm redirected to a source code editor. I will delete default implementation. I will go back to my homework and open CloudFront function example. Here I will copy it. I will paste it here into the source code editor, and I explain you what's going on. So I have declared a single function with a name handler, which accepts one object event. From event, I can get information about request. And from request, I can access query string and check if there is redirect URL parameter specified. So if this parameter was specified, I can create a response to return. This response will contain status code 302, status description found, and I will add a response header with name, location, and value from the redirect URL. So if this parameter is not specified, I will basically return request to indicate what my function hasn't done anything with this request. So please, CloudFront, do all our necessary steps. But since I'm returning response, I expect that my client will receive response and no further processing on CloudFront side will happen. So let me deploy it. To do so, I need to first click Save Changes. After that, I need to go to Publish tab and click Publish Function. Now I need to add an association. I will click Add Association. I will choose my distribution. I will select Viewer Request as an event type, and I will choose the only behavior I have and click Add Association. So now the association has been created, and I can go to another tab to show you how it works. In order to demonstrate it, I can use my root object, add a parameter, redirect URL, and I can add any website I would like my client to be redirected. So since I work for Amazon, I will use this one. And as you can see, my client receives a response which asks it to redirect to another website. There was no interaction with cache. There was no interaction with origin. It happened right on the edge location. All right, now let me switch back to the presentation. So there is only one slide left where I would like to demonstrate the key differences between Lambda H and CloudFront functions. CloudFront functions support only JavaScript at the moment. You can trigger it using only viewer request and viewer response events. CloudFront functions deployed to 410 edge locations, not to regional edge caches, as it happens with Lambda H. In terms of scaling, you can expect tens of millions requests per second. On other side, Lambda H is suitable for long-running tasks up to 30 seconds. It can also access network and file system, can use much more memory for processing, and can also use external libraries. So you can see that CloudFront functions are designed for performance and scalability, while Lambda at Edge is a universal tool for a variety of use cases. Please keep this information in mind while making your choice between CloudFront functions and Lambda Edge. So that's almost it from my side. Now I'm ready to answer your questions, if any.
Thank you very much, Stanislav. It was a very detailed and insightful and marvelous talk with the demonstrations. I hope everyone enjoyed it. So far, so good. So if anyone has any questions, so we are dealing all the questions for Stanislav right now. So if anyone has any questions, please type it in the Q&A, please, in the right now box. So we'll wait, I think, couple of minutes for the answer questions. Stanislav,
sure.
Then people will get more chance.
Sure.
I think there is no questions at the moment, but if any questions in a chat, Stanislav, please keep your eye on the chat on the live sessions, so you can ask directly. So people will ask on the go, so you can direct the questions to the audience in the chat if you don't mind. Is that okay?
Yep.
Okay, Stanislav. So thank you very much for your time and the effort for putting the presentation and the demonstrations to the audience with the new concept and new ideas. Thank you very much, and see you soon, and enjoy the rest of the evening. Thank you. Bye.
Yep. Thank you very much. Bye-bye.
Bye-bye. So I hope everyone is enjoying so far so good. So I think everyone is waiting for the quick break. So we are having a short break right now, and then we'll jump back soon with the new speaker and the new moderator. So I think I will see you soon tomorrow. So I hope you enjoy the next sessions and the rest of the evening, and this the new speaker and new moderator will continue very shortly after the break. Thank you.
So it's me again, and I'm just here to tell you thank you for being with us from the whole Geekle team. We appreciate your time, that you are with us, and I hope you enjoyed all the previous speakers' talks and even more excited for what our next speakers prepared for you. And during this short break, during you enjoying your coffee or tea or whatever you decided to take, enjoy, I just want to invite you to our software architecture event. It will happen next November, actually this November this year. And yeah, it will be one of the biggest events. It will be the 4th edition we're really proud of. I believe it will be around 20 hours of content there, 35 speakers. And yes, I hope you would actually visit our website and decide to join. I will be happy to see you there. Just use this promo code with a special price, and yeah, invite your colleagues and friends. Enjoy the rest of the conference. Thank you again, and yeah, see ya.
Howdy, folks. Just want to make sure everyone can properly hear me. So if someone can give me a +1 in the chat, either Senya or Nick, that'd be great. This camera's very close. Amazing. Okay. All right, let's get started. Let's share my screen. Okay. Can everyone see? Oh, there it is. Thank you. Awesome. So everyone, I just wanted to open up by saying, so David unfortunately had some issues with Hurricane Ian. Everything is okay, but he's unfortunately not going to be able to make it and give his presentation today. He did say that he would record his presentation and send it out, so you guys can expect that in your mailbox within the coming days. We'll provide a link to his recorded talk. So today I'm here to talk about rapid prototyping on Google Cloud. So a little bit of the agenda. I'll intro myself. I'll talk about my role at Google. I'll discuss a little bit about the 3 Ps that I've come up with for sort of best practices for doing rapid prototyping. We will talk through a mock example of solutioning with a customer, right? And then we will actually dive into some code, and I will do my best to harness my inner Kelsey Hightower and go against everything I've ever learned about doing demos and write some live code on the fly and see if we can get a rapid prototype stood up on top of Google Cloud within 20 minutes or so. And then we'll have some time at the end for Q&A. So please provide all your questions in the chat. I am more than happy to answer all of them. So quick disclaimer before we get started. All of these views are my own. While I do work at Google, I do not represent their point of view. These are practices that I have sort of come up with in my role, and others have within the customer engineering role at Google. But again, this is by no means Google's standpoint. These are personal opinions. So a little bit about myself before we get started, just so you can know why I'm here and sort of qualified to talk about this. So my name is Noah Mercado. I am what's called a specialist customer engineer here at Google. I've been with Google about a year and a half. And prior to that, have had the fortune to wear a bunch of different hats in my career, right? So I sort of got started in software engineering, evolved into architecture type roles. I've done a lot of DevOps work, some SRE work on a private cloud team many years ago. And all of it sort of encompasses in this quote unquote cloud engineer role, which, really can mean anything. But today I'm a specialist customer engineer, and I primarily focus on application modernization, which mostly encompasses serverless and Kubernetes. I'm in the Philadelphia area, so I'm East Coast of the United States. I'm on a team that supports strategic opportunities across the East Coast with our customers on Google Cloud. And you can see on the left here is a picture of my puppy, Bailey. He is a little over 3 years old now, so he's not a puppy anymore, but he still acts like one. So the role of the customer engineer. So in Google Cloud, the customer engineer, at other organizations, it can be called solution architect. But essentially, we act as the technical subject matter expert for our customers on Google Cloud, right? So our role is to sort of, if we think of Google Cloud as a toolbox, all of those services that comprise Google Cloud are the tools in our toolkit, right? And then we use those technical capabilities provided by Google Cloud to help our customers solve their biggest problems and achieve their business objectives, right? So we help put together architectures, we build proof of concept systems, we advise on existing architectures, we help with migration plans, and really help our customers adopt best practices when moving to Google Cloud so they can get the most out of the platform. So the life cycle of a typical customer engagement as a customer engineer. In the beginning, we'll typically do some discovery sessions, right? So there are different maturity levels for each of our customers. Some are completely net new to Google Cloud. Some have been building on us for years. But in this case, we're going to focus on essentially they want to build a net new solution. So we'll go in, we'll meet with the customer, we'll understand what are their business objectives behind this solution, right? What is the actual problem they're trying to solve, and sort of what's the experience they're trying to create for their own consumers or customers. So we'll hold a bunch of discovery sessions. From there, we will take those outputs and formulate some requirements. And then we will look to go into the architecture and design phase, right? So we will come up with maybe a couple of different proposed options of how we can build the system that they're looking to build, right? We'll talk about each of the trade-offs for each of them, right? And then once we land on one with the customer, we will typically take that back and build out what we call a proof of concept or a prototype. So the prototype is sort of that first iteration that is meant to sort of prove out the idea of the architecture that we proposed. These are all the various solution components, and they're typically fairly scoped, right? So we want to solve a particular problem. From there, after we've built the prototype and we've proved out essentially our concept, we will then pass off the opportunity to one of our partners or our internal professional services organization, or if the customer has their own engineering team who's up to par, right, they will take it and they will sort of build it out to production themselves. So today, we're going to primarily be focusing on this third step in our role, which is how do we rapidly develop these prototypes so that we can prove out the concepts that we're sort of proposing to our customers efficiently and quickly? So first, let's look at what is a prototype. Right? So Wikipedia, the most trusted source on the internet, defines prototype as a prototype is an early sample, model, or release of a product that is built to test a concept or process. And when I think about prototypes, right, I sort of think of them as if we picture the scientific method, right? We formulate a hypothesis, we gather some data, we use that data to then conduct an experiment, and then we try to prove out our hypothesis. I really think of prototypes as sort of that experimental phase, right? So we have a hypothesis of X. We can build something that solves this problem, right? And we build a prototype as the experimental phase to prove out to some extent that this hypothesis is true. So how do we rapidly build these prototypes? So in my role, like I said, I support strategic opportunities across the East Coast, right? We work with a ton of different customers, and we need the ability to sort of move quickly in our development efforts. So that way we're not spending multiple cycles, multiple sprints, building out these proof of concept systems, and we're able to deliver value for our customers much quicker. Right? So I've sort of come up with these 3 Ps, like these 3 pillars of prototyping. And in reality, we should be focusing on creating standards, repeatability, and having purpose for each of these 3 pillars. So the first is process, right? It's very important as an engineering team, whether I'm strictly working on proof of concept systems or I'm taking these systems all the way through to production, right? We want to have consistent, repeatable, and standard processes in how we do this development, right? Clear documentation on the toolings that we should be using, the processes that we should be following. Everything should be super discoverable, right? And then we want consistency. We don't want to be re-evaluating or reinventing the wheel every single time we need to deliver a new proof of concept system for a customer. So we want to make sure that in this process, we follow consistent patterns. The second P is platforms, right? So as engineers, right, I am best at my job if I can focus on the thing that delivers the most value. So I focus on app modernization. I primarily cover DevOps, serverless, and Kubernetes-based architectures. So we want to create these underlying platforms so that way our developers, our customer engineers can come in and have this sort of landing zone type concept, right? Things like networking already built in place and consistent services that we can leverage and stitch together where I'm not reinventing the wheel. Same thing goes for my development environment. Right? I want a consistent way of writing code and sort of scanning and testing and linting that code. So standardizing on how we're going to do our development process, as well as the infrastructure that we're going to eventually deploy that code to, is super critical in making sure that we have like consistency and repeatability in delivering these POCs. And the third, and what I think is probably the most important, is packages, right? So this concept of pre-packaging solutions, or what we can call building blocks, that we can later stitch together to create net new systems. So if we look at internally within our organizations and we look at all the different systems that we have, there's a lot of like similar components, right? There's a lot of maybe similar architectures that are in place. Maybe we are frequently doing, microservices on virtual machines in an auto-scaling group that is behind a load balancer, right? So that's sort of a standardized architecture within our organization. We want to create some infrastructure as code building blocks or Terraform modules as one example to sort of package up the different components of these architectures so that way we can later easily stitch them together to create this net new system. So in terms of consistency and sort of standardizing on our tool set, right? So my standard prototyping stack looks a little something like this. I'm definitely not a front-end dev, but I do do a decent amount of front-end work in sort of helping to create these high-fidelity proof of concepts. So I write a lot of Vue.js, right? I'm not a front-end dev. Vue.js is the only front-end framework that I know, but it's what works for me. It's what works for my team. So this is sort of the standard that's been implemented every time I go to deliver prototypes. I'm not going to learn a new framework every single time. Right? I understand Vue enough to be able to sort of leverage it to build what I want to build, but I don't need a professional. I don't need to be a production grade front-end engineer. Firebase is typically my platform of choice, and we'll dig in a little bit into why. But Firebase is essentially Google Cloud's mobile and web application development platform. And it gives us these different building blocks to sort of stitch together these serverless systems. My two primary languages these days are probably Python and Node, with a little bit of Go in there. But I write a lot of Terraform as well to sort of automate each of my infrastructure components. And that way I can make them repeatable when I need to build a new system in the future. And being in the cloud, we want to build cloud native systems. We want to make them portable and repeatable. So Docker is always coming into play, right? We're going to containerize our applications, maybe throw it into Google Cloud Functions v2 or something like Cloud Run, so we can get that serverless container orchestration without having to worry about the underlying infrastructure. So Firebase. So like I said, Firebase is our mobile and web application development platform. And it really helps our customers shorten their time to market with these various app building blocks and fully managed services that we provide on the back end for building web and mobile applications. It's this end-to-end platform that solves sort of each of these different components, right? So we have, I think it's like 18 or 19 different services within the Firebase platform at this point. And they provide functionality like authentication as a service, right? I want to build in federated login based off of Google sign-in, right? So we have essentially an identity or a authentication as a service component that allows you to easily create logins within your application. We offer backend compute. So this comes both in the form of Cloud Functions for Firebase, which are essentially opinionated Cloud Functions. It only supports Node and TypeScript, right? But because of that opinionation, we get a lot of tight integration with the rest of the platform. So it makes it really easy to sort of build these event-driven systems. There's a bunch of other services if you're going to production for things like testing and release management and understanding the crashes of your application. But we won't really get into them today. We're really just focused on the building blocks within the platform. And it really, I think, like I said, it's like 18 or 19 different services, but they kind of fall into these three different pillars. So building better apps, right? We have services for authentication, backend compute. Cloud Firestore is a NoSQL database, entirely serverless. You don't have to worry about the underlying infrastructure. You sort of just flip a switch within the console and you get access to a database. Real-time database is another NoSQL database that we have. Firebase hosting will host your website's static assets. So if I'm building, say, a React or a Vue.js front end, I can just drop my assets into Firebase hosting and I get a full global CDN to sort of replicate those assets around the world. We get cloud storage, services like AppCheck for sort of attesting to the integrity of our applications as they talk to our backend components. And then it's super extensible. So there's these official pre-built extensions that can sort of build on top of the platform. In Firebase, although you can think of it as a platform within a platform. So Firebase is the platform within Google Cloud. And you'll see that there's a lot of overlap with some of the services in Firebase, like Cloud Storage and Cloud Functions, which really, under the hood, they are just the Google Cloud opinionated versions of the Google Cloud services that sort of back them. Right? So Cloud Storage for Firebase gives us some nice interfaces so that our mobile and web applications can directly talk to our cloud storage buckets, which is object storage in Google Cloud. And then Cloud Firestore has an SDK, which allows my mobile So with these various components, you can build full-blown applications that are essentially entirely serverless, right? By sort of stitching them together. So here is a common example. We built a solution like this a few different times for customers where they build a web app that has authentication that allows their users to sort of upload objects to a storage bucket. On the event of an object being updated, that invokes a cloud function, which then takes that, maybe it's an image, right? And it will process it by running optical character recognition through a machine learning model. And then we store the outputs of that text within a database. Right? And then it's super extensible. So you have backend compute within the platform. You get access to cloud functions, but you can also sort of extend upon it with the rest of the Google Cloud services. So Firebase hosting integrates directly with things like Cloud Run for serverless container orchestration. And we'll talk about some of the other integrations as we move through in our mock example here. So let's think through a mock scenario of a customer engineer working with a retail customer. And I just want to highlight, this is an entirely mock scenario, one that I created up in my head. This is in no way something that I'm aware of that someone's actually doing or one of the Google Cloud customers actually doing. I just wanted to sort of think through what is a potential business problem that we can help to solve and how can we quickly build a prototype to prove it out. So here's the problem. So say we have a retailer and they have these brick and mortar stores. And the problem they're trying to solve that they come to us with is they say, how can we better understand our in-store customers' consumer preferences? So these are things like, what are the brands that they wear when they come into our store? Are they actually wearing our brand? Are they wearing a competitor's brand? Are they maybe wearing clothing that's has the logo of a local sports team or some sort of product? So how can we get better insight into the customers that come into our stores so that way we can better tailor our products to them? Okay. So let's build a prototype. So customer comes to us with this problem. We say, great, we have the tools to help you solve this. So let's think through some of our requirements. So what we probably want to do is we want to build some sort of cloud-based system that has the ability to identify brand logos. We want to do some real-time image analysis as folks sort of walk through the door of our store. And we want to be able to identify what is the actual branding on the clothing that they're wearing. It needs to be able to scale to millions of invocations because essentially we have hundreds of stores and each of those stores has hundreds of daily customers that sort of walk through the door. So the number of stores times those daily customers means we got a lot of logos to scan. And this thing needs to be super scalable in the back end. And maybe funding's low, right? A lot of folks are cutting costs right now. So our budget's a bit tight. We want to make sure that this thing sort of scales to zero. We're only paying for what we're consuming. So as the architect for the solution, right? Google Cloud services are the tools in our toolkit. So we need essentially various components to do image storage, backend compute, machine learning model that can actually detect the logo, a database to store our data in. And then we have our other requirements like this needs to be cost optimized. Maybe we need support for a mobile client, right? And it needs to scale. If we look back at the different services we get with Firebase, right, we have services that can cover each of these technical requirements. Cloud Functions can provide our backend compute. Firestore can act as our database. Firestore or Firebase hosting can host our mobile web application our static web application. And we can use cloud storage for Firebase to host the images. We've checked those boxes. And now we need our machine learning model. So if we look at Google Cloud's AI suite, right, we have all the way at the top, we have the highest level of abstraction when it comes to creating these intelligent experiences with machine learning. And then in the middle tier, we have these managed services, which are sort of pre-built machine learning models, which can be tailored to you, but don't take that much effort to get up and running with. And then all the way down at the bottom, we have, I am a data scientist. I'm a machine learning engineer that is skilled in Python and TensorFlow. And I have the ability to create these myself. Right? And we have all of these services like Cloud Machine Learning Engine and Dataflow and Dataproc that help us to orchestrate our data pipelines and build out our machine learning models. So I'm just the dumb app dev guy, right? I help with DevOps and I help build apps. I'm not smart enough to do machine learning on my own. But fortunately, right, we have a managed service called Cloud Vision, which can help us do our logo detection. Right? So I don't have to write any machine learning code. I can just consume this managed service via an API, and then I can get this back and sort of integrate it into my application. So we've checked the box for the machine learning model logo for logo detection. And given that we are leveraging consumable APIs that are hosted by Google, as well as serverless infrastructure to host these various components, this thing is going to scale to 0 when we're not using it, so it's cost optimized. Firebase provides our support for mobile clients, right? And we get that scalability and the elasticity as, say, things like Black Friday happen, where we have more in-store shoppers in our brick and mortar stores. As this solution is being consumed more, our backend infrastructure will actually scale out dynamically and be able to support that load. So here's our proposed architecture, right? So we'll create a Vue.js front end that we will put in Firebase hosting. This will sort of tap into a high quality camera that's running on it's sort of mapped to a web application. And then we will use things like Firebase Auth to make sure that our application is secure. We will have a cloud function, which will sort of run our image that we're processing through our Vision API to extract the logos. And then we can have Firestore as our database, which then will stream to something like BigQuery, which is our data warehouse, which then gives us a whole suite of other options for doing things like data visualization with Looker, building machine learning models directly in SQL via BQML, building custom machine learning models in Vertex AI. But for the purposes of our proof of concept, right, we're just going to build a quick web app that's going to take the image that we send through it, and it's going to run it through the Vision API, and then it's going to show us the logos that have been detected in that image. The rest are more implementation details. Maybe phase 2 of our prototyping, we will focus on that bottom half. But today, we just want to prove the concept that we have the ability to detect logos. So here's the fun part. So let's build out our proof of concept. So we're going to leverage a component that I use nearly daily at this point in my role to rapidly stand up a new Firebase web application. We're going to modify it so that way we can create the components we need to sort of talk to the backend cloud function, run it through Vision API, and then we're going to display the results out to the front end. So I created a new Google Cloud project. So one of my practices that I follow in prototyping is sort of everything is ephemeral, right? I've seen too many times in my career as a software engineer and consultant that what starts as a prototype eventually becomes production. And this is a terrible practice because typically folks will cut corners on prototypes, right? Maybe they're a little bit less secure, or they're not as cost optimized just because we're trying to get it done quickly. So everything I do goes into a net new Google Cloud project that we can then blow away when we're done. And then if we decide to move forward to production on the system, right, we will take it and actually build out in a production grade environment rather than our initial prototyping environment. So I got started just for the sake of time. Essentially, what I did is I created a new Google Cloud project for the DevOps Global Summit. And then I installed or cloned my repository, which I call the POC starter pack. So we have this catalog of starter packs, which are these infrastructure as code modules, which we talked about, which is these are our packages. These are the things that the building blocks that we can pull off the shelf and stitch together and create net new systems without reinventing the wheel every single time. So I will go in, I will look through my building block repository. I see I have this POC starter pack. The starter pack is clearly defined, right? Because we want consistency and clarity and good documentation in our process. So this repository stands up. It has automation for rapidly delivering a new POC on Google Cloud. And it contains things like some Terraform, some bash scripts, a makefile to sort of stitch everything together, as well as like a boilerplate Vue.js front-end application and some starter code for some Cloud Functions. So I cloned this repository down to here. Now the first step so we declare all of our dependencies. We need Terraform, we need the gcloud CLI, gsutil, etc. Right? The first step is to clone. The second step is to essentially run our backend bootstrapping script. This is a consistent script that I use, which essentially will go ahead into the Google Cloud project. It will enable the APIs that we define here. It will do things like create a backend cloud storage bucket for me to host my Terraform state file, create me a service account that I'm able to impersonate to run my Terraform, and sort of create that landing zone in the ephemeral environment. So I did run a test yesterday. That script takes about 5.5 minutes to run. It's really just setting up IAM permissions and enabling APIs. So I figured I would not bore you all while that runs today. So I went ahead and ran it prior to the talk. So we get a Terraform module that's baked in, which has functionality for deploying new Cloud Run services, Firebase hosting deploying Firebase hosting assets, Cloud Functions for Firebase, doing our IAM permissions, creating our service account needed for these backend services to run, etc. So sort of the interface to this is a few different variables, right? So we can specify the region we want to deploy our resources into, which is US Central 1. I can give my application name a name, or it'll just essentially infer the project ID from there, so we don't need to set that. And then I have a couple of booleans here. So if I want to create some backend Cloud Run services, so I mentioned earlier that Firebase hosting actually integrates directly with Cloud Run. All I have to do is flip a boolean here, and I get a starter service in my APIs directory, which just contains some boilerplate code. Right? So it's essentially a hello world API, but it has some boilerplate for essentially enforcing authentication within our function. So we're going to ensure that every request that comes to this backend function has a valid Firebase auth token. So this is sort of just some boilerplate wrapper code that we leverage, and our business logic essentially gets plugged into here. We're not going to use Cloud Run today because I think Firebase Cloud Functions for Firebase serves the purposes that we need. So I can just flip this boolean to false. But we do want to enable our Firebase function, so we're going to leave this as true. The rest of these we can ignore because these are specific things for how to handle caching from our Cloud Run service, etc. So the first thing I'm going to do is open up my boilerplate Cloud Function, which again is just some scaffolding, some code scaffolding, which is hello world. It enforces that all the requests that come through to this Cloud Function, again, are validated. This is written in Node. And then it just returns a basic JSON payload of hello world. So what we're going to do is we're going to install the Google Cloud SDK for talking to the Vision API. So let's go into functions. We're going to npm install save at Vision. So we've installed our Vision package, and now I can import it. I'm going to import the Vision package, and then I'm going to create a new Vision client. And this is actually going to be super simple code. So after we validate our authentication, right, instead of returning just a static JSON blurb, we're going to extract the data. So there's an expected payload of a JSON object, which has a root level attribute of image. So we're going to extract out that image, and that's essentially the base64 encoded image that we're going to feed to this function. We're going to create a new request payload to go back to send to Vision AI, right? And Cloud Functions for Firebase automatically will handle promises for you in Node.js. So all we have to do is return the promise that gets returned from our logo detection request in Vision AI. And that's going to actually just kick the response back to whatever is invoking this front-end service. So now we have our back-end compute written, right? We added essentially, 7 lines of code to sort of act as a proxy between our front end and the Vision API. And now we're going to make some modifications to our front end. So our front end boilerplate code gives us essentially some reusable components to make this thing look a little bit prettier. So we have a standard app bar that I use, which has things like it will show an icon of the image of the person that is logged in. It has a little fake search bar and a little fake hamburger menu. Right? It's all for aesthetics, right? We just really want to prove the concept, but this is a nice way of sort of creating these pretty looking assets using material design without having to put in a lot of effort, right? We just continuously reuse these. So if any of my customers are watching this call, you'll notice that this is going to look very similar to maybe a solution that I built for you in the past. And that's because I use a consistent sort of template for stamping out new prototypes, because it's really not delivering much value to sort of focus on the UI every single time. So we are going to, I did another little bit of homework prior as well, where instead of boring you all with writing the camera component, I wrote a new component that we're going to leverage, which essentially is tapping into the webcam of the consumer device that is running this web application, right? And then it gives you a button to sort of take a photo. And when you take a photo, it's going to grab the frame from the webcam, and it's going to emit the base64 image up to the parent component in Vue.js. So now in our app.view, this is sort of like the main entry point of the application, right? We need to import that new component, and then we will walk through some of the other boilerplate that sort of comes with this. So we will import camera from components / camera.view. And then you can say, this is what came with the repository. So we have some pre-baked logic for handling authentication in our front end. Right? And we can look. We essentially dynamically will load in some configuration for our Firebase web app based off of a environment variable. And then
hey, no, I'm so sorry. Can you please enlarge the font of the code just for a little bit? It will.
No worries at all. Thank you for mentioning that. Is that better?
Much better, thanks.
Awesome. Cool. So we instantiate our Firebase client, right? This is boilerplate. This is going to look exactly the same no matter which web app you're writing using Firebase. Okay. And then in our main application, we are going to import some of the components from our Firebase config. And then there's some logic in here to handle our sign-in with Google. So every rAPPid prototype that I deliver, given that we are Google, we use federated IDP with sort of the Google social sign-in. So that way we get a nice little Google icon, and then I can click and I can log in with my @google.com email address, and I get automated sort of SSO into all of my web applications. Firebase all supports multiple IDPs, right? You can integrate it with Azure AD, with a bunch of social providers like Twitter and GitHub and Facebook, as well as anything really that supports SAML or even OIDC. So if you have an Okta tenant, you can create single sign-on in your application with your Okta users. So we're going to import auth, and we're going to import functions. I need to import a couple of new methods. So what's nice about Firebase Cloud Functions is in the SDK that you use on the client side, there is a method for securely invoking your backend function, and it takes care of everything for you, like the authentication headers, right? You're not actually having to direct to a like DNS, right? I'm not sending up necessarily a post request to my backend endpoint. All I have to know is what the name of the backend function is that I've created, and I can sort of reference it by name in my front end code. And then the SDK with Firebase will handle that secure communication to the backend, invoke the logic, and then pull back down the response. So I've imported my camera component, right? I've defined it in components. And now let's actually embed it into the front end. So we have login with Google. So I have pulled my, oh, I forgot to delete some code from the last one that was already in here. So essentially, I'm importing the camera component, and then I'm saying when it emits the grab frame event, or essentially the picture take event, we're going to pull that event and we're going to send it through my cloud function. And then we're going to do some data cleanup every time I hit the little X to sort of clear the image from the screen. I need to declare a couple more variables. So we'll go to computed. And this is just some data cleanup that we're going to do. And then we're going to define some new methods. Right? The first one is this asynchronous on grab frame. And we've configured our camera component that when that component emits the grab frame event, right, it's going to invoke this function. This function is going to it's essentially going to leverage the HTTPS callable method from the library and say, hey, I have a backend cloud function that's going to be called detect logos func. I want you to sort of pull that down into a local function. It's not actually doing that. It's just giving you the ability to invoke it as if it is a local function. And then we're going to take that local function. This is going to return us a promise. So we're going to await, and we're going to feed it a payload of image equals the base 64 content of the image. Once we get that result, we're going to loop through all the logo annotations that it finds in that image. We're going to push them to a variable. Right? And then essentially we're going to sort of strip out some of the extra metadata out of there, and we're going to display that at our front end. So now I need to make sure my backend cloud function has the name detect logos func. So we've plugged in maybe 7 lines into our backend cloud function. We've updated our front end. And now the Terraform takes care of the rest. So I just run make app. Terraform the make file takes care of that entire Terraform workflow of initializing our Terraform, generating a plan, applying that plan, and this will do things like create our backend cloud function, deploy everything to Firebase hosting. If we've had that cloud run boolean and flip to true, right, it would package up all the services defined in API, containerize them, push them to our container registry, and then deploy them as cloud run services, as well as configure Firebase hosting to sort of dynamically route based off of a path to those backend services. So as this is running, I'm going to move this over here. We should start to see different services coming up in our Google Cloud Platform project. So if I go to, say, IAM, and let's go to service accounts. So we can see that it created a service account for me for the DevOps Summit 2022 web app. And this is what's going to be used for Cloud Run as well as Cloud Functions, which gives those backend compute the ability to send payloads to the Vision API. We can go into Firebase. So Firebase does have its own console. Right. A Firebase project is essentially a Google Cloud project. But you can see it took my empty Google Cloud project and it now converted it into a Firebase project where it's created my application for me. And it's doing things like provisioning my database, packaging up my application, deploying my functions. And then the output of this will be a fully built and deployed web application that has SSL. There's direct integration with GitHub Actions. So the Firebase CLI will actually automatically generate you a GitHub Actions CI pipeline for pushing your web app out to Firebase on pull requests. Takes about 3 to 4 minutes. I guess while we're waiting, any questions? It's a great question. I will leverage CI/CD in my prototypes to the extent where it's sort of automatically created for me. Right? For that example of the Firebase CLI actually will automatically generate me a GitHub Actions pipeline. I also have some standard cloud build pipelines that I use, which are pretty agnostic. Because it's essentially just orchestrating Terraform commands. I've recently moved to leveraging Make. Despite being a software engineer, I actually never wrote a Make file until about 8 or 9 months ago. But since I moved to Make, it has drastically simplified my life. It gives me single commands to run to deploy things locally, as well as I will typically bake because you can programmatically invoke cloud build pipelines within GCP. So I'll have like a make command to say, hey, like package all this up, send it out to cloud build, and let cloud build do everything it needs to do to get this deployed rather than deploying locally. So I have essentially a consistent interface, whether I'm deploying it locally or deploying it via CI pipeline. It's either way, it's essentially just a make command. I wouldn't recommend that necessarily for production, because in production, you're doing things like running unit tests and integration tests, et cetera. But for these purposes of just, hey, quick and dirty web app, I got to get it out there. I'm just trying to automate the deployment on code changes. I think CI can make sense there. This is taking a bit, but I fortunately did a cooking show style where I have a pre-built one already deployed. So I can come to hosting. Right. From that Terraform command, which is essentially wrapping a bunch of Firebase commands, etc., we get a fully deployed web app, right? So you get a custom DNS name, which maps to your project ID.web.app, as well as your project ID.firebaseapp.com. From there, we can view the web app, right? So because I'd already played around with this demo version while I was testing, it skipped over the sign in because I'm already signed in. But let's do this. So we can show off the auth functionality. Let's do new incognito window. And let's navigate to my web app. This is that reusable, app bar component I had mentioned. Right? So the first thing I do is, and this is just pre-baked in the template that I use, I get a login with Google button. I click login with Google. It takes me to my Google sign-in. So I'll sign in with my google.com email address. Right. So you can see it's logged me in. It's actually pulled from the OIDC token that Google OAuth kicks back. Right. We get my image, and then I can start the camera. So I have a couple of hats to demo, right? But essentially, so got to rep my owls, very proud Temple alumni. So let's take a image of my Temple visor. We'll do scan for logos. There you go. Internet's a little slow today. It took a second, but you can see it identified the logo as Temple University, my alma mater. We can do a second one. So I have an Adidas hat. Let's scan for logos. Found the Adidas logo. And last one, my Philadelphia Eagles, go Birds. This one was picking up some weird, it kept picking up Coastal Carolina University. Let's try it again. Let's do the polo. Images are a little blurry. Let's try Eagles one more time, but I think y'all get the point. Yeah, incorrect. So let's leave it on a good mark. We'll do Adidas one more time. Cool. So just like that, right? Starting from scratch, we had a couple of components built just for the brevity of the demo, right? But this is what a typical flow will look like as customers come with us with problems, and we will help them sort of rapidly iterate on these ideas, leveraging different services within the Google Cloud Platform to rapidly build out new proof of concept systems. Any questions? Cool. Ksenia, I'll follow your lead. Cool. Is Omar up next? There we go. Hey, Omar.
Hello, Noah. How are you?
Good. How you doing?
Fine, thanks. That was a great chat that you had there.
Thank you.
Very interesting. Thank
you
you for sharing.
Well, best of luck. Looking forward to yours.
Thank you. So let's begin. Okay. So, well, welcome to the DevOps Global Summit 22. Well, I think I'm the last one, so I'll close it with something more soft. You know, when Geekle reached out to me and share with me the information about this event and if I wanted to participate, I thought about what the topics were and the ones that were already reserved, and I thought about giving my talk a little bit of a more general view about monitoring, about observability, that it's more aligned to the soft skills part of the work, not so much of a technical stuff. So I'll present myself a little bit. I'm Omar Chemes. I'm from Argentina. I'm working at CloudFront right now, but I've been working for different companies that are in the entertainment industry. And well, I specialize in two things really, CDN and also team building. I know it's hard, but I'm more of a generalist. I know a little bit about everything and not very specifically about something. So, well, let's start. I hope you enjoy this talk. So this is a little bit of evolution of IT resources. When I learned that I was going to be in the beginner's track, I changed a little bit the approach. So I wanted to tell you about the evolution that we had over the past years in the IT areas. So as IT resources, at first, like in the 80s, 90s, we were isolated individuals. We were not an area itself. We supported other areas. There were a lot of proprietary products. We had IBM, HP. We had a lot of companies that used proprietary software. So you specialize on each, and jumping from company to the other one was hard. After that, maybe with the web, when the internet and the web 1.0, we started to have an IT area. There were few resources and they were doing a lot of different things. And we started with the expansion of knowledge with the open source solutions and globalization, and of course software that is globalized. Later on, maybe in the 2006, 2007, we started to get, or 2005. We got it. We IT area turned into an IT department, IT division. There was a CTO position that existed on every company. There was a wider range of IT-related positions and responsibilities. You have the DBA, the function analysis, the DevOps, the project manager, the developers, the sysadmins, the managers, a lot of QA, a lot of related roles. And we had teams per technology, and we started sharing the knowledge in documentation over the internet, and it became easier to share. And after that, I think like in 2010, the CSO position, the chief security officer, appeared, spread among companies. IT resources were required by every division of the company. It was not division itself. We had the tribes, squads, chapters, topology. That's the Spotify approach to how to work with teams. There was collaboration of different roles on the same project, and the knowledge started to be continuous. We have to now learn everything and keep on learning because everything is getting updated so much. After that, the CIO position, Chief Innovation Officer, spreading. This is more of an current status. Their IT objectives conversation now include marketing ideas, business needs, and customers' feedback. There's a shared vision and transparent short-term goals, team topologies that is changing the way we set up teams, and business knowledge is added to IT. Now I will try to compare this with what was happening in the IT world in the technical part. We first had mouth-to-mouth support, sequential programming, on-premise servers. We had no internet. There was linear development. That's when IT was isolated. Then we moved to mail support, stream programming, data centers, Web 1.0, infrastructure networking, only monitoring. And after that, it evolved. We had the support ticketing systems, the Web 2.0, software as a service, agile methodologies, API monitoring. So we started to add more and more complexity to IT. After that, object programming, Web 3.0, DevOps with the social networks, and a little bit of how we are now. We started to use the DevOps methodology, cloud services. The monitoring started to be of the whole platform, whole solution. We started to work more on automation, and the support started to be via social networks. And currently, we have a customer-centric development, business-oriented objectives spread across the company. The DevSecOps is something that you hear a lot. We are, as you heard all over the talks today, we have serverless solutions, containers, Kubernetes, customer care-oriented monitoring, and infrastructure as a code. So now I will talk about monitoring. I want to talk about a mindset that I think that was covered all over the talks today, which is collaboration. And for that, I'm going to explain a little bit about what are DevOps objectives right now. We have automation, we have continuous improvement, we have customer-centric action, and cross-functional teamwork. So as I said before, first we were isolated individuals, then they were the developers team, the sysadmin teams, and now we're in a cross-functional setup of the teams where a lot of roles work together as a whole and collaborate for an objective. And the teams can share a lot of different ideas. So going back to the collaboration mindset, the DevOps culture is about collaboration. It's about shared responsibilities. It's about transparency, and it's about communication. And this is where we are at right now. Here I will say some quotes of technical directors. My approach here is just to explain a little bit about a little bit more about what collaboration is. So here they are. We need the whole squad, every player of the team, if we are to be successful. That's Pep Guardiola, technical director, now for Manchester City. And here we have an Argentinian that it's while the opponent has the ball, the whole team presses, always trying to cut off the play as close as possible to the opponent's goal. When we get it, we'll look to play with dynamism and create the spaces for improvisation. So we are now in a place in IT where collaboration matters, where collaboration among companies matter. It's not only that you belong to a team, that you belong to a company, and you talk to your colleague and you work things out, make solutions, innovate, create new software. There are a lot of companies partnering with each other that have different software, different hardware, but they sometimes work together to innovate and to reach new places of evolution in the IT world. So this is an example of a team, soccer team. This is PSG from France. And what I'm trying to tell you here is that they have a collective objective, but to accomplish this, everyone, each position has an individual objective. They all have their different roles and the different ideas of what they have to do, earn the different directions, but they work for a collective objective, and that's what the evolution of monitoring from my perspective is all about. Individual objectives need to be lined up with the collective objective. For example, in this case, in a soccer match, the collective objective is to win a match or to win a tournament. But maybe the goalkeeper has an objective of not getting goals into their side. So, and we have the midfielders that want to pass the ball. That's the objective to the ones that are in the part where they have to score the goal. So this is an example of what happened a little time ago. One French program showed what the passes were between the players, and you can see that in this case, one of the players didn't give passes to the other ones, and now those two are the top league scorers. So it means that collaboration is key here. So here, there's a summary of that collaboration versus a single-sided. You can exchange knowledge. You can transform an individual objective into a collective one, different perspectives of the same subject, or avoid issues that come from miscommunication and faster solving. When you're single-sided, you burn out due to time spent solving tasks. You're not aware of the context or company changes. Achievements are not recognized. And you work one task at a time. So how do you use this collaborative mindset with and you apply it into monitoring? I think monitoring as to be in a new place, in a place that you need to really understand the customer. So I call it customer care monitoring, and it's applying marketing and business analysis to the classic monitoring of your service. It's important to have active learning, learn what your customers are expecting from your service product. You shouldn't stay with the technical part or the technical perspective of what your service is. Of course, if the database goes down, you will probably have issues and the customers won't be able to use your platform. But you also have to think with a wider perspective and not only focus in those big issues. You need to monitor every part of the platform, and it's important to learn what your customers are telling you. So in this case, what I would like to share with all of you is that I think that we're evolving to a place where we are collaborating better with business and marketing areas, and the information that they gather is also information that we want to have, of course, in a summarized way. We are not people from marketing or business, but we need that data or a summary of that data to do the best monitoring that we can. So we also need to know our offering. We have to take time to understand what the solution provides to the customer client. So you can test it yourself and see. In my case, I work for a lot of video applications. So when you have a video application, as a person that is part of the company that makes it, you want to try to download it, test it, see if you get any issue, if everything goes smoothly. Just trying to see it from the perspective an end user could have. Also, target audience. You need to know the demographics and behaviors of your customers. Client. It will be great for you to know which customers your product is aiming to, and of course, get precise information about what the business wants to achieve, where you should focus your efforts, monitoring what. So the monitoring ultimate goals for me, it's a proactive product service analysis. You need to, and this is an evolution that came with the new softwares and the new methodologies, where you don't work reactively, work proactively, trying to keep the issues from being shown to the customer. But you don't need to only work on that. You should aim to detect any kind of divergency in the expected flow, in the back end, in the front end, and in every where that IT is used. You also now, and you heard about this in the talks, you need to, of course, concentrate also in security, and the monitoring can sometimes be focused on infrastructure, but you need to focus on the security also. It's a critical thing to add, a critical feature to add to your monitor to do threat detection analysis. And of course, you'll need to continue analyzing the tools that you have to monitor, because the market changes all the time, and the market changes all the time, and you want to keep yourself updated with what you can check in with your monitoring. Also, you need to automatize everything that you can. There are a lot of issues that you encounter when you monitor that can be automatically fixed. In easy example could be the auto scaling that you of course know that you can trigger with metrics the auto scaling of your infrastructure. And this is one kind of monitoring that you're doing, because you're monitoring what's happening with your infrastructure and if it's reaching the limits. And that's a good example, but that of course is something that we all do right now. And we need to be specific on the automatization that we do. This is not something that is mandatory or something that you need to resolve the solution. You maybe want to automatize the notification. We have now the WhatsApp connections, the SMS, email, Slack. Maybe you have the limit to automatize the notification and not do a task over it because it needs to be manually done. So those are different kinds of automation that you can have in your monitoring. And what complements monitoring? Observability. And this, I recommend to use the same mindset as right now, to collaborate with every area that makes use of the work you do, directly and indirectly. In this case, observability will be better if you have more information. If you sometimes I know that it's hard for companies to invest in saving data. Sometimes storage is not cheap, and eventually if you save a lot of data, a lot of historic data, it will cost. But data is the key to the moment that we are right now, to the present, with more data and all the VI, for example, implementations that are being done. Companies are learning a lot about the customers, about their needs, about the failures that the products have, and how to improve it, and also how to customize things better, personalize. So with all this data, you can assist the teams in achieving standardization, which is important, because today we have a lot of different devices that can be used to open apps. We have for example, the home automation right now, and as you know, there are a lot of companies that are doing these products, and they are not near as compatible with each other. There will be a time that maybe they are all compatible with each other, and you don't need to stick to with a brand like Hue from Philips or Xiaomi to have your home automatized. So with more data, you can assist on achieving standardization, and you can use this data to assist in global standardization matters. You should make area focused reports if you have a lot of data from observability. Every area needs to see the benefits of doing that. Mainly a lot with the BI. So you could make area focused reports and try to assist each company area, even marketing and business, even accountability. Depends on what your service or platform is on. And of course, you need to prepare the results for business decisions. This is a part of what we have right now. A lot of startups come up and then disappear. A lot of startups become unicorns. So it really depends on, of course, the need of the customers of that product and the reliability on them. So if you do observability right, you can prepare the results of what you have and assist the business on taking the decisions that they need to have to create a better solution. And also I would like to talk a little bit about budget analysis and continue using the mindset proposed before. This is what I talked about collaboration a lot at first and about the evolution that we had. And so when you think about budget, mainly in cloud, you need to think, is our platform 24/7 filled with customers? If not, could we downgrade a little bit our infrastructure, our databases, or at the time that we don't have so many customers? Do we have special events where we can, if you know that you have a hot sale or Black Friday, you may want to reserve servers for that, and maybe you can do that from a lot of time before, and maybe you can get an extra discount on that because you know how much servers you will use as a base. Is our platform using microservices? Are the servers optimal for that specific service? So one of the things that I do for budget analysis is to check out what the server, what's in the server, what software or what applications are in the server. Are they using more RAM? Are they using more CPU? If they're using more CPU than RAM, do I have the best CPU RAM sizing there, or do I want to change it? Do I want to go serverless to optimize costs? But can we run things from there? Sometimes going serverless means on refactoring. That's a bad word for some companies. You need to use special programming language and people that knows about it. So will it be better for us to do something like that? Is my service auto-scalable, which everyone already is thinking about? Do developers work only in daily hours? Maybe you have a lot of environments, test, staging, but your developers work only on work hours and not over the weekends. Maybe you can shut them down for the time being. Are we archiving information that's not required to be at hand anymore? That's another thing that you need to think about. Like use AWS Glacier solution or some compatible solution like that. Maybe there's information that we don't need anymore. So the important end to this talk is just make your company leaders involve you in what's happening with the company, in the vision and the mission, in the short goals that they have, the objectives for the year. Just look for transparency and communication about that. You don't need to be a marketing specialist or a business specialist or an accountant. You just need transparency to monitor and observe what the platform or product or solution that you monitor is and what's and how's better to do that. If you have business information and information from marketing teams, you can just tune up your observability and your monitoring and your budget just to reach the goals, the same goals. So, well, I think that's it for the moment. I thank you. I know that this is not this has not been a technical talk, but it's something that I wanted to share of how the evolution of IT and specifically how to think about monitoring and about budget and about observability. I want to apply today. So thank you a lot. So yeah, let's see if we have questions. Well, thank you for the question. Yeah, that's one of the things and the worries that I talked about before. It's correct that you need to find a balance of those metrics. That's why I have an example of something that we did over before at one of the multinationals that I've been part of. That in the CDN perspective, we gather data, and of course it wasn't cheap because CDNs are having requests all the time, all day long. But what we did is we had a person that specialized in BI and made reports that assisted the business with that metrics. So what is important, and this is the whole idea of this talk, is it's important to make those costs count. If you show what the regions are doing the more requests, what the contents are being the most play, what countries are the ones that are viewing more your content, what states have the more buffering, and you want to fix that because the customers are having a bad experience. Every data like that, you can put it in a BI report, and I think that's one of the ways that you can show the business side that the cost of storage is something that balances with the values of what you get after analyzing them. I don't know if there's another question, and we can chat about that via LinkedIn. You can reach me out. So the top 3 mistakes I meet regularly. Well, this is also about what I talked about. I think that isolating the developers and the DevOps and the people that make or create their product from the business objectives is wrong, and I see it all the time. That's one of the things that when I enter a company, I try to work out. I try to listen to what the business says, what the account managers are saying, what the marketing people are saying, what the customers are saying. So I try to gather that information and implement tunings in my team to just work on that. So that's one of them. The other one is one that was mentioned before, that sometimes business doesn't see the benefits of having log collection, and I explained that before. It's really important to get a fine-tuned production or solution that then the customer enjoys without issues. And third mistake that I made regularly is, and this is something that happens in all companies, is the changes in priorities sometimes are on a daily basis, and you're focused as a developer or as a DevOps or as a sysadmin, is somewhere, and when you have a change in the priority, your mind gets out of focus, and you need to rearrange it to rework what you're doing or change your direction completely, and that's lost in that makes your brain get lost a little bit. So you need to work with the business, just to tell them, just try to prioritize things only with try to reprioritize things only if they're an urgent matter that is affecting the customer. I don't know if that answered your question. Yes, of course, you can automate the archiving of the information with lifecycle rules. AWS is pretty ready for that. And for example, I haven't worked a lot with Azure and Google Cloud, but I suppose that it's the same. Yes, you can automate this with lifecycle rules, but you need to just understand what you're saving, because I have seen in the past and in previous experiences that maybe you're saving things that nobody needs. And then when they're telling you, why are you, okay, this cost is minimal, but what are you saving there? And you realize that there was nothing useful there. It happened to me just recently that I got a message from someone that said, hey, we have all of this data here that it's storaged. This was in net storage from Akamai. Do you know why we have it? And I said, well, I know that we have it, and we don't use it, and we haven't used it for a year now, and we won't use it in the future. So it needs to be deleted. But no one wants to, confirm that. So just think about what you're saving before creating and who needs that before creating those lifecycle rules. Well, observability is a complement of monitoring. Observability is, as I said before, it's more about data gathering and data analysis, and you use that to find more in-depth issues that the real-time monitoring can achieve, or the historic monitoring can achieve, because you shouldn't make your monitor something too big that you have too many things there. You need to narrow it down to what the customer really wants you to take care of, and then observability will work in the back end of that as a more in-depth analysis of what's going on with your platform. But you shouldn't put all the eggs in a basket, in the monitoring basket, because you will get lost. You will receive millions of emails about what's going on, and you won't see the issues when they come because you have too much information. So that's why observability behind that, it's a proper way to analyze it. Use more like things like Splunk or Datadog or something like that. The other ones, more for monitoring, you can use Grafana, Zabbix, Nagios, a mix of that. Well, all the monitoring tools that they are out there, but it's a different approach that you need to have. So, thank you. Is there any other question? Thank you. Thank you. So,
yeah,
okay,
thank you so much.
I really hope that you enjoyed this talk. As I said before, I know it's more soft skill oriented kind of approach, but I thought it would be a different kind of perspective than all the technical one that we had, that were pretty interesting, if I say so. So I really hope you register your for second day, which is more a harder track to follow for career persons only. Thank you so much for assisting and spending the time on this call.
Yeah, thank you so much for joining today, Omar. Yeah, we'll hope to see you on our future events. Good luck.
Thank you. Bye-bye.
Bye. And right, folks, that was actually the end of the DevOps Global Summit 2022, of the first day of the DevOps Global Summit. So I hope to see lots of you tomorrow, as we'll have much more. We have like 4 blocks instead of 3, and we have more hours of amazing talks ahead of us. And so, yeah, we have a promo code for tomorrow. So if you don't have a ticket, you still have time to get yourself one. And yeah, like, see you tomorrow. And thanks for joining today. Bye.